Turn-based RPGs. We are going to go over making a setup for a turn-based RPG. As you can see here, we have a RPG encounter. The enemies hit us, it's just randomly hitting us. And then we have a list of abilities for our characters, and some abilities have criteria where this one can only target the knight, and then other ones can only target, for instance, this revive, a character with 0 HP, healing can only target things that aren't at full HP, and so on and so forth. This light attack can just attack anything it wants. The abilities themselves will be fully scriptable, entirely up to what you want to do with them, and generally it's going to be a very customizable, very fluid system to make your RPG in. So, without any further ado, let's get started because there is a lot of work to be done, and today we're going to get started setting up the ability components and the attributes for our turn-based characters. Here in an entirely empty project, we're going to be getting started. The finished project files, both for the entire series as well as each individual video, will be linked down below in the description as always for patrons and YouTube members. But for now, I'm actually going to make a little folder here for our TB RPG, that's turn-based RPG, because we're going to need to make a lot of stuff. And we're going to get started by making a actor component. So we go in here, make a actor component, and that will be our ability system component. And that's going to hold everything to do with our ability system. A lot of this series is going to be setting up a turn-based ability system. It will be very heavily inspired by Unreal's own gameplay ability system, but this will work entirely within Blueprint, and it will specifically be geared toward turn-based abilities, whereas the gameplay ability system that Unreal provides you with is more about real-time action abilities. So let's open that up, just so that we have that to access. Eventually, this is going to be one of the two central points of this system, the other one being the turn-based battle scene that we're going to be making. For now, this is just going to stick around for a bit, and we'll make another thing here in Blueprint. We're going to make a structure, and that structure is going to be called attributes. So instead of just adding a bunch of floats for like max HP and minimum HP and all that kind of stuff, we're going to be doing all of those combined within one attribute so that we can easily read and write from that and pass it around easily. So an attribute is going to have a name. So that's going to be a name variable. We'll call that just name. And then it's going to have a display name as well. So the name will be for internal use only. That's a name variable that's very optimized so that you can compare them to each other, and they aren't as expensive as like string compares would usually be. The display name will be what you actually display in your UI and that kind of stuff. And that'll be a text so that it's also translation friendly. Then we need to give it the stat values. And for that, we're going to make another struct. So let's go ahead and make another Blueprint struct, and we'll call that just like stats. And in here, we're going to be adding a whole bunch of floats. So we'll start with the minimum value, and every one of these is also going to have a modifier. So we'll also have a min value mod for the modifier. That way we can have a base value, which minimum value would be 0, but maybe we have a certain gameplay effect that while it's active, the minimum value is at least like 20. So we can set our modifier to being 20 when we apply that effect, and then take away 20 again from the modifier when we remove the effect without actually affecting the base value. And we're going to be doing that for the max value of everything as well. So max value and max value modifier. And then finally, we also add in the current value, because obviously that is the most relevant thing to do. And current value modifier. Now, if we were doing this in C++, we could actually add in within this struct functions to just get us the combination of these two and these two and these two. As it stands, we're going to do that as part of the ability system component instead. But now that we have these stat attributes with all the floats, we can go back into the actual attribute struct that we made and add in the actual stat. So that'll be of the variable type stat that we just made. And if we then go into the default values, we can see the name is the default, which is none. display name, which will be empty, and then our stats. We'll set the default value for things like the maximum value to like just 999, so we don't have to put that in anytime. Also do that maybe in the normal max value, and then the modifier will be 0. So we don't have to do that every time we add in a new stat, because likely the max value for most stats is going to be pretty high. And then the current value, you can give it a default value as well if you want to. For now, I don't really care that much. So back in the ability system component, now that we have those structs, we can make a variable called attributes. And that will be of type attribute, the structs that we just made. And coming over to the right side here, we're going to make that into an array. So now we have an array of attributes. And the way that this is going to work is when we want to get an attribute out of this ability system component, we're going to be doing that based on its name. This, once again, is a situation where C++ might be able to help you a little bit more, because you can write like custom finding operations for your struct in an array. We're going to have to do it a little bit differently in Blueprints, but we can just add in a attribute here. Let's say the name will be HP. Display name, let's call it health, and then the stat will be 999 max value by default. Let's actually set that to 100, and then it'll also start at a current value of 100. The wonderful thing about doing it this way is that it is very flexible which stats you give to which characters. We're not hard coding in a bunch of variables inside of the ability system component class itself. That is just everything is going to have HP, and everything is going to have MP, and everything is going to have stamina. Maybe certain enemy characters don't need MP or stamina, so we don't need to give it to them. Or maybe certain enemy characters have specific attributes that only they need, and your player characters definitely don't need to worry about that. Every single instance of your components can have its own set of attributes, and as long as you use the same name for things that are the same, so everything that's HP should be called HP, you can easily find it based on their names. So let's make those functions to get the combined minimum, the combined maximum, and the combined current value based on the name of the attribute, because that is going to be, again, the central thing that everything in the end comes down to in the combat. It's either increasing or decreasing attributes. That's what pretty much all your moves are going to be doing. So let's add a function and call that getAttributeMinimum. And that will take in as an input just the name of the attribute that we want to get. So that'll be a name variable. We'll get our attributes array that we have here, which you might as well expose as well, because you're going to want to be setting this on each character that you add this component to, obviously. But this array will for each loop over. And then we just split this structure up in. And then we compare the name that we give in to each and every one of the names that we have in the array. If we find one, what we do is we get the element stats, we break that. And there we have the minimum value, the maximum value, and the current value. So once we find whatever name is equal to the name that we give in, we will simply return. In this case, we're getting the minimum value, so we get the base minimum value plus the minimum value modifier, and that will be our return value. And this is quite as easy as it gets. The moment it finds it, it's going to run this return node, so it's not going to even loop over the rest of the array either. We'll be fine, and we'll get the number of its current minimum plus modifier. So for this, I like to call the output here min value, and then add in with mods, just to make sure that it's clear that this is with the modified value applied. Now we can just kind of copy this over. We can get attribute max, and we just put in the max values for both. And of course, we also do one for get attribute current. And we suddenly have our three functions that we can now use anywhere that we want. We give it a name of whatever we're trying to find, and we get back its value. Now, the way that we're going to be editing these will be with gameplay effects. Again, very much based on Unreal's gameplay ability system, which we will make a little bit later down the line. For now, I think what we want to do is we want to make a character for our turn-based combat. Now, going into Blueprint class, you can just make this a character or a pawn if you want to. The thing is, we're not actually going to be possessing these, because we will be possessing a manager object that gives the actors themselves tasks like, hey, you do this ability now, you do this ability. So the player controller isn't actually going to be possessing any of these characters, because we're going to be controlling multiple at a time, because we have like party members, right? So you can just make this an actor, with the caveat that that is assuming that we don't need to do any like AI movement stuff. Because if you do want the characters to like actually walk up to each other, it might be easier to make them characters because they'll have a character movement component. For the way that we're going to do it, everything is going to just be static, very much like classic Final Fantasy style. So we're just going to make them basic actors. And we call this BP turn-based character, which is maybe a bad name because it implies that it is a character class, which it isn't. So you know what, let's actually call this turn-based actor. Just to make sure that it's clear what this actually is. In the turn-based actor, you can do whatever you want with this. I'm just going to simply be adding a skeletal mesh. In the preview at the start of this video, I showed you a couple of characters with meshes from the Paragon set that Epic provides to people. I'm not going to be including those in this project because those files are fairly large and I don't want these project files to be like 20 gigabytes apiece. So we're just going to be using the default mani instead. So we'll just do skeletal mesh, set that to the mannequin, make sure to rotate it in the proper forward direction so that it matches the X being forward. You can maybe see like the red line, that's the direction that your character should be facing forward in. And then we'll use the animation blueprint for mani as well. Now, these don't even necessarily need collision either, because obviously, again, they're going to be mostly standing still and just playing animations and playing some particle effects, and they're not going to be moving around, they're not going to be doing any collision checks, so you don't even need to give this a collider necessarily. Again, maybe unless you want these to actually be moving around with like AI stuff, in which case they might benefit from having a collider. The more important part is adding in our ability system components that we made. So we're going to be adding that in. And you can see in its attributes, we already have the basic attribute that we added in, being the health, because effectively everything that's going to have one of these components needs to have an HP stat. So that just comes pre-loaded in, but we can very much just give this, because this is now the player. Well, it's actually not the player yet, it's just the base pawn. But we can give this one specifically now MP, and if we make another one, it's not going to have MP yet, because that's specifically something we added to this version of this blueprint, this component. But we're not going to be adding MP to this yet, because I want the MP to only be like a player related. So let's just actually do that. Let's make a separate player and enemy pawn hierarchy. So we can right click on our turn-based actor and we can say BP player actor, and then another child blueprint of the turn-based actor again, and that will be BP enemy actor. Now, this just works inheritance-based as you would expect it to, so we can add a skeletal mesh, give it a different mesh if we want to, so maybe like we give it this mesh instead. And then, because this is the player, we want to actually give this one MP. So we add in an attributes, we name that MP, we give that a max value of 50, and then its current value will also be 50 by default. And then you can make all of your individual characters, like your Cloud, your Aerith, your Tifa, whatever, as child blueprints of this one. And the same thing with the enemy actor. We can give that whatever mesh that we want. As for now, we'll just do the Quinn mesh, and you can make child blueprints of this as well, with different skeletal meshes, with different animation blueprints, with entirely different components onto it as well, if you want to. So you can make all your enemies of this. And that is the basic setup of setting up our ability system component that now exists, and we'll have some attributes to work with. Now, this is a fairly fundamental setup part, so that's why I really wanted to take the time to make this into its own separate video. We're gonna kind of start getting a move on with hopefully getting something that is actually like functional and works with stuff really quickly in the next video or two after this, We start implementing the gameplay effects to change these attributes, and then gameplay abilities to apply those effects. We have made a ability system component and some attributes to work with in the first setup video to this series. Today we're going to go ahead and make our gameplay effects, which will be changing up these attributes. There's quite a lot to this to make this in a scalable and flexible, malleable way, so let's immediately get into it. For this, we're going to make a new blueprint, and we're going to go down to all classes and make this a basic object. There's no reason for this to exist in the world as an actor, so we're going to make this just as a basic object that applies itself and sticks around for as long as it needs to stick around, and then deletes itself. And we'll call this something like turn effects or gameplay effect. I'm trying to give them somewhat unique names compared to the actual gameplay ability system because you might get confused otherwise. So this is specifically a gameplay effect that gets applied within the turn-based system. So let's open this up. And here we start with making a new custom event, which we'll call apply effects. This is just the setup, kind of the begin play for our gameplay event. Because this is a base object, it doesn't have a lot of stuff like tick and begin play or anything like that. It's very bare bones. The reason that that is a good thing is because it also means that the memory overhead and the constructing of it is a lot faster than making an actor would be. So here when we apply the effect, we need to know what type of effect it is. In my example project, I have 4 types of effects, which are instant, 4 turns, which is just for a set amount of turns at the beginning of every turn, apply this effect. Then infinite, which is just as long as this is around until it's explicitly removed, apply this effect. Temporary is mostly for the modifiers. You can use them on the base stats as well if you really wanted to, but it's an effect that applies itself and then de-applies itself whenever it's removed again. Hopefully it'll become a little bit more clear if it isn't yet as we go. For that though, we do need to make an enum type. So we're going to go into Blueprint, make a new enumeration, and we'll call that the effects type. Open that up, and we'll add our new enumerators, all 4 of them. We're going to make this instant, 4 turns, infinite, and temporary. With that made, going back into the turn effect, immediately what we do is we create a variable for the effect type, and we'll make that of type effect type. So we type in effect type as an enum. We make that instance editable, and then also on the right hand side here we expose it on spawn, because whenever we create one of these effects, we immediately want to be able to give in, hey, what type of effect are we dealing with here? And then we pull that in and we add in a switch node for that. So all 4 of these are going to do something slightly different, but in the end, all that they do is starting with actually applying the effect. And for that, we're going to make a function and we'll call that do effect instead. So apply effect is going to run do effect, and we need to have a couple of things set up here. So the effect that we're going to be doing needs to have a target. We need to know what the target is that the effect is going to be applying to. So we make that as a variable and call that something like target component. Because we're going to be not targeting an actor with this, we're going to be targeting a ability system component, which will also set instance editable and expose on spawn. Before anything else, we want to get this, right-click it, and turn it into a validated get. We want to make sure that whatever ability system component we're trying to apply this to is valid, that it exists. Because if it doesn't, obviously, we're not going to want to do anything with it. Then, from that target component, we're going to get the attributes. And just as we did before when trying to get attributes, we're going to for each loop over them. If it's valid, of course. And we're going to be trying to find from this split structure pin the matching name to the attribute that this effect is going to be applying to. So we also need to add a variable for attribute to effect, which will be a name, which again is going to be exposed and exposed on spawn. And that is what we will be comparing to here. So we're going to be finding the attribute in this set that we're trying to adjust. Now, if this attribute array doesn't have any attribute with this exact name, it's just going to do nothing. which is fine. But when it does find it, we'll go into a branching node, and then we need to decide, hey, what are we actually going to do with this, right? Which stat are we targeting to begin with? The minimum value modifier, the maximum value, maximum modifier, the current value, or the current value modifier. So for that, we need to make another enum, because we're going to do the exact same thing that we did before. We're going to make a switch node. So we go into Blueprint, we make an enumeration, and we call that the target stat. And opening that up, we effectively just add all the things that we have there. So min value modifier, max value modifier, current value. Maybe typing value for every single one of these is unnecessary now that I think about it, but here we are, and max value modifier. So this is going to be the enum that we decide that with. Going back into the turn effect, we obviously need that to be a variable. So the target stat will be of type target stat, which once again, instance editable, exposes on spawn. We get that, and we add in a switch on target stat so that we get a switch node with all of those options in it. Now, this is a little bit of work that we're going to need to do here. So bear with me. We're going to make a new function again, which is going to take in the current value and then calculate the new value and output it for us. So we'll make a new function and call that calculate new value. And for this, we're going to need yet another enumerator. We're almost done making new enumerators, but we just need a couple of them because there's so many different things that a gameplay effect can do. It can affect a number of different stats. It can have a number of different rules that it needs to follow. And now we need to make one for the math rules that it needs to follow. Does it need to add? Does it need to multiply? Does it need to override? Does it need to divide? You can also make one for subtraction, but subtraction is just kind of like inverse addition. So generally speaking, we don't add a specific one for that, but you can. Either way, you go into Blueprint, enumeration, and I call this one effect math, because it's the math that we do for the effects. So in this case, what I did is I just have add, multiply, divide, and then override as well, because sometimes you want to just specifically say, hey, this is going to be the new value of this stat. I don't care about anything else. I don't want to just add to it. I don't want to like do multiplication. I just want to give in whatever value it's going to be now. If you want to add in a separate like subtraction, maybe like exponent, whatever, you can add as many of these as you want, obviously, into the enumeration. We're going to stick with these four for now. So, to nobody's surprise, we're going to make a variable for that, which will be the effects math, which will of course be of type effect math, going to be exposed on spawn, and we're going to be using that here to run a switch statement with. Let's add in a variable as well for the magnitude of the effect. So that's how much we're going to be adding, multiplying, whatever with, right? So that will be the magnitude, which will be a float value, which again, we're going to expose on spawn because pretty much everything is going to be exposed on spawn, okay? We drag in that magnitude and we try to add to it. So we take this and then we hook this up to the beginning of our function to make it an input. And we'll call that input old value or current value, whatever you prefer. And then if we're adding, we return this, which we'll call new value. If we're multiplying, obviously what we do is we take the magnitude and then we multiply with the old value instead, and then we return that. If we are dividing, I think that you know what we're going to go with. It's important that you take the old value first for division, because the order of these does matter for division. So it's old value divided by the magnitude, which is going to be the return node for division. So hook that up. And it's kind of neat because for override, we don't even need to do any math. We can just say, hey, the magnitude is just going to be whatever the new value will be, right? This is the basic setup for this function. It works. I'm going to future-proof this a little bit because sometimes we want to know what the absolute change in the value is later down the line. And we can either come back to this function later to add that back in, or we can just add in a couple of extra nodes right now to figure that out. So I'll make a variable here. We'll call that absolute change. This doesn't need to be exposed for once. And on every single one of these paths, before we do anything else, we're also going to be setting the absolute change. So just add in a setting node for absolute change between the switch and every single one of these returns. And then for all of them, it actually kind of comes down to just taking the old value and subtracting whatever the new value is. So for the plus, that is this one here. So our magnitude plus our old value. We take our old value, subtract that combination from it. And we kind of just do that a bunch of times because we do the same thing for multiplication. So we take this, subtract our output from our multiplication, put that in there. It becomes a little spaghettified fairly quickly here. So what you can do for that is you can just get old value and hook that up like this instead to all of these so that we don't have the spaghetti going all over the place. Just looks a little bit more organized that way. You can actually kind of see what's going on a little bit better as well with it. So let's do that. There's still a lot of nodes going around all over the place, obviously, but a little bit less now. So then we also take old value minus the result of the division. And then for the override one, we just take old value minus the magnitude directly and put that in absolute change. Real quick cutting in here during the editing of this video. It's going to happen a couple of times during this video because there's a lot of stuff. We hooked up the minus node here the wrong way around. You do need to put in the magnitude plus old value, so that's the new value in the top here, and then the old value goes into the bottom. Otherwise it's going to reapply the same absolute magnitude change at the end as well. So make sure to go through and make sure that the old value is at the bottom and our new value is at the top. Got to do that with all of these. So I seemingly messed up them all. So again, just got to make sure new value at the top, old value at the bottom. So now we have our function that takes in the old value and puts out the new value based on our effect math. So going back into the doEffect function, we can now get our calculate new value, and we're going to put in one of those for every single one of these pins. So there's going to be a few of them, which is also going to be a noodly mess. Bear with me, we're going to make it through, I promise. So we hook all of those up just like this, fairly straightforward. And then the old value that we provided, let's make a little bit of distance here, will be taken from the for each loop. It's a little bit weird though, because looping over the for each loop, everything that we go through here technically are copies of the original values, not the actual original values that we're working with, just due to the fact of how Blueprint deals with the for each loop. So what we actually want to do is we want to get a reference, not a copy, but a reference from the original array, and we just get it at the array index that we're currently at. This way, we get a reference to the actual index of the actual array, so we can edit it and it will reflect properly back into the components. So we're going to break that, and we get the stat attributes, which we break again, and that's going to give us our minimum value and all that other stuff. These are what we provide in for all of our calculate new value nodes. And with all of this, it's not really that important yet that we're using a reference, but that will become important in a moment because it's going to do its math and output the new value. So we're going to go over back here to our break attributes. We grab our stat, just pull that out, and then we set member in stat. This requires it to be a reference. Otherwise, we're going to be setting it in a copy and it's not actually going to like pull through. So in this case, we go in the details panel here and we set this as pin for minimum value to be enabled, and we set that through there. And then we just kind of like copy this over a whole bunch of times and just update which pin is available. So we do value mod for the second, then we make sure that it's the max value for the third, and so on and so forth. So just copy like 3 of them over, the max value modifier, next one would be the current value, and you kind of get the point at this point, I hope, and then the current value modifier as well. Make sure that if you just copy them over like I did, you can just double click to add a reroute node in here and make sure that all of the struct references are also hooked up in there, because otherwise it's not going to be able to set them to the actual struct. And this is now effectively a functional gameplay effect. Now, there's one thing that I do want to do, and that is I want to add a event dispatcher, which says update attributes, which is going to take in an input of either just a name of an attribute or the attribute as a whole. Kind of depends on what you want to do. Largely, just sending through the name is probably enough. I'm just going to send through the entire attribute so that we have all the new values to it as well. We'll call that attribute. And after any one of these parts, we're just going to be calling that out. So we hook all of these up to that so that we have an event dispatcher that everything can listen out for. So when you like damage something, for instance, you want to be checking, hey, after the damage has been applied, are we now at 0 HP? Because if we are, obviously, you want to like kill that character or whatever. And the thing that we're going to be sending through is the output from this getting node. So you get that and you pull it all the way through to there. And then after all of that, we just return. So that ends the function. It doesn't need any return values. The return node is just purely there to stop this loop from going through the rest of the attributes once it's already found what it's supposed to be looking for. Now, you also can implement the built-in clamping for the minimum and maximum here, because obviously your current value should not be above or below the minimum or maximum value. So we have our current value here. We're going to put that into the clamping float node. And then we want to clamp this between minimum and maximum. Now, the way that we can do that is either just by getting the min value and adding to that the minimum value modifier and putting that in there as the minimum value. But we made a function for this, if you recall. So let's make a little bit of room here. We have our target component that we're working on as a reference. So we can just get minimum attribute. And we can then also get the maximum value for that attribute. Fairly straightforward and easy, just like this. So if we hook all of that up kind of a bit like this, we just need to give in the name. But hey, don't you know, we have the attribute to effect as a variable as well. So we can just give that in as a name too. And then we can easily pull these through. And now our current stat value will be clamped to the minimum and maximum with their modified values applied as well. Cutting in here during editing real quick. It's been a long day. Do make sure to hook up the get minimum and maximum attribute things to the right line of things, because we hooked them up here to the bottom thing where I hook it up to the current value modifier. Obviously, we want to do that with just current value instead, because otherwise it's going to always set you to 0, which obviously we don't want to do that. So make sure to hook this up in the proper line. So again, that is the current value goes to calculate new value, goes to the get minimum and maximum attributes for the clamping nodes, and that sets the member stat current value. This is the bulk of what the gameplay effect will actually be doing. So we're actually pretty close to having this working now. So we can go back into the event graph and at apply effect, we can just do effect at pretty much like every single one of these anyway, right? Because if it's an instant effect, we just want to do the effect immediately. If it's a turn effect, we want to do it and then do a little bit of like turn counting. If it's infinite, we just want to do it and that's it. And if it's temporary, we also want to do it and that's it. Now we need to add in another event. So let's add in the custom event for end effects. So end effect. And this needs to check the effect type as well. Specifically because the temporary effect is going to be dealing with its own like absolute magnitude that it applied and going to be reversing that. That is why we made that absolute magnitude change variable before. So let's switch on effect type. And here we pretty much just, because we calculated the absolute change in magnitude, what we can do is we can set our effect math now just to be like hard coded to set to add, because we calculated how much it subtracted. If this is a negative number that it subtracted, it added something. It's now going to subtract it, whatever. Again, adding and subtraction are kind of the same thing, just in opposite directions. And we're going to set our new current magnitude to being our absolute change multiplied by -1. So we're just going to add back in however much we took away or the other way around. And then we will do the effect to reverse it back to what it was before we applied this temporary effect. Now, in order to finish this end effect, we also do need to hop over real quick into the ability system component, because the ability system component is going to keep track of what effects apply to it. Because at the start of every turn, it's going to need to like run the effects that it has actively on it. So we'll make a array for that, call that active effect, and that will be of type turn effect, the object that we've been working on this entire time. And we're going to make that into an array. In a moment, we'll actually make the function that adds things to this array. But for now, we just need this array to exist so that within the turn effect, when we end the effect, what we can do is we can get our target components and we can get the active effects, and then we can remove from it. So we can remove an item, and we're going to be removing just a reference to self. So this effect is going to be removing itself from that array. And the wonderful thing about Unreal Engine's base objects is because Unreal Engine has its own built-in garbage collection, we don't need to explicitly destroy this object. Just as soon as it's no longer available as a variable that's set in any object, or part of this array in this case, Unreal is just going to clean up this effect all by itself eventually. You don't need to worry about explicitly destroying it, which is kind of nice. So we just remove this pretty much like any case, and then also add in the instance. So yeah, this is pretty much just like removing it from that array, but if it's a temporary effect, first reversing whatever it did. So now that we have that end effect thing, we can also hook that up immediately to instance, because instance just does the effect and then immediately ends the effect as well. So we can end the effect. And the last thing that we have to do is to make a turn counter for the 4 turns effect types. So we make a variable for that as well, which will be the effect turn counter. That's going to be an integer, which obviously is going to be exposed on spawn and instance editable. And then we just get that counter and we decrement from it. So that's -, so that we take away 1 from it. And we just check, hey, is this now less than or equal to 0? Because if it is, we just applied it for the last time and we can end the effect as well. And just like that, we have a functional gameplay effect. Now we just need to set up the code to apply it, because what good is a gameplay effect if we can't apply it, right? So for that, we're going to go back into the ability system component, make a new function, and we'll call that something like apply effects to target. And in here, we're going to construct a object from class. And we're going to be constructing an object from the class that we give in to it as a parameter. Now, this is just going to be a normal object class reference. We obviously only want to construct objects of the type turn effects. So we look for turn effects and then we make this a class reference. Now, that initially might not get you everything that you need. So you disconnect this, and when you reconnect it, it will show up with all the exposed on spawn things. So we pretty much just hook all of these up right into the parameters of this function as well. It's just going to all send them through. So we do this. The effect math didn't want to connect up for some reason there. If it does that, just try it again. Probably put it just in the wrong place, and just like that. Now, there's only 2 things. I also didn't set the attribute to effect. Now, there's one more thing that we want to take a look at, and that is the outer of this object. The outer of the object is kind of like the parent, the thing that is responsible for this object, that takes care of this object, that without it, this object like doesn't have a place to exist within like your game code. So you want this to be applied to the target components, because what you don't want to have happen is a character applying an effect to a different character and then getting removed, which means that the outer object of the effect gets removed, and that's all kinds of weird. So you want the outer object of it to be the actual component that it will be affecting. So you can just pull those through like that, and that will be all fine and good to go. Now, if you click on this, you can rearrange the order of these to be in a slightly more sensible way. So maybe like having the name of the attribute up top, and then the effect turn count I'm going to keep at the bottom. The effect type, probably the target component also quite high up. You can order these however you want, really. Doesn't effectively change anything, but it might be nice to like order these in a way that makes sense to you personally. Quickly during editing, I'm cutting in here because I made this class a parameter for the apply effect to target function. You actually don't need to do that. You can just make this be a turn effect class that it spawns in, because we're given in all of these values through the parameters, and we're always going to be spawning in a turn effect. You can set this up a little bit more like the original gameplay ability system, where the gameplay effects themselves are always like separate classes, in which case you don't need to give in all of these values one by one every time you call apply effect to target. I personally prefer doing it this way, because it saves you having to make a separate blueprint for every single variation of damage that you possibly could want to do. Then when we have constructed this object, we do want to bind to update attributes. And what we're going to be binding to that will be on the target component a specific function. So let's actually pull off of this, and we will create an event, and we'll make a new matching function for that, and we'll call that on attribute updated. For now, we're not really going to do anything with this, aside from maybe also making a new event dispatcher on this, which we'll call attributes updated as well. You can give this a different name, maybe, so that it's a little bit more clear that this is the component version. But all that needs to really do is copy the signature from on attribute updated. So we find that somewhere in here. You might need to compile first for that to be in the list. So on attribute updated, and we just kind of like send that through. So that way we can subscribe to this on the components instead of the individual effects as well. The effect just sends through a message to the component, and then the component can send through that message to whatever actors might be listening out, right? Just makes it a little bit easier to deal with. But we do want to make sure that we do that on the target component and not on the component that is sending the effect. So the target component will be the object that we link this to. Then we get our effect type, which is just the input parameter that we have here in the function. You can, again, get these as just nodes in your graph. They'll be marked with this little F icon so that it's clear that these are function inputs. And we will do a switch node on that as well. Because we now have this effect that we constructed. If it's an instant effect, we just immediately want to start applying this effect. If it's a temporary effect, we also want to immediately apply the effect. However, if it is an infinite or a effect that lasts for a certain amount of turns, what we want to do is we want to get our active effects, and we want to add unique. We add unique just because in case you might accidentally run this twice. You shouldn't. But you're going to be adding the constructed effects that we just made to this array. And don't immediately apply the effect either, because we're going to be applying this effect for the 4 turns and the infinite at the start of every turn in our like battle scene instead. So then we simply add a return node that both of these hook up to, and now we have a way to apply our stuff. If you want to, you can also add in a reference to that created effect as an output, just in case you want to do something out with it. So you can call this like effect reference. That way you can easily get the effect that was just created and have a reference to it just in case you need it or you want it. So with that, let's just add in a ability system component just to our BP third person character for now, because we don't really have a battle scene or anything yet. So what I'm going to do is I'm going to add a ability system component to our like just overworld character, for lack of a better term, which is going to have a attribute for HP by default, which is going to have 100 max and 100 current value. And then when I press a debug key, so let's do debug key F or something like that, we get in our ability system component and we apply effect to target. The target component will be just itself. For that, it might be nice to, in the ability system component, just also make a apply effect to self, where we just kind of get apply effect to target and just make the target component a reference to self, and still just hook through all these other things as parameters. Just so that we have anything, if you want to apply an effect to self, like healing, it's a little bit more straightforward than having to also then hook up the target component, because it's going to confuse you. So you can apply effect to self instead. You see it doesn't have the target component anymore. It's just a little bit more clear. And what we're going to do is we're going to get our HP and with a magnitude of -10 instance at the current value, we're going to be adding. So every time I press the F key, I will lose 10 HP now. The way that we can test that fairly easily is just to add in a tick event, get our ability system components, obviously, and then get attributes, current value. We're going to be getting our HP, and then we print the value of our HP like that. And I'm going to just print this with a duration of delta seconds so that it doesn't spam my entire screen full. So now we will be able to see that if that pop-up for Shift F1 goes away, I have 100 HP in the top left corner. It's a little small, hopefully you can see it. If I press the F key, it goes down to 90 and then to 80. And then I can keep doing that until I get to 0, at which point it won't go down anymore because it is getting clamped to the minimum value of 0. If I go into my ability system component on my character here, and I set the minimum value to be like 15, you'll be able to see that it will stop at 15. So I can go down, that pop-up needs to go away real quick. 60, it's 50, it's 40, it's 30, it's 20, and now it's 15, because it doesn't allow me to go down below that. If I add in a value to like that modifier that we had, so I have a minimum value base of 15, and then it's temporarily like modified to allow me 10 more minimum value, you'll see that now the minimum value that I will practically be able to get to will be 25. So everything works as expected. We have attributes that we can now, with gameplay effects, change around. Now, we also obviously need a turn-based battle to make use of like the turn-based effects, that kind of stuff. We'll do that eventually. Before diving into fully making abilities for our turn-based combat system, I think we're going to take what we made last time with the gameplay effects and make some equipment, because that's also a very key part to your turn-based RPG, most likely. Obviously, this would likely hook into some sort of inventory system. If you need an inventory system, I have an entire series on that as well. We're gonna just do something fairly basic here to show you the setup that we're gonna go with. So what we're gonna do is we'll make a new blueprint and we'll make a child of the static mesh component. So you just look for static mesh component over there. Now, there is an argument to be made that you want to do this as a skeletal mesh, because if you have specific parts of your armor, for instance, that you want to be able to equip and deform with the character. If it's just something like a helmet, you can just hook it up to a socket on the character's head. But if it's like a full breastplate, for instance, you want to be able to have that deform with the character, in which case it being a skeletal mesh that shares the same skeleton with your character is probably a little bit of a better setup. It goes a little bit more into things than I want to do right now, because that's not really the point of what we're trying to get across here. I probably will just make a separate video about that in the future. So for now, we're going to go with this being a static mesh component. And we'll call this mesh equipment or equipment mesh or something along those lines. We'll give this a couple of variables. The first being the slot name. So this is going to be either like head or body or gloves or boots or whatever. Just something that you can check on whether or not the equipment that you're trying to equip goes into this place to begin with, which is going to be exposed as instance editable. Then we don't really need begin play or even event tick on this. We're going to make our own custom event for equipping. So let's call that equip. And there we take in an equipment asset. Now, I like to do this as a data asset because my own inventory system also is data asset based. If you have something different, obviously, you might need to adapt to suit whatever you have going on. But what we're going to do is we're going to make a blueprint class, and that will be a data asset type primary data asset. And we'll call that equipment data asset. Open that up. This will also have a couple of variables, starting with the slot name. So this is what we're going to compare when we try to equip something from an asset. We're just going to look at that asset, say, hey, do you go on the slot that this mesh component represents? If so, we'll move on. If not, obviously we won't move on. So that's going to be a name variable. Then we'll add in some modifiers, which is going to be a struct that we have to make. So let's call this modifiers and then make that struct. So we might need to start organizing this a little bit better in a moment as well. But for blueprint structure, call this attribute modifier. And maybe like don't misspell it like I am doing, which is obviously going to have the attribute's name, is going to have the target stats, because we want to know minimum, maximum, whatever. What do we want to change? We want to add the magnitude, obviously. We'll give these names in a second. And then again, the operation. So that will be the effects math. I think we called that, right? Yeah. So give these names. This will just be name of the attributes. This will be stat values. This will be magnitude. And this will be the operation that we do on it. So this way we can create a equipment data asset with those modifiers as an array. So we can make this the attributes modifier, which I horribly misspelled. I'll fix that eventually, I'm sure. And that's going to be an array, because the way that we want to do this is we can set up this to now influence both the attack and the defense and the magic stat and everything that this specific piece of equipment needs to represent. I guess you can also add in a text variable for the display name of given stats as well. It's entirely up to what you want to do with that. If you want to display these stats in a menu, maybe that's a good idea. At that point, changing these two out for an actual just like attribute struct might make more sense. Feel free to do whatever you want with that. And then since this is going to be a static mesh, we also want to know what mesh represents this, obviously. So we add in a mesh as static mesh, object reference, and we expose all three of these values. So this is going to be our data asset class. This is the template for our data asset. Now that we have that, we can make a data asset of that type. So we will have, if we look through here, equipment data asset. And let's just make this like a helmet or something like that. I don't have a mesh for this, but it'll go on the head slot and it will increase my maximum HP. So let's go to max value for the HP. And it's going to add to this like 100. So this will be one of the assets. You can make as many assets as you want here. If you have an inventory system, this would also tie into being a item data asset. Again, if you're using a data asset based system for your inventory like I would. But we can now go back into the mesh equipment, and there we also make a custom event for unequip, obviously. So unequip. We'll fill this out in a moment, but it just needs to exist because it's going to be part of the equipment code itself. So we'll take in a equipment asset as a input here. So this will be the equipment that we're trying to equip. And that's again horribly misspelled because I tend to do that. That will be a equipment data asset object reference. And from that we can get the slot name and we can check, hey, whatever we're trying to add in, do the slot names match between this component and whatever asset we're trying to add. If they don't, we just kind of don't let them do anything. But if they do match, we unequip what is currently equipped. So we unequip that. And then we promote whatever we're trying to put into a variable. So this will be the currently equipped asset. So let's call this currently equipped and we set that. So now we finally get into having to get the ability system component from somewhere outside of the actual like blueprint that owns it or whatever, right? So the way to ideally do that would be to go into your blueprint and set up a blueprint interface. We can call that BPI turn-based combat, and we can create get turn-based component, or just get ability system component if you want to be like fancy and make it the exact same name that the gameplay ability system uses. And that just outputs for us a component of obviously the type turn-based or gameplay or ability system. What did I call it again? That component that we made. I think I just called it ability system components. Yeah, there we go. So that's what it's going to output. We can go into our turn-based actor here and implement that. So you can go into the class settings, into the interfaces, implemented interfaces, look for our BPI, and now it has that as a function that we can just drag in our ability system components and give that as the return value. That's all that it needs to do. And then we also, because we've been testing this with the third-person character, because we don't have a battle scene yet and all that kind of stuff. So this also needs to implement that. So again, we go into here and then we BPI turn-based combat. And then we go into that interface and provide our ability system component in, so that the rest of our code can now access ability system components on various different objects. Back to the mesh equipment component. Slight little detour. We want to get the owner of this component, which is going to be an actor. And from that, we want to get the turn-based components. Because obviously, we want to apply effect to self. And the effect that we're going to be applying will be the modifiers from our equipment data assets. So we have our currently equipped variable here. We get the modifiers. And we for each loop over those, so that we apply all of them. We can just split the structure pin, give in a name, give in the stats, which will be this one, the magnitude, the operation. There will be a temporary effect, because they need to reverse themselves when they get de-equipped. And they don't have a turn counter, because obviously it doesn't automatically unequip after a certain amount of turns. Then we do want this component to also keep track of the effects that it added, because it's going to need to unequip them. It's going to need to end those effects manually. So for that, going into apply effect to self. Last time we didn't give this a return value. Apply effect to target has a return value. It's probably good to also pull that through as a return value for apply effect to self. Now that we have that, we can add that to an array of effects. So let's call this effects as a variable, which will be of type turn effects, object reference, turn that into an array. And anytime we make one of these, we just add unique, the effects that we just created. Then at the very end, because this is a child of the static mesh component, we need to remember that we're actually working within a static mesh, right? We can just set static mesh, because again, in the end, we're working within a static mesh component. We're just adding some functionality on top of what the static mesh component already does. And we're going to get the mesh from our currently equipped data asset. So we get the mesh, which apparently I accidentally made into an array. That's not what that's supposed to do. So let's go into here real quick. Turn that back into a singular variable. That's my mistake, but now we can set that. And in the helmet, let's actually just quickly set this to material sphere, which is going to be really big, but for now, for demonstrational purposes, I think that'll be good. So that gets us to unequipping, because obviously that's also quite important. For unequipping, all that we need to do is we need to get our current effects that we applied when equipping this. We for each loop over those, and we simply end the effects on all of those. And because those are set up as temporary effects, they will take care of whatever like their absolute magnitude change was and reverse it like we set it up in the previous video. Then once that is done, we clear the array so that it's empty for whatever is going to like equip next to it. And then we set our current equipment to being a empty value. And we make sure that our static mesh also gets set to a empty value. So that's the basic idea of setting up like this equipment system. Again, you can tweak this to however you personally like it. We're going to go on the third person character for now. And I'm just going to add in a equipment mesh as a child of the skeleton mesh here. And then we can set the parent socket. I'm going to set this to be the head bone, which is right here. So it'll be parented to the head. And the slot name for this one is going to be head. Do make sure to double check your spelling. It's case sensitive, so I needed to make sure if I used a capital H there. And then in the event graph, I can, when I press the F key, instead of just applying an effect to self, what I can do is I can get my mesh equipment and I can equip. And I can equip the helmet. And then when I press the debug key for like G instead, I can unequip. And that should then allow me to equip and unequip with stat changes. So we're getting the current value for our HP now. We are changing the max value. So we're actually gonna get max attribute for HP because I need to be able to show you that it's actually doing something, right? So let's replace that real quick. And now if we start playing the game, we should be able to see everything work out fantastic. And now we will see that I have 100 HP, so I can equip. I have a, well, sort of a helmet, for lack of a better term, and I have 200 HP, and then when I unequip, I go back to not having that helmet and go back to having 100 HP, max HP, that is. So we essentially now have working equipment that can hook into, again, an inventory system or something of the sort if you like it to. I figured a little bit of a lighter video in between the very heavy gameplay effect stuff and then the very heavy gameplay ability stuff that is going to come next. It's probably a good thing to put these gameplay effects into some sort of smaller context actual use. But that does mean that next time we're going to go back in to something a little bit deeper and we're going to start making our gameplay abilities. It is time to get started with making the actual abilities for our turn-based ability system that our turn-based RPG is going to be relying on. But there's going to be a lot of work involved in it, and there might be some future videos where we circle back around to adding stuff on top of what we make here today. Today is mostly the basics, setting up an ability like template, and making our ability component able to execute those abilities. Then, once we actually have like our battle scene arena set, then we can get started into like actually setting up the abilities and like a targeting system for who we want to target the abilities with and all that kind of good stuff. So let's get started with that. I'm also going to make a folder here for like the structs and enums and that kind of stuff. I'm just going to call that new folder, that's fine. So we have a lot of stuff that we can like put out of the way that we're not like actually using. So all this stuff we can just kind of like move into there. I'm going to eventually structure this a little bit better, but for now we'll just keep it as is. Make a blueprint class. Okay, there is a consideration to make here. That is, we're gonna use the actor class for this. And that is specifically because I'm going to want to make something where you can script out individual abilities, like do this, then do this, then do this. And in order to do that, having a lot of things that are present as an actor in the like physical world is fairly useful, because things like delay, things like spawning in other actors, that kind of stuff might be relevant to do. Ideally, you would make it a basic U object, just a basic object here in all classes. Those don't have access to a lot of latent actions or actions that influence the actual game world, because they themselves don't exist in the game world and they don't have a context of what the game world is. If you are doing this in C++, I do highly recommend still going with using this basic object instead of making this an actor, because constructing and destroying basic objects is a fair bit faster than doing it with actors. We're not going to be spawning in hundreds of these anyway in a short period of time, so it likely doesn't matter that much, but doing this with basic objects is a little faster. If you do want to do this in C++, I'm going to show you a little bit of code on how to set this up in a way that makes it work. If you don't want to deal with that, we're going to go through the rest of the series using actors for our abilities instead. But the C++ code to do this would be a header file here. We just have the U ability inheriting from the U object. All that you need to do is you need to add virtual U world pointer, get world, const override. This is the getWorld function that it doesn't have by default. It doesn't have a value by default, rather. And you can implement that in the CPP file with something along these lines. And all that this is doing is it's checking whether or not the outer object of this object is valid in a couple of different ways. Then it's checking whether or not it is an actor. And if it is an actor, it uses the getWorld from that actor as the world context for this object. Suddenly, our uObject now has a world context, meaning that it can use latent nodes like delay. It can spawn in other actors, it can spawn in particle effects a little bit easier, all that kind of stuff. So this is the C++ solution to that problem. Obviously, we're going to just stick with Blueprint for this, and we're going to go ahead and make an actor for our turn-based ability. Now, this is going to have a fair few things that we need to do with it. I'm going to get rid of everything that has to do with it being an actor, because aside from the fact that it now exists in the world and we can spawn it in as an actor, we don't actually care about like the components on it or anything like that. We're just going to make a handful of quick and easy functions. And from here we need to do one thing. I want to have a variable that is the ability or the owning ability component or something along those lines, or the owning component, whatever you want to call it. That will be of type ability system component, and we're going to be exposing this on spawn, because when we spawn in this ability, we want to be able to provide it in the owning ability component. Then a couple of other variables that we want to just set up, which will be the name of the ability, and this is going to be just for display purposes, so this is going to be a text. And then we also want to set up what this ability is going to cost as far as like the attribute cost of this ability goes. Now, the way that I have this set up is going to just take in one attribute. If you want a ability to take in multiple attributes, you'll need to like arrayify the setup that we're going to do here. But for now, we're just going to go with a singular attribute cost. So we need to make, to nobody's surprise, a structure for that, which will be our attribute cost. And that's effectively just going to be a cost for float, and then also the name of the attribute that we're going to be taking it from. You can also put in whether or not this is taken from the max or the minimum or the current value. Generally speaking, the cost for an ability is fair to assume that it's just going to take away from the current value of whatever you have. So let's just put in a name there, and that's all the information that we need in that struct. So let's call this costs, and then attributes cost as the type here. We'll actually put both of those to be exposed as well. Don't need to expose those on spawn, just make them instance editable. That's plenty enough. Now, first and foremost, let's worry about this cost thing, because obviously that's quite important. And for that, we're going to make a function here, and we'll call that something like commit ability. And this is going to check whether or not we have enough of that certain attribute in our attributes to begin with. And then it also will immediately subtract that and give out some bool value to let us know, hey, did we actually activate this? Yes or no. So we get our owning ability system component, and from that we get the attributes on it. And we're going to be doing the good old for each loop over that, and you can probably kind of see where this is going, I would imagine, because you split structure up in, and you check the ability system, ability cost, rather, split that structure pin as well, and we're going to be comparing some names. So we compare the name against this name to see, hey, when do we find the proper name of the attribute that we're looking for? And then we use the owning ability component again to get current attribute with, again, that same name. And if that is true, that last branch, we're going to be doing a new branch here. And that branch will be whether or not the value of this is greater than or equal to the cost of our ability. Now, this is checking it with modifiers, and we're going to be applying a gameplay effect that will only apply to the base value of it. Generally speaking, this is assuming that we're doing a cost on something like mana, which isn't going to have its current value boosted in any significant way. If you do have that in your game, where a potential like resource stat can also have something that is like currently boosted. And to be clear, that's specifically talking about the current value. Obviously, if you have like equipment that increases the max value of this stat, that's not a problem at all. But if you have a temporary buff to like your mana, for instance, in most cases, I don't see that being like the case and being too useful, even from like a game design perspective. That's a little bit weird. But if you do have that, you need to specifically figure out, okay, so but what is my actual like current value, and then apply 2 gameplay effects, once to the current value and once to the modifier value. But in general, I would just advise you to not like open that Pandora's box, because then when you take away that modifier again, it's going to maybe like get you into a total value of under 0, which would be a little weird. So just generally, when a stat is used as a gameplay ability cost, just don't modify the current value with current value modifier. Either way, if this is false, we just simply return, and the output here is going to be, we'll call that committed, and that will be false. The same thing, if we actually reach the end of the for each loop, we also want to return false, because reaching the end of the for each loop means that we never found an attribute with a matching name to begin with. But if we did find that, and it does have enough value to actually be committed here, what we'll do is we will once again get the owning ability component, and we will apply effect to self. The target attribute obviously will be again the attribute that the cost is targeting. The magnitude will be obviously the magnitude for the cost. Target will be instant. The target stat will be the current value. Effect math will be add, and then turn order will be 0. We do need to add in a multiplication node in between these two though, because we're going to be multiplying that by -1 to make it a subtraction. Again, if you have effect math subtraction as an option, you can just use that instead. Generally, I prefer just doing it like this, adds a little bit less headache. And once you do that, we can add another return node, and this one with success. This will do all of the gameplay like mana cost for your spells and that kind of stuff, and then tell you whether or not it actually successfully committed the spell. So this will work no problem, but the little bit of code that we have here might actually be useful to put in a different place, because this is checking whether or not we can do the ability to begin with, which maybe sometimes you want to check whether or not you can do an ability before you actually create the ability. Because what this will do is it will create the ability, then check, hey, can I actually run to begin with, and then like move on with it, which generally is a good way to do things, but maybe you want to disable even clicking the ability if you don't have enough mana or whatever, which is just a bit of a pain to do this way. So what we can do is create a new blueprint function library, call that something like RPG functions, and here we'll check can do ability, and we can just kind of copy all of this stuff over, and then we can paste that in here. Now we do need to change a few things up. So what we want to do is we want to change this owning ability variable to just a input parameter, and the same thing with the cost. So we can just make an input, which is over here on the right side for the cost. And that will be the attribute cost type, which we can then once again break open and just hook up to everything that we had it hooked up to before as well. And the upside is now we can use this from anywhere. So we can just check, hey, this specific ability component, can it afford this specific cost? An alternative that we could do as well is, instead of using this cost like this, what we can do instead is add in a ability class input instead. So we'll use our ability turn-based ability, make that a class reference, and then get defaults, and we can get the cost from that. So it's going to check, hey, the cost that that ability has, can this component afford that to begin with? And this might give you a couple of compile errors because it uses the get own ability component still here as a variable. But now that we have that, we can hook up the return node here. So if we get to the end here, we return with can do, and that'll be a boolean, obviously. So that'll be true. If we get to the end of the for each loop, once again, that's going to be a false. And if we do find the attribute, but it isn't enough, this is also going to return a false. So we can now just move this into a place where we can reuse this code a little bit more easily. Now that we have that, going back into our turn-based ability, we can get rid of all of this from here. And we can instead can do ability. The target will be our owning component, and the ability class will be a reference to self. And we will get class from that. So it'll check just, hey, this specific ability class, can we do this ability? Yes or no. If we cannot do this ability, what we'll do is we'll just instantly destroy this actor as well. If you're doing this as a basic object, you don't need to explicitly destroy, which is why it's kind of nice to work with base objects. If you're doing this with an actor like we are doing, you definitely need to like actually destroy this. So yeah, we hook that up to there, commit it. We'll say that, hey, we didn't commit this. Otherwise, we apply this effect to self, and then we say, hey, committed was true. So this is how we can commit this ability. Now that was a little bit all over the place, I am aware, I'm sorry about that, but it's going to make things in the future a little bit easier to have this as a blueprint library function as well. Now ideally, this also will mean that this check should always be true, because we shouldn't ever be executing this code ideally without this being possible to begin with, but it's good to have this in here as an extra layer of protection. Now going back into the event graph, I'm going to add in a couple of custom events, that being activate ability, and then also a custom event once again for end ability. So we'll end ability. The end ability is going to have an event dispatcher associated with it, so we'll call that something like ability end. And when we end the ability, we'll just call this out. That's really all that we need to do for this. It might be nice on the ability end event dispatcher to add in an input for the ability reference, so that we can send through which ability just ended in case that ends up being relevant. So we can just do a turn-based ability object reference in there, which can just be a reference to self. We're not going to put any code into activate ability, because activate ability will be populated by whatever child classes we make of this, the actual individual abilities. And since we're using a actor here instead of an object, when we end the ability, we also want to destroy this actor as well. Things are just a little bit easier if you use basic U objects, but again, I want this to be blueprint friendly. So with that, we now have the basic structure of an ability being a thing that we can do something with. We can commit that ability, and we can end that ability again. So let's go back into our ability system component and actually make it able to execute abilities and to own abilities. We're going to do this in two different ways. The first one is just activating a single ability. This doesn't need the ability component at all to like own that ability, to have gained that ability. And then we're going to make a function that kind of like builds on top of that, that first checks, hey, does this ability component even like have access to this ability? That way your character can learn abilities like as it levels up, or as you find like specific abilities in the world, whatever you really want to do in your game. So let's make that first function, which is activate single ability. And that's going to start off with spawn actor of class. So spawn actor from class, and the class that we're going to be spawning will be a ability class. So let's call it ability class, and then we'll make that specifically of type turn-based ability class reference, and put that in like this, which will get us a couple of things that we need to fill out. First and foremost, spawn transform. This can just be 0, effectively. It doesn't matter where you spawn them in, because they're not going to have any visuals. Again, the fact that these are actors is kind of not ideal to begin with, but we can just get actor transform from get owner and then the component version of this. So I'm just going to spawn the ability actor at the exact same position as whoever is using it. Again, doesn't matter where you put it in the world because it's not going to be visual or have collision or do anything like actually within the world. Then the owner of this needs to be a actor as well. We can just set the owner to the owner actor of this component too. And then the owning ability component we will set as a reference to self. Then we'll make a variable here for the active abilities. In theory, they should never have more than one ability in it because we're doing a turn-based ability, but maybe if your ability persists between different turns, it might be nice to have a like active array of all the active effects or abilities rather that are going on. But generally speaking, the length of this array should be either 0 or 1. We can just make this of type turn-based ability, make that object reference, and make that an array. So we can immediately just add unique, and we can add it to that array just in case. Okay, so now we want to, when this ability ends, also bind some events to that. For the time being, we're only going to bind one thing to it, and that's going to be a parameter to this function. Eventually, when the ability ends, it's also going to be ending the turn for this character, but we don't have a turn flow system set up yet. So we'll come back to that in the future. But for now, we can just get the ability that we made and bind to ability end. So bind events to ability end. And then the event that we'll be binding to it will be whatever we give into this as a parameter. A lot of the time, that's going to be nothing, but it will just be nice to have a delegate that we can give in if we want anything to happen when this ability ends in any sort of way. And then eventually we will add in a second one here for ending the turn, but we'll circle back around to that when that actually becomes relevant. And then we obviously return, and we're going to be returning the ability that we just spawned in as well. And then importantly, of course, we need to actually activate the ability. So activate ability, just like that, and put that in at the very end, preferably. So otherwise, obviously, the ability never starts up. So now we have the basic setup of activating a singular ability. Let's make a new function here, and instead let's activate owned ability instead. For this, we're pretty much just going to use the activate single ability. We're going to want to activate the ability that gives in. We also want to be able to bind that delegate, so we're just going to pass that through. But we want to check, hey, this ability class, do we have that owned on this ability component? For which we need an array of owned abilities. So we can just fairly simply make a owned abilities array, and that's then going to be of type turn-based ability is going to be a class reference instead. And we pretty much just check, hey, does this thing, this array, contain this specific ability? Because if it does not, we will not be executing that ability. But if it does, we can move ahead and execute that ability, no problem. And then, of course, we like to add in some return nodes. And the return nodes here are going to, first and foremost, obviously, return the actual ability reference that it created. Now, just having this can be enough because we can check whether or not this was successful based on if this is a valid object pointer or not. Whatever comes out of this, we can just do an isValid check on, and from there we can figure out, hey, was this a successful activation or not? If you prefer to just add in a bool for, hey, was this successful? So just activate it and make that a bool. In this case, that will be true. In that case, that will be false. You just have that bool to check. That's entirely fine as well. It's a little unnecessary here, but it also doesn't hurt to add it in. Now that we have that though, we need functions to both add and remove abilities as well. So let's make those functions add or give ability. And this is pretty much as easily as just owned abilities, add or add unique. This kind of depends on whether or not you want certain abilities to be able to be granted more than once. I would probably argue you don't need that. If you have things like passive abilities that might stack, maybe you don't want to add them as unique, but you just want to add them. I'm going to go add unique because I don't think that's like too relevant for a turn-based RPG scenario, but your mileage may vary. And that pretty much is all there is to that. And then we'll also remove ability. And that is just pretty much remove an item. We can just kind of give in the ability that we want to remove. If that's not part of this array, it's going to tell us, hey, we didn't actually remove the ability. But that doesn't matter because it's just going to move on otherwise. So we can add, remove abilities, we can activate abilities now. So all that we need to do is script out our first ability to test out whether or not it works. So again, we're going to go in with the third person character here. And on its begin play, which I'll need to add in real quick, we'll get the ability system components and we will give it an ability. Now, you see that this new item here, which actually should be given a name as well, is just an ability like class bin. We don't really want that. So let's go back into our ability system component and make sure that the give ability and remove ability, when you select the input node, open up the settings for it and remove the pass by reference for them. That'll make them into drop-down menus instead, which is what we want in this case. So do that, compile, going back, we can see now it's a drop-down menu, which lets us choose turn-based ability. But turn-based ability itself obviously doesn't do anything. So we have to make a testing ability. So right-click, create child blueprint, and we'll call that something like GA for gameplay ability. And I'm just going to make this jump. Fairly easy, all things considered. I don't really have an attack, do I? So we can go into the event graph for this, get rid of all this, and then we activate ability. Now, I want this to take some amount of cost as well. So I can go into the class defaults, and in its cost, I can say, I want this to take 15, that's 145, that's a bit too much, 15 of my HP. And then what I wanted to do is I want to commit ability. And if the ability was not properly committed, I want to end ability right away. If it was properly committed though, I want to get the owner of this thing. I'm going to cast that to the character class in this case, because I know that whatever owning this is a character, just because I want to be able to run the jump function on it. Now, the reason that we are doing all this stuff, setting up like these abilities that are linearly scriptable, is because now what we can do is we can wait for the jump to end. And that will be the end of our ability. So we can either like add in just a delay for the ability end, but what we can also do is, coming off this character, we can assign on character movement mode changed delegate is what it's called. So when the movement mode gets changed after we started jumping, we can check, hey, the previous movement mode, but we can also get our current movement mode again. So get the character movement components, which is all the way at the bottom here, which gets movement mode, and we can check whether or not that is equal now to walking. So this way it will fire this off when it actually lands again, at which point we can end the ability. And obviously you can script this out to behave any way you want. You can make it wait for whatever like delegates you want to like be updated for finishing an animation. Is most likely what you're going to be doing with this turn-based RPG stuff. What you'd probably do is you would play an animation montage, and you'd need a skeletal mesh component for that. So you get mesh, and then you play a montage, but I don't have any animation montages for this skeleton, so can't really do that at the moment. So we're just going to do jump as a test for the time being. Now going back into our third person character, we can now give it that gameplay ability for jumping. And I'm going to set this print string back to printing out the current value of HP. So get current value, going to put in HP there and hook that up just so that you can see that it actually uses the HP as the resource. And then when we want to jump, instead of using this code, which is why we would even use that code, right? we can use the ability system components and activate owned ability, at which point we can try to activate the ability for jumping. We can even hook up a custom event to whatever happens here. So we can print string and jump ability. And now we should be able to see that if we play the game, we have 100 HP, I press the space bar and it takes some HP from me. It ends the ability when I touch the ground, and we can do that every single time. So it takes some HP again, and there we go. Now, if I jump a couple times here, you will see that eventually it, well, my minimum HP actually is forcibly set to 25. So it's always going to allow me to do it now. But we can set that back in the attributes here because the minimum, I messed around with that in the last video. But if we set that back to 0, at some point we'll get to a point where I can't jump anymore because I don't have enough HP to do so. So let's get to that point, which should be right now. So it immediately ends whenever I try to jump because it just straight up does not allow me to do the jump. So that's the basic setup for the abilities. Now that we have that, we have all of the building blocks that we can start putting together into our battle scene to actually start making a turn-based RPG with this. So far, everything here is a pretty like generic turn-based oriented ability system. Now that we have that in place, we can finally start with the turn-based RPG, like actual battle mechanics. So next time we're going to set up the arena, and then based on how long that takes us, we might start implementing like the turn flow as well. But having the turn flow of your battle system is pretty in-depth, so that might be the video after that, an entirely video to itself. Now that we have the basics of an ability system for our turn-based RPG, we can finally start making a battle system to actually put those into use. So the way that we're going to do that is we're going to make a separate actor. And in our case, we're actually going to make that a pawn because we're going to do something that's a little bit weird. And we're going to be possessing the battle scene as a whole. Because that way we can easily set up input actions that our battle scene will deal with. And we can easily go back and forth between what camera perspective we show, either the overworld character or the battle scene. So let's make it a pawn. And we'll call that BP battle scene. And this is going to have a handful of different things. Now, this is going to be the parent blueprint that everything else is going to inherit from at the end. Meaning that if you have like a jungle battle scene, you're going to build out your jungle area with static mesh and all that kind of stuff within this blueprint. There's going to be one giant blueprint with everything in there. First and foremost, a static mesh. And the static mesh, I'm just going to kind of make this a cube or a plane. Let's go with a plane, actually. And I'm going to make this relatively large. So let's make this pretty big, because this is going to be the ground. Do we have any pre-existing materials that we can use for this? The bricks are kind of nice. It's going to be scaled up really, really big, obviously. But for now, this will be a good reference. Now, after that, we add in a camera as well. So let's add in a camera component. And this is going to be the camera that shows the battle scene. So you can just put those at like whatever distance you want. I'm going to put it somewhere right around here. If you want to have a good view of what actually is being seen by the camera view, you can just drag this into your level. Because it is an actor with the camera, it actually shows you a view of what the camera will see. If we go into the level here, we see the actual view that this camera has. We can double click on the camera, change the coordinate space back to local, and then we can make it like move in and out depending on what we want. Once we have that, just shift right click on the transform in the scene, and then we can go back into the blueprint, shift left click on the transform, and it will take over the transform that we had in the world. Now, this is just a template. Again, you're going to be building this out with other stuff in the future. But for now, we just deal with one plane. And we're going to add a couple of billboards to this. Essentially, we only really need this to be scene components, but just for the sake of it being visible in editor, making these billboards is a little bit easier. So we're going to put this over here. Then I'm going to set the snapping to being about 100. And move this, I don't know, about 600 that way. And make sure that these are actually parented to the default scene route and not to the camera. Then we'll call this one player 1. And you can kind of see where this is going. We'll copy it over. And then move this a couple hundred across until it's at 0. And then copy it over again. So we have player 3. And move it over. So that's about 600 over. So now we have them 600 units spaced apart. Then we just copy it over again, and instead of calling this player 4, we'll call this enemy 1. You can see that there's going to be a limitation here of 3 enemies and 3 player characters, but that's actually not that big a deal. If you need more, obviously just add in more enemy slots, and likely you're never going to really end up in a situation where you need an infinite amount of enemy slots anyway, because you're likely designing your game in a certain way. If you need like 10 slots here, of course you can just make 10 slots. We're going to go with 3 because everything that we do will be scaled up in like tedium and setting up things as we add more slots. But you can add more slots. You can, if you wanted to, like add back rows as well. It's a little bit more complicated. We're gonna not do that here. We're just gonna do 3 players, 3 enemies, and kind of keep it at that. But now these are going to be the positions that they spawn in. Now, for the enemies, we also want the rotation to be rotated inward. And you can check that by making sure that the red arrow is pointing that way. Because the red arrow will always be the direction that it is facing in its forward direction. For the players, you want the red arrow to be facing right. For the enemies, you want the red arrow to be facing left. Generally, you just want the enemies to be rotated around 180 degrees. Those are going to be the places that we spawn them in. Now we actually do need to do the spawning in, and this is where a lot of work starts coming in. So let's get started with all that. We're going to get rid of the pre-existing events here. We might re-enable begin play at some point. For now, we will just stick it out with this. And I'm going to start with adding a custom event for starting the battle. When we start a battle, we need to do 2 important things. Number 1 is we need to possess this pawn, because that's going to give us control over the battle scene, and that's going to show us this camera view. But we also need to remember which character we need to return to once the battle is over. So let's close down this components tab in the variables and make a new variable and call that return character, or return pawn more accurately, because this just needs to be a pawn variable. Again, just because we need this to be filled out so that we can return to this once we're done. So that's going to be a input parameter for starting the battle. When we start the battle, we need to provide in, hey, who is going to be possessed again once we finish the battle. Then we'll come back and do some other things here, like actually moving the party to the battle and setting up the battle UI and that kind of stuff in the future. For now, we won't need to do that yet. We do need to, however, make sure that the set actor hidden in game is false, because this thing is just going to kind of hang out in our level way up in the sky, and obviously we don't want that to be visible at all times. So what we do is we just set it hidden in game by default. So we can do that by just selecting the topmost thing in the actor itself and set hidden in game to being true by default. When the battle starts, it will set itself to being not hidden in game anymore. So we can see now from this camera perspective, it doesn't actually show, it doesn't cast any shadows because it is hidden in game. When we start the battle, it will no longer be hidden in game. And then we can get the player controller and we can possess. And the pawn that we're going to be possessing will just be a reference to self. After that, we will be able to spawn in our enemies. At this point, we need to create some player characters, move those to this scene or to this actor in the right positions, and then spawn in some enemy characters as well whenever the battle starts. So let's start by making those player characters. And the way that I like to do that is to make the player controller responsible for that. So we can go blueprint class, make a new player controller, and we'll call this TBRPG PC. Because abbreviating everything makes it a lot more clear. Nope. Maybe something like turn-based player controller will work a little bit better, whatever. So what we do here is we make some variables. So we'll call this like player1, and that will be a type turn-based pawn. I think I called this right. Turn-based actor. And we do the same thing for a player 2. And if you have like actual characters in your game, you might as well name these so that it's a little easier to actually like keep track of which one is which. But you can make as many as you want. We only need player 1, 2, and 3 because we're only going to have 3 players. And then the last one is going to be the active party. So if you have like 10 different characters, this is going to be an array that's going to hold the 3 characters that are actively in battle at that given time. In our case, it's just going to be the 3 characters that we have. But again, if you have a party switching system, you just spawn in all of your potentially usable characters and then assign the 3 that you're going to be using to this array, and then when you swap them out, you remove the one that leaves the party and you add in the one that joins the party. But all of those actors will actually exist in the world at all times. So with those made, we can go into the event graph, and here we're going to use begin play. So we're not going to use event tick, but on begin play we spawn actor from class, and the actor that we will be spawning will be our player actor. I think it was this one. Let's make sure that that's correct by opening it up. So this is the turn-based actor player version that we made. So that is the one that we would be spawning in. You can spawn them in wherever you want. I just like to get actor transform from the player controller. It doesn't really matter because we're going to make them invisible anyway until they actually get sent to the actual battle scene, at which point they will be made visible. Again, it does not really matter. And then we set this one to be the value for player 1's variable. We kind of just copy this over 2 more times and set player 2 and then also player 3. And then we have all 3 spawned in as easily as that. Then we'll just pull in all 3 of these and make an array out of those. So make array, pulling off of one of them, and then the other 2 can go in there, and we can just for each loop over those. For each loop, and we can just set these to actor hidden in game, set actor hidden in game. You can also just set the default value in the player actor class to being by default hidden. But I also then, because we're doing this with an array, just want to set the active party to being these 3 members. That's the way that I have it set up in my reference project. Again, if you have more than 3 characters, choosing which ones go into the active party. If you have a party switching system, you might need to like set up some code here. That probably would be like in your save file, all that kind of stuff. So for now, this is the basic implementation. You probably can and should build upon this. But now that we have this set up, we need to assign this player controller to be the player controller that we use. So let's go into our project settings and look for the game mode. And there we can set our player controller class to being our TBRPG PC. So now the default player controller will be that one. And we can check that by first saving everything and then starting up the game. And we can see that it spawns in those actors, which is a little bit weird because we shouldn't be able to see them. Oh, I didn't connect this one up. That's my bad. So we could only see one. But now we won't be able to see any of them. But if we look in here at the right side of the screen, we do have these player actors that exist in the world for us to use now. Oh, that's the player characters existing. Now, going back to our battle scene, we need to make an event that moves those 3 active characters to our battle scene. And that's actually not that difficult, all things considered. So what we can do is make a new custom event here. And then we'll call that move party to battle, something along those lines. And we will just get the player controller. Once we've gotten the player controller, we need to cast it to our TBRPG PC so that we can get the active party array. Now, there's going to be a couple of different things that we need to set up here, because we're going to need to reference the party a lot. So we want to make that into a variable. But we don't want to create a situation where there might be a disparity between what this battle scene thinks the active party is and what the player controller thinks the active party is. So the easiest way to actually deal with that is just to promote this thing itself to a variable. So let's call that player controller. And every time we need to get the active party, we just get it from the player controller. And when we need to update it, we also do that with the player controller. So we have the party of player characters always just being one array. But we also want to have an array of the entire battle scene, which is going to be both the player characters and the enemy characters. But we don't want it to be a variable because, again, part of that array is always going to be sourced from an entirely different objects array, which is a little like annoying. So the way we do that is we make a function for it, and that is just get battle characters. And this is going to return in the outputs an array of battle actors, let's call that, and those will just be our turn-based actor object reference, and it's going to be an array. So now we can just make an array out of two existing arrays. The other one we'll make in a moment once we actually have enemies, and return that. So we'll have a function to do that for us. So it just combines those two existing arrays. One of which, obviously, is going to be our player controller and get active party. We'll make a local variable of that. So promote to local variable, not just variable, local variable. So it's specific to this function. And we'll call that outputs array. So the first thing we do is we just kind of get whatever this array is and set our local variable to that as well. Then when we start getting a array for our enemies, which we might as well just make one right now so that we can implement this fully. So this will be the enemy party, which will be of type turn-based actor, obviously, and then also make that into an array. We just take this and then we for each loop over this secondary array, and then for every single one of these, what we're going to do is we're going to get our output array and just add to it. So we can add unique to make sure that we don't add the same actor twice by accident, and my cursor is kind of freaking out there. So we just add unique for every single one of the things in the enemy party to the output array. And now once we are completed with that, we just output the output array. So now we have that as a function. To make it a little bit more usable, we select the input here and we mark that as being a pure node. So it becomes one of those little green nodes that is easy and convenient to use. So now that we have all that set up, we can get battle characters easily, and we just have that as a node that we can drag in. Going back to moving party to the battle. We have our player controller, our active party. We're going to for each loop over that active party and put them into their right positions. So for that, we need to get all of our player positions that we made components for. So player 1, player 2, and player 3. And we're going to make an array out of those three things as well. So we connect everything up like this. We have an array that corresponds to this array. So what we can do is we can get any of these actors and set the actors transform. And we can get from this second array a copy at the exact same index that we are in the for each loop right now. Get the world transform from that. So that would be get world transform. And just put that into there. And that's going to move them into the right position. Now, they are invisible by default. So we'll also need to set actor hidden in game to not be hidden anymore. So new hidden will be false so that they actually become visible. Now, eventually, we also add in a little bit of logic for when they die. We check whether or not we lost the battle so that we can end the battle and have like a lose state, but we don't have the code to support that yet. So this is all that we're going to do at this for the time being. Just get those characters and move them into their proper positions. So going back to start battle, we possess at the very end, but we also now do this move party to battle in there. Next up, we spawn in the enemies. So let's make a custom event for spawn enemies. And for this, we're going to immediately also make a table that is going to contain all the possible permutations of different character layouts that we can randomly encounter. So for that, let's make a new blueprint structure because we need to make a data table for this. And this will be enemy encounter, which is going to hold a couple of values. First and foremost, it's going to have a float in it that's going to be the weight of this encounter. We can't really easily set this up to use percentages because it's just going to be a whole bunch of numbers that don't interact with each other. So the way that we do this, generally speaking, is by giving everything a certain weight. You'll see how that works in a moment, hopefully. And then we add a new variable, and this will be enemy class 1. And for that, we're going to make that a BP enemy actor soft class reference. The reason that we're doing the soft class references here is because this is going to be referencing the actual classes, and the data table will otherwise just load every enemy in the entire table into memory, even though they might not be used at any given point. So we're going to only explicitly be loading in these classes when they actually become relevant. So we do a soft class reference there. It's going to take a moment there to load it in because the editor does need to actively load it in. And we'll just do that for enemy class number 1, number 2, and also number 3. Now that we have this structure made, we can make a data table of this. So we come in here, and I think it's somewhere in miscellaneous, but for data tables, I generally just like look it up with the search function. Make a data table with the enemy encounter structure, and we'll call this basic encounter table. And here we can start putting in all of our encounters. So we make a new row. The row names don't really matter in our case because we're going to be sampling all of them anyway. And we can say that this has a weight of 10, and we only have the basic enemy actor for now. So it's only really one permutation that we can do, but we could make one where it maybe has only like 2 enemies. We can add in another with a weight of 5, which means that the total weight of this data table is now 15, meaning that this is a 2/3 chance to appear, and this is a 1/3 chance to appear. Where we will only have like the top and the bottom, for instance. And you can fill out this data table with a bunch of rows as you add in more enemies into your game. We might make a separate enemy type in the future, but for now, this is going to be the way that we deal with it. So going back into our battle scene, we want the battle scene to have a variable for the encounter table. And that's going to be of type data table. And that's going to be an object reference. I accidentally made that a class reference. Let's change that to a object reference and make sure that it is a singular one. And we'll make this instance editable because we're going to be changing it on a per instance basis. The default value is going to be the basic encounter table. So now that we have that encounter table, we can use that to calculate a random entry from that data table. So let's make a function for that, I think, and call that pick enemy layout. This is going to take our encounter table and get data table rows, row names is what it's called. Get data table row names. So this is just going to get all of the rows from our data tables by name, and we can for each loop over that array. So for each, and then we drag off our encounter table again and get data table row this time. That lets you put in the data table row. You will note, however, that it is a wildcard. It's great because it doesn't know when you just put in a variable for a data table what type of data table you're working with. So you need to explicitly tell it that. And the way that you can just do that is you can break this into whatever attributes or stats or whatever structure you made. So in our case, we're going to break this into enemy encounter, and it will now be aware of, hey, we're expecting this to be a enemy encounter. You can also make sure that it is this type of struct by looking up get data table row struct, and there we can check whether or not that is equal to our enemy encounter structure. If it is not, you kind of just want to exit out of this immediately because everything else is gonna not work. So only when this is true do we do any of this. When this is false, we want to just immediately print string data table with wrong struct used for encounter table and make that red, because this should never actually happen. Now, when we do find a row, we are going to add in a local variable for this. We'll make a total weight because we need to know how much total weight the entire data table has if we're going to be picking a random thing by weight. So we make that a float variable, and we just set our total weight to being our current total weight plus the weight from this row, and that is not a plus the weight from this particular row. So it's going to be adding up everything, and when it reaches the end of this for each loop, we'll have a total weight for the entire thing. Then we're kind of going to have to do all of that again, because now that we have everything counted up, we need to loop over every data table row again. So let's copy this over and hook it up to after the completion of the for each loop, and we can get the encounter table again. You can probably just reuse this array, to be honest with you. Probably doesn't matter that much. I like doing it this way because it's a little bit more like visually obvious what we're doing. But it technically is doing this getting array 2 times. Well, it really doesn't need to, but we're not doing this every frame or anything. So it's actually like not that big of a deal. And then we copy this over as well. So we again use the same setup for nodes. And instead of counting up to a total weight, we just want to start counting up to a like weight counter. So make a local variable, count up weight, and we just do the same thing. We set our current count up weight to being the previous count up weight plus the weight of this data table row. This time, however, we're going to be checking for it to having surpassed a random value. So we'll make yet another one of the local variables and call this target weight. We're not on a diet or anything. That's just the weight that we will be targeting. So we actually set that after the first for each loop, but before the second for each loop. And we will be setting that to a random float in range between 0 and our total weight. After every single time that we count up the, well, count up weight, what we're going to be doing is we are going to check whether or not our target weight is still less than or equal to our count up weight. Because the moment that it is, that means that we've surpassed whatever we are targeting. So that means that the row that we're currently working on is the row that we're going to go with. So there we return, if I can actually type, return, and we will be returning this out row struct, which will be a enemy encounter. So now we have this entire setup here to pick a random row from a data table that's going to provide us with the enemies that we want to spawn in. Going back into the event graph, we can now actually use that. So let's pick enemies by layout, split this structure pin. We're not going to be using the weight here, so you could really just send through these 3 class references if you wanted to, instead of the entire struct, but again, it doesn't really matter. And here what we do is we async load this asset, and once it's completed loading, we will cast this to the actor class. The thing is, with loading this async asset, it just makes it a generic object class reference, and we need it to be at least an actor because we're going to be dynamically spawning it in. We don't need to make this a cast to the actual class that we're going to be spawning in. We just need it to be an actor so that it has the capability to be spawned in. And make sure to hook that up to once it's completed and not immediately. So then we spawn actor from that class, and we'll spawn it at the transform of enemy 1 get world transform over here. And then we get our enemy party array, and we also add to that. Now, you might actually want the enemy party to just be a actor array, now that I think about it, because we want this to be as flexible as possible, and there's no real reason for it not to be an actor array, because everything we do is actually going to be driven by the components on these things. So might as well make that a actor array. And if you do that, you do want to go back into check battle characters real quick and update this as well, because this might be a slight issue, because the output array here also is not just an actor array. Couple of things that we might need to change around a little bit. The output needs to be just a actor array. You can just make this the turn-based character array instead if you don't mind. But if at any point you find yourself in a situation where you need to spawn in an enemy that needs to, for whatever reason, be not inherited from your turn-based character, but instead something else. This is the reason that we make it a component to begin with, right? Instead of coding everything onto the class itself. So now that we have everything hooked up and everything being made as generic as possible, that's a good rule of thumb while coding to begin with. Every type of reference that you're using, make them only as specific as you need the functionality to be. Make everything as generic as possible. Anyway, we're going to be adding whatever we spawn in to our enemy party. So, and never hurts to use add unique, because otherwise you might add it twice. It's technically a little bit slower, but again, it doesn't really matter. And we're going to do this entire thing just for all 3 of these. So we copy this over 2 more times. And then we just hook up our class references to this and to this one over here. Now, we did just make a layout where one of the classes is empty. So this cast is going to fail, and if the cast fails, it's not going to do anything after it either. So if this cast fails, we're going to just skip anything to do with this specific actor, and we just move to the next async load. Same here. If this cast fails, we move to the next async load. And if this cast fails, we move to whatever happens after that, which is eventually going to be also binding these things to when they die, so that we can end the battle when we actually defeated all of our enemies. But for now, that's not really a thing that we need to do. So the next thing up would be, after we have spawned everything in, to initialize the turn order. But that's going to be a separate video in and of itself. So this is just setting up the basic arena and moving everything into place for the battle to be able to take place. And then next time we're going to go over and do the actual like turn flow of things. But for now, we essentially have a battle scene that is more or less functional. We just need to be able to trigger it. So the way that I personally trigger it for testing purposes is just to go into our level blueprint with this thing selected, and then also add in a trigger box real quick so that we can, well, trigger something. So make this trigger box a little bit bigger, like the size of this ramp, something like that. Have both of those actors be selected, and then go into our level blueprint, where we will create references to both actors, and then I will actually also add a event for on actor begin overlap, specifically for the trigger box. We're going to check if the other actor is a soft, and we're going to check whether or not it's a BP third-person character. We actually don't need a reference to the trigger box, we only need a reference to the battle scene. And if it is, we will start the battle. And the return character will be the other actor in this case, which we do need to cast to a pawn, because we need to make sure that it is a pawn before we can actually provide it in here as a return character. So with all of that, let's test out what might go wrong here. So we go here and we don't actually spawn anything in, but it moves all of our 3 characters to their correct position. So why didn't it spawn anything in? It didn't spawn anything in because I forgot to add this new event to our start battle. So we very simply just spawn enemies, and then it should work. So let's try that again. This time it spawned in 1 character, and now it's spawned in 1 character again. Yep, because I'm an idiot. It's spawning them all 3 at enemy location 1, just because I copied it over lazily. This, of course, the second one needs to spawn at a second, and the third one needs to spawn at a third location. So with that out of the way, we now spawn in 3 enemy characters. Fantastic. And if we do this a couple of times, you'll eventually see that we also run into the permutation where it only has the top and the bottom character. So it does properly randomly pick them, and in this case, it actually did them in the statistically likely order. 2 out of 3 times we had 3 enemies, and on 1 out of 3 times we had 2 enemies. So that's the basic setup for our battle scene, and as you can see, it's been a long video just setting up this basic setup. Next time is going to be probably a very long video as well, because we're going to do the whole turn flow thing. Now, fair warning, we're not going to have a functional battle yet at the end of the next video. because we're going to just automatically skip all of the turns and we're going to just see, hey, whose turn is it? I just want the turn order to work properly. Once that is in place, we can just write some code for what turns should be for player characters and what turns should be for enemy characters. And then we will very quickly get into having a functional turn-based RPG. But for now, if you want the project files, as always, link down below in the description. For YouTube members and patrons, really does help support, especially these like bigger multi-part projects. And next time, we'll be getting into making it actually turn-based. With our turn-based scene now being kind of functional, it's not very turn-based yet because nothing's actually happening. So let's start coding up the turn flow of our battle scene. Now, this is very much one of those things where your desires might divert from what we're going to be doing here, because deciding your turn flow might be a very like mechanically different thing in the game that you want to make. If you're following along with this series, I do recommend just following along one-to-one with what we're doing here, and then once you reach the end, go back in and tinker with things to make them work the way that you want them to, because if at this point you start to divert from things, you might get into a little bit of trouble with things in the future. If you're going to be tinkering with things, you should have the full picture first. Of course, that goes for everything in the entire series, but specifically this turn flow thing is a very central and big thing, and might be something that, depending on your game design IDs, might be different for you. So let's get this figured out. We'll go back into our battle scene actor, and we're going to do this entirely within a self-contained function. So let's make a function, set turn order, because we're going to need to do this at either the start or end of every single turn, or even after every single move of a character. If you want it to be very dynamic, again, we're going to just do it on a turn basis, but depending on your game, your mileage may vary. And what we'll do is we'll get all of our battle characters, so every character that is participating currently in the battle, for each loop over that, and we will get their ability system components. So get ability, or turn-based component, as I called it instead. My cursor is still kind of freaking out, I don't know why. From that component, we're going to get a attribute with its current value, and the attribute that we're going to be looking for will be the speed attribute. Now, if something doesn't have a speed attribute, this is going to return 0, and that kind of can break some things a little bit. So you probably want to build in some kind of protection, whether or not something doesn't have speed, meaning that it's always going to be moving last, or that it's always going to be moving first. That's entirely up to how you want to deal with it. For us, we just want to make sure that everything we deal with has a speed stat, and if that is the case, this shouldn't be an issue. So, how do we do this? Well, we first set up every single speed that we can find into an array. So we make a local variable, again, important that this is local, of floats, and we turn that into an array, and we very simply just add every single one. Add them to the array, not add as a mathematical operation. For this one, you don't want to add unique, because if you have two characters with the exact same speed, you want them to both be in this array. The array for speed should always match the length of the battle characters array. What we're going to do then, at the end of this for each loop, once we have that entire array, because this is a float array, Unreal has a built-in thing to sort that float array, and we can sort it either in ascending or descending order. I'm going to sort it in descending order, so that the highest speed is at index 0 and the lowest speed is at index, at this size it will be index 5, so the 6th position. Now that we have that sorted array, we need to find out which speed matches which character. And for this we do need to build a nested for each loop, which is generally something that you of course want to avoid, because nesting loops is quickly going to grow out of proportion. But this is just an operation that we do once every so often, and only once. We're not like constantly running this, so it is mostly fine. So we're going to for each loop over the speeds, and then for every single one of these speed values that we have, we then need to also for each loop over our battle characters to see which one of them has the matching value for that. So we're gonna do the same thing here. We're gonna get their turn-based components, and from that get their speed. We do that in another for each loop. So hook that up just like this, get ability system component, all that kind of good stuff. And then what we check is we just check, hey, the speed attribute that we find on the actor that we're currently checking, is that exactly equal to the speed attribute that we're checking from our first array? If it is, we have found the character that corresponds to this speed stat. Congratulations. So we add that to a output array variable, which we'll call something like turn order. And we'll make that a actor array, object reference, and we simply just get the array element from our battle characters for each loop, and we simply just add unique to prevent it from adding the same thing twice, which might be relevant more so here because we're potentially going to be adding the same thing twice if two characters have the same exact speed stat, because it's looping over the entire array, right? So if we have two characters with 15 speed, the first time going through is going to add both of them into this array, and then the second time through we don't want them to be both added again. So it's quite important to do add unique here. Anyway, from the for each loop, the array element with the actor is going to be the thing that we add into the array here. Now once that is all done, we can do one of two things. We can run all this code anytime we need to then reference the turn order, which is not that big a deal, but also not ideal. So what I like to do is I do like to just make a variable for turn order actors. It does need to be differently named from this one, otherwise there's going to be a naming conflict. And we just, at the end of this second for each loop, we just set that member variable to this local variables value. And now running this function will just update that variable's turn order at the very end. And now we can, at any point in our event graph, just use this variable instead of running this entire thing over and over and over again. Because we are like doing a loop within a loop, and it's not ideal. They're very small loops, so it's not that big a deal. But also, if like speed stats change between character moves, you could end up with a situation where a character gets 2 moves, or a character gets skipped entirely if you run this every single time, which again might be what you want to do in your game, but if so, just come back to this and adjust it as you want later. We have the set turn order now. So if we go back into our event graph finally, so back in our event graph, at our spawn enemies, we're spawning in these enemies one by one. At the very end here, we're going to set our turn order with the function that we just made, because now we have everything in place, right? We have our enemies in place, we have our player characters in place, ensuring that spawn enemies happens after moving party to battle in our start battle event. So we can start generating our turn order. Once the turn order is set, we can then move to the next character in the turn order, which is going to be the first character in this case, but we'll make an event here. You can make it a function as well, but I'll make it an event, which we'll call something like next character. After we set the turn order, we're going to be moving to our next character. Now we need to code all of our code into the next character event, and that's going to be quite a lot. So bear with me here as we go through all of that. First, in order to know what turn we are even on, what character we're even on, we're going to need a turn order index. Something like turn order index like that. And we're going to make that a integer. That's just going to be a number that counts up through, hey, what index are we in the turn order array? What character are we currently on? And at the very start of the next character, we're going to check whether or not this is currently greater than or equal to the amount of things that are even in our turn order array. So we get our turn order array, we get the length of that, and put that into the bottom here. Because obviously, if our turn order index is greater than or equal to the length of our turn order actors, we should loop around back to the start of this array. So we very simply set the turn order index back to 0. Then we run the set turn order, because this is the time where we recalculate everything. Like, okay, so we've gone through the entire range of turns for the entire like party member and enemy party members. So we need to recalculate, hey, has any of the speed stats changed or whatever. Again, you can very much add this set turn order in here as well, but do pay in mind that that might result in some weirdness at times. And then we just simply do next character immediately again, because then we're going to loop back around to the first index again, which is index 0. If that's not the case, we are currently trying to access a character to start its turn. Oh, and do make sure to hook this up to the true pin and not the false pin, because if this is true, we want to set all this stuff. If it is false, we're still clearly within the context of the array. So we're fine to just move on to set character. And if that is the case, we just get our turn order characters and we get a copy of the turn order index. And we get the ability or get turn-based components from that, which we hook up to the false pin here. We want to get the attribute, in this case, current 40 health, or the HP, as I call it in this project, I believe. And we want to make sure that that's just over 0. Because if something has 0 HP, we want to skip its turn altogether. So let's check that with a branch. If it's not greater than 0, so if this is false, what we do is we just get our turn order index, we immediately plus it, so we increment it by 1, and then we just go to next character right away. So this just kind of skips over any character that is currently dead. Now, enemy characters, when they die, you probably want to destroy them, but for party members, you don't want to destroy the actors when they die. They still will technically be part of the battle, but when it's their turn, they will just get skipped over. Now, when we actually want to activate something's turn, we want to, well, have a function to activate the turn. We're going to do that as part of the interface that we made. So I just got to find the interface real quick. BPI turn-based combat, right? There we have a handful of functions. Well, we only have one at the moment, which is get turn-based components. But we'll be adding a couple more. For now, all that we're going to be setting will be the set turn active. And that's going to just take in an input for is active, which will be a bool. Make sure to capitalize this so that it actually like properly displays. And we need to implement that, of course, into our turn-based characters. But we'll get around back to that in a moment. I think it makes more sense to just go through everything in the battle scene, and then once that is in place, we'll actually do the implementation of this function on our characters. We need to have a active character reference as well. So let's make a active character, or active actor, technically would probably be a better name, because it will be an actor object reference. We'll get our current active actor and set turn active to being false, because we're still working with, hey, whatever character we set for the last turn is currently the active character, because we haven't set it anywhere yet. So we want to say, hey, it's no longer your turn, stop being your turn, run whatever code it is that you do when your turn ends, which is things like the outline highlighting that you saw at the very beginning of the first video in this series. After we've done that, it's ended its turn, so now we can set the active character to being the character from our turn orders array. And then we can immediately set turn active with true on that one, because it needs to start its turn now. Then we simply increment the turn order index the same way that we did here actually, so we can just kind of copy that over, so that when we loop back around with the next turn, we have our index increased. And here we get our active character, we get the turn-based component, and we bind an event to on turn ended, which I don't think we actually have yet. So we will need to make that as well. So let's do that. So back in here in our ability system component, yeah, we don't have an event dispatcher yet for turn ended. So let's make turn ended as an event dispatcher. It doesn't need to have any parameter or anything. It just needs to tell you when your turn has ended. Now that we're in here anyway, we also need to make a function to start the turn. Because obviously that's what we're going to be doing here as well. So let's start the turn, for which we're also going to be making a delegate, or an event dispatcher rather, just because it might be useful. So let's make a turn started. And here what we want to do, if you remember when we made the gameplay effects, we made this active effects array. At the start of each turn, we're going to for each loop over this entire array, and we will apply its effects. Now, when something is set to be an infinite or a 4 turns effect, it's going to do its thing. and then deal with itself however we set it up to deal with itself. So this is the only thing that turn started really needs to do for the time being. And then at the end also calls out that the turn has started, which again, if that's relevant for anything listening out, it'll be nice to be able to send that message. So that's pretty straightforward. Now let's also make a function to end the turn. And with end turn, what we want to do is we also want to pass through a parameter, because a turn has usually, not always, but will usually have had an ability that it executed. So let's put that as an input, and that will be the turn ability. That of course will be of type ability, so turn-based ability. And we'll just remove that from the currently active abilities. Again, this is mostly here as something that I set up to deal with the basic U objects. If you're using actors, this isn't technically necessary for the most part, but it's still good to have there. Also, if you can hear the birds being really loud, I'm sorry. They're literally on top of my roof. So after we've done that, we can just turn ended event dispatcher and call it out. So now we have a way to call that out, but we don't have anything that triggers the end of the turn yet. So way back when we initially set up the abilities, so you can see activate single ability, we made this end ability delegate, right? So when we activate the ability, we also bound to a delegate and we gave it as a parameter. In this case, what we're going to do is we're going to bind to that end ability delegate again from the ability that we spawn in. And we will be creating an event. So we can just pull off of the event pin here and create an event. And that will let us select any function that matches the signature here. So in this case, it will be end turn. Meaning that now when an ability finishes, our linear script for our ability says, hey, we're finished. It's going to call out the ability ended, and that's going to run this function that will also call out, hey, that means that the turn has ended too. So the end of an ability will now also immediately mean the end of that character's turn. So with that detour a little bit out of the way, we can go back into our battle scene, into our next character code that we've been working on, and now we can assign on turn ending, where we will, just to be safe, delay until next tick. This is strictly speaking not always necessary, but it can be nice if you have some other code that is still running to do some cleanup of certain things. Making sure that that all runs before we go to the next character can be nice. So we just delay it by 1 tick, and then we just next character. Now we're going to be adding some code behind all of this later on to actually deal with player targeting and all that kind of stuff. But for now, this will make us go through every single turn in order, in theory. That should be all there is to the turn flow part of things. So after we bind to that turn event, we can then also do start turn. And here we're going to just make a temporary code to make them do an ability that just waits for 2 seconds and then ends automatically. So let's make that ability a turn-based ability. We will just make a child blueprint of this, and we'll call that a GA for gameplay ability, and we'll call that something like just wait. And here we can pretty simply remove all these pre-existing events. Then when activate ability, we just delay for, let's say, 2 seconds, and then we end ability. This is pretty much all that this is going to do for the time being. Then in our turn-based actor, we can do this in either one of the player or the enemy actors. These are going to have their own versions of how they deal with this in the future. But for now, we just go into turn-based actor, the topmost actor in the hierarchy. We go into the interfaces and we say, hey, when the turn is set to being active, we can do one of a couple of things. Number one, if the turn has been set to active, we activate single ability, and the single ability that we're going to be activating will be the wait ability, and that's pretty much all that we do there. But we also want to visualize that this is now the character whose turn it is. So for me, I set up a simple outline material for that, so we're going to do the same thing here, turn outline. Of course, you can indicate this in any way that you personally like. The way that we do this, I'm going to very quickly go over this because I made a specific video about this if you want a more slow step-by-step thing. We set this to being mask blend mode. We set this to being unlit. The emissive color, in our case, let's make it yellow, because I like yellow. And then we make sure that this is a two-sided material. We set the toSign node. We multiply that by -1. And that will be our opacity mask. And then we get the vertex world space normal. Multiply that by a distance. In our case, let's make that like 10. And world position offsets. And that is effectively a outline material now. So we can actually see that if we just put that on this thing over here, it becomes inverted. And if we use that as the overlay material, well, actually let's do it on this thing. If we use that as the overlay material, we effectively have a rendering outline. 10 units might be a little bit too much, to be fair. So let's make that like 3 units instead. So that's a fairly thin outline, and that is effectively a outline material that we can make. So going back into our turn-based actor here, we can get our skeletal mesh and set the outline, or set the overlay material rather, to our turn outline, if it is our turn. If it is not anymore our turn, we just set our overlay material to being nothing. So now we have a system that sets up that outline material. And this should automatically now, every 2 seconds, go through to the next character in line. The only thing that we need to look at and worry about at this time is to go into the ability system component and make sure that they have a speed attribute, because obviously that's quite important. So just like everything needs to have health, probably everything needs to have speed as well. So let's add in speed, display name, speed, add max value 999, sure, and the current value is 10 for all of them. Now at begin play, what I want to do is I want to add or apply a gameplay effect. That's effect to self. We want to do that at speed. The magnitude will be a random float in range from -2 to +2. The effect will be instant. We will target the current value and we will add that, and that'll all be good. So they'll have randomized speeds so that they actually have like different speed stats as well, because that's quite relevant for like things like turn order. So all that out of the way, let's see if all that works. So we have that character in the bottom right, and they don't seem to be resetting, but they do take turns, well, in turn. It only seems to be including the enemy characters at the current moment. Oh, the mistake that we made is just not setting this to a value of nothing. That makes sense. So you can just set this to a value of none, and then it will clear the material. That's very, very straightforward. So, and of course it's quite important that in the player character, it has a speed stat. So this is in the player actor. So we have this thing here that kind of got mixed up. The display name for this thing is speed, but the actual like internal name, because we set up MP, it still says MP. So it's kind of conflicting between what I set up in the base turn-based actor and what I had already set up in the player turn-based actor. But now that we have that fixed, we should be able to see that we can go through and make sure that, okay, so it has this turn, middle, bottom, top, and then it goes over to the other side and it's middle, bottom, top. That is most likely a coincidence. So let's try again, see if it has a different order. It has top, middle, bottom, and then it does bottom, middle, top. So it does this on a cycle, and you can see that the cycle is the same every single time because the speeds are the same every single time. If I had an ability that increased my speed temporarily for a certain amount of turns, it would then give me priority during those turns in this turn order. So our turn flow is now entirely fixed up, and we can actually like do this all day long because nothing is actually happening. I think next up it is time to start adding in some targeting as well, so that when it is our turn, we can then decide, hey, what do we want to target? And also filter in what we can target. After we can target things, we can start attacking things. And when we can both target and attack things, the only thing remaining after that will be choosing what abilities. In order for a turn-based RPG to work as a turn-based RPG, you need to have turns, which we now do have, but you also need to be able to select things to attack. That's quite important. So let's look at setting up targeting today. This is going to be a little bit of a weird setup because we have a couple of things competing for needing to function properly. So if we open up our battle scene, this is going to be the central piece of everything working. We have a handful of different things. We have the battle scene that's going to be handling our input. That's why we made it a pawn that we can possess so that it can handle input very easily. But then we also want the characters themselves to remember the last thing that they targeted. Because of course, if you have a character that's constantly attacking a specific enemy, you don't want to re-navigate to that enemy target every single turn. That gets really tedious. So characters should remember what they last attacked or what their last target was, and then abilities need to be able to filter on what they can and cannot target. And when they try to target something that they cannot target, they need to have a way to steer that away into something else that they can target. So there's a couple of things working against each other here. We're going to be making those things work together instead. So we need to set up the remembering first in the ability system component itself. So let's set that up. In the ability system component, we're just going to make the target a actor. So let's make a variable for the target actor. And that's going to be obviously of type actor. There's nothing really that we need to do in the ability system component itself regarding this actor. It's just a variable that we're going to be setting and getting from the battle scene. Then back in the battle scene, we're also going to be making a currently targeted enemy in this for a variable. So let's call that targeted actor. And that will be the type actor as well, which we're for the time being going to do at the very end here of the next character function. Eventually we'll put some other stuff in between there to do with UI and actually selecting abilities, but for now we are going to put it at the very end here. We're going to need a handful of functions to help with this. So the first one will be set selection by index. And that's going to be taking in an input of a index integer. We'll also make a variable for the battle scene itself, and that will be whether or not the own party is selected. And that'll just be a bool. So if this is true, we're trying to select something in our own party. If it is false, we're trying to select something in the enemy party. If you have like back rows, multiple rows of characters, maybe you want to make this an integer for which row of character you're trying to select in. We're just going to simply do this as a bool instead. So we'll put that in here. And we'll run the same function that we need to make after this on either the party array, which we get from the player controller get active characters, which is at the very bottom here, get active party, or we will get it on the enemy party, which is just a array that we have on here. So we need a function now to actually set the selection based on something in either of these arrays. So make a function for that as well. And we'll set selection in array. And that's going to be taking in both a index, of course, because we're just going to be pulling that through. But then also we need to take in the array that we're going to be working with, which will be a actor array. So we go in here and we change that to an array. Now, first and foremost, we check this array and we get the last index of this array because we want to check if our selected index, which we can also just get the index, which is all the way down here as a function parameter, whether or not that is greater than the last index that this array has. Because if it is greater than the last index that this array has, we want to loop around back to the first index, which is, of course, always going to be 0. We put this in as a condition. And if that is the case, we set our index variable that we made here. We want to set that to 0. And we're going to make this as a variable as well. So this will be our selection index, a variable on the actor itself, not local, because we want this to persist between different function calls. And we'll just set that to being 0 because we want to loop it back around to the start. However, if it is not greater than the last index, we are somewhere within the array. So we want to then check whether or not our selected index here is less than 0. Because obviously if it is less than 0, we're trying to still go outside of the array. So at that point, we want to set the selected index variable to being whatever the last index of the array is. If this is also false, however, we just set our new selected index to whatever index we input in here for the function parameter itself. So then after either of these three, really, what we do is we set our selected actor, so our target actor, to whatever this array, get a copy of what our selection index has now been set to. So selection index, put that into that array, and that's going to be our new target actor. So we can easily now set that up to either target the enemy characters or the player characters, or again, if you have different arrays because you have multiple back rows, you can also provide in those, of course. And we just give in a index 0, 1, 2, maybe 3, 4, 5, 6, 7, depending on how big your parties are, and it's going to select that properly. So if we set a selection by index, we can now use that set selection in array, just pull through the index from this parameter into both, and then provide in the respective array. So if party selected is false, we want to select from the enemy. If party selected is true, we want to select from our own party. Now that we have that, we can go back into the event graph at the very end here. Again, if you have forgotten in the meantime, we're still working at the end of our next character event after we start the turn. We're going to get our ability system component from our active character, so we can just use the one that we got here. And we will get the target actor, which you might need to save and compile this to make sure that the ability system component actually has that reference. So now we can get target, and we're going to check whether or not that target is in our own party. So we get the player controller, we get active characters, which is all the way down here somewhere, get active party, and we check if this contains a certain item, which is the target that we have here. Now it's going to check on this being turn-based actor, so we actually might need to go into our player controller as well, because I kind of just autopiloted setting this to being turn-based actors as an array. It's best, again, to make things as generic as possible, so just make this a normal actor array. It shouldn't really interfere with anything going on here, because these turn-based actor references still can be put into a normal actor array, so that's not a problem. But it does allow you to just check generic actors for like this contains node. This contains node is going to set whether or not we have our own party selected, because if our target is contained within the active party on our player controller, that means that we currently are selecting our own party. If not, we're clearly selecting not our own party, meaning the enemy party. So then we set selection by index, and we're going to be getting the index from finding in one of two arrays our target. So the index will get from a select int node. We'll base that on our own party selected value. And if it is our own party, what we're going to do is player controller active party just find item and put our target into that, the target that we get from our turn-based components. And that's going to go into the A. And if this is false, so if we not have our own party selected, we do also do a find, try to find the target, but we're going to be trying to find the target in the enemy party instead. So we put that into there, and that will then select either of the enemy or the active party based on what it currently had as the last remembered target in the turn-based component. Now, it does give you a couple of issues here because I did change the active party around, so you might need to like decouple this and recouple this. That's in the move party to battle function, and that's all fixed up now as well. So this is the system that's going to do the remembering of, hey, what did you have selected last time? And we're going to try to select that again. But that's honestly just kind of like an initial guess as to what to select, because in reality, what's going to do the selecting is going to be the abilities themselves. So if the ability allows for you to select this, it's all good. There's no problem with that. If the ability decides, hey, you're trying to select something that you cannot select, it's going to take this selected actor and actually change it to something that it is allowed to select. So this code is kind of just an initial guess as to what we're supposed to do, and then the ability is going to take over with more knowledge. So let's set up the input real quick for navigating our selection, and then we can start working on the abilities selection code, which is going to be the majority of what we have to do here. So I'm just going to set up debug up, down, left, and right keys. Of course, this would be input actions in your own game. So debug up, debug down, debug left, and debug right. And first and foremost, we want to make sure that if we try to do this to begin with, is it the player's turn, right? Because if it's not the player's turn, we don't want to be able to select anything. So we just add in a player's turn bool. So make it a boolean. And just put that in here as a branch in front of pretty much all of these to begin with. So we just, for all of them, check, hey, is this the player's turn? If not, just ignore everything after this, because clearly we're not supposed to be doing anything. So on pressed, check whether or not we are allowed to move, and then we'll actually be doing the moving. Except we're going to be checking one more thing, and that is we are going to keep track of the currently active ability. So in variables, let's make a new variable here as well and call that current ability. When we have a UI, we'll be able to properly populate that, which will be the next video. But I wanted to do this first before diving into the UI. Both this system and the UI kind of rely on each other in some ways. So I might have been better off making the UI first, but I wanted to do this first. So what we're going to do here is after we start the turn, we know that we start the turn off automatically because we've hard-coded it that way with making the ability. So we can just get our current ability and set that to our current character. So that will be our active character, and get the ability system component, or get the turn-based component. We'll set this up a little bit to the bottom here so that it's easy to get rid of, because we're going to be getting rid of this again in a little bit. But this is just temporarily so that we do have a way to set our current ability. We get the active abilities, and we just get a copy from index 0. And that should do well enough for setting our current ability to being a value that actually gets populated so that we can work with this. Again, once we have a UI, the UI is going to have a selection menu, and when we press a button, it's going to be setting this variable based on what button we set instead. But now that we do have that, we can check whether or not our current ability, if we get that, we just change that into a validated get, and we check whether or not, hey, is our current ability like even valid to begin with. So we check whether or not it's player's turn, and then we check whether or not the ability that is being executed is valid. And the reason that we do this is because the ability is actually going to take in our currently selected target and both of the arrays that we're going to be working with, the party array and the enemy array, and then return what it thinks the new selected target should be when we press up, down, left, or right. So going into the ability class, which is somewhere in here, turn-based ability, we're going to be adding a whole bunch of functions for that. So those functions will be select up, and we'll set up the parameters for this in here so that we can just copy them over. We'll make the player party, which is going to be a actor array. So make that actor and then make it into an array. We'll make the enemy party, which is also going to be an actor array. And then we'll make the current selected, which is just going to be a singular actor. Now, we do need to set up a couple of different other functions to actually work with this as well. But let's first make all the functions and then start filling them out. So We copy this over, call this select down, and then we can make select left and select right both. We're going to be making every selection option here wrapping. So if we are on the right side of the screen and we select going to the right, it'll wrap around and select to the left again. So since left and right only have like one column each in this case, it's just going to be ping-ponging back and forth between the party and the enemies. But selecting up and down, it will, when you're at the top selection and you press up, it will loop all the way back around to the bottom and the other way around. All that to say is, in my case, I just make this select other party. Again, if you have more than 2 columns, you would make a separate left and right here as well. So for selecting up, which is the first one that we're going to be doing, I want to check whether or not the party, so player party, get a reference to that, does that contain the currently selected thing? Just like we did before with the remembering thing, this is the way that we figure out, hey, are we trying to cycle through the player party or the enemy party? Based on that, we're going to execute the same new function that we're going to be making in a second here, which is the wrapping around an array function with different parameters. So let's do that. Let's make a new function, loop over array with wrap is what I called it. And that also then takes in a couple of things. So the inputs will be the array that we're going to be looping over, which will of course be a actor array in this case. Then we'll add in a bool for whether or not we're counting down. So we can either loop upward or downward through this same array. What we're actually going to be doing is kind of making a little bit more of a customized for each loop that we're setting up ourselves here. So let's make this into a singular boolean. And then we also, of course, want to have the start index where we want to start looping through. So essentially, this is a for each loop that can start at an arbitrary point in the loop and then go all the way up, loop back around, and do the rest of the loop from the start, or go all the way down, loop back around, and do the rest of the loop from the end backwards. We're going to make a couple of local variables for this as well, which will be our starting index, which is going to be an integer. All of these are going to be integers. We'll make a goal index, that's the index that we're working toward, and then the current index that we are checking. First thing we do, of course, is with loop over array is we set our starting index to what we give in as the starting index. You really can just use this parameter, but we're actually going to be doing some stuff to it. Because of the way that we are working with this, we want to prevent trying to get a negative index from our array, because that's not going to work. And since everything we're going to do here is going to support wrapping around the array anyway, the way to prevent that is to get our starting index and actually add to that the length of the array itself. Because this way, even if we count down through the array, we're never going to get under a value of 0. So our starting index will actually be something that's already outside of the bounds of the array to begin with, but since we're going to be setting up some wrapping stuff, that doesn't matter, and that's actually exactly what we want. Then we set the goal index, the index that we're going to be working toward, and that will be our starting index plus some other stuff. And that other stuff is going to be a multiplication between a select integer, which is going to select either -1 or 1 based on whether or not we want to count down. So get count down, that variable or parameter that we made here. So if we say, hey, we want to count down, it's going to multiply the length of the array by -1, add that in, and that's going to make our goal index, which again will then be lower than our starting index. But since we are adding in the entire length of the array, it ensures it's always going to be above a value of 0. But if we say, hey, we don't want to be counting down, it's going to just be adding the length of the array on top of this, which again is going to make numbers that are outside of the array scope, but that's what we're going to be dealing with here next. So first things first, we set our current index, after that to whatever our starting index is after all of that stuff. And then we get the array that we're working with. So you might need to scroll down a little bit to like get the array variable or the parameter. And we want to get a copy from that. And the way that we're going to get this is we're going to get our current index and then use a percent sign, which is modulo. And what this does is it just does a division and returns the remainder of that division. So if you're doing like 15 modulo 3, it'll be 0 because the remainder of that division is 0. But if you're doing 15 modulo 4, the remainder would be 3 because you can do 12 divided by 4. And then the remainder between 12 and 15 would be 3. This is basic math stuff that you've hopefully gone over in like school. Either way, what this essentially does is we're going to be doing a modulo between this and the length of the array as well. So we get this length and we do a modulo. And that effectively just makes it wrap around. Because we're dividing the length of the array away, and whatever remains is going to be within the context of 0 to the length of the array. The moment it goes over the length of the array, it has another like full division that it can subtract from it, which means that the modulo is going to wrap around back to index 0. So that is what we hook up to the getting of the array. Now, you can actually kind of collapse this into a blueprint library function if you want to, because this is just generally a useful function to be able to use. I might make it into a macro because macros support wildcard parameters, so that you can make this a more generalized array even than a actor array. But this generally is like a good thing to have. We're just going to keep it in here because we in this project don't actually use it anywhere else. But it's nice to have. So what we're going to do then is we're going to check whether or not this actor can be selected by this ability. So for that we need to make a separate function. Let's make that function can select. And we'll set the output for that to be, well, a can select boolean. And the input will be just a actor. So this will be the actor that we will be checking. And the default of this is going to be just returning true. This is the function that you need to override in any of your child abilities, where you can script out per ability, hey, so what are the rules that an actor needs to follow in order to be selectable by this ability? So you can check its HP, if it's below a certain amount, if you want to be a heal ability. You can check its affiliation between being a player character or an enemy character, if it's like an attack or whatever. The default though, if you don't override anything, is just everything will be selectable. So going back into loop over array with rep, we can now use this can select on the actor that we got out of that array. And this is pretty much what we're going to be doing for everything until we find something. So if we can select, if this is true, we immediately return. And we're going to be returning the output from this getting operation, because we've now found the actor that we're going to be selecting. If we cannot select this for whatever reason, what we need to do is we need to do another branch, because we're going to be checking whether or not we're counting up or we're counting down. So get count down, select that and do that up to the branch. Because if we're counting up, we want our current index to be incremented. If we're counting down, we want it to be decremented. So count down will be minus minus if it is true. And it will be plus plus if count down is false. So that's what we will be doing there. Then we put in another branch, because then we need to check, hey, did we now reach the end of the array on? For which we also need to use the countdown, because we're going to check this in one of two different ways. So in this branch, we actually want to select a bool based on our countdown here. And we'll use our current index and our goal index. And depending on whether or not we're counting down or up, we're going to be checking whether or not one is bigger than or smaller than the other. So we'll check if our current index is larger than our goal index. And we'll put that into the top here, into the false. So if we are counting up, we want to check if our current index is now bigger. But if we're counting down, we of course want to check, hey, is it now smaller than our goal index? And that's going to go into the true pin of this. If this is true, we also return, but we return without any output. If it is false, however, we're going to loop back around to the can select that we have here. And we're going to do the whole thing again. And voila, we have a customized for each loop, which we just set up a couple of reroute nodes, which you can do by double clicking on a line. So that's a little bit more readable. And this is the whole function that wraps around our arrays. So now that we have that set up, let's go back into our select up, which apparently I did my work in the wrong thing. So I accidentally put it in the select other party. We're going to go into select up. That's my bad. And put all that in. So if we're trying to select up and we already have our currently selected thing in the player party, we're going to do the loop over array. And we're going to be using our player party to loop over. We want to kind of counterintuitively, depending on how you have the order like physically set up in your battle scene from top to bottom, whether or not it's 1, 2, 3 or 3, 2, 1, you might need to change the select up and select down functions around, or change the positions around to match what I have. But maybe counterintuitively, since we're cycling up, we're going to be setting count down to being true. And then the starting index will be our player party. And we're going to be finding our currently selected item. And we subtract from that 1. Because we want to start looking for whatever we have as our next selection, 1 up, which is 1 less in the array, from what we have currently selected. And all the wrapping stuff will be dealt with by this function itself. So we just set that to happen when this is true. And when this is false, we kind of do the same thing, but we just do it with the enemy party. So we get the enemy party, put that in as the array. We're still going to be counting down, and the starting index will still be currently selected finding -1. But we just put that in through the enemy party instead. And then the output for both is going to also be the return value of this function. And that's the basic setup of cycling up. Now, cycling down is actually pretty much the same thing. So we're just going to copy this entire thing over, go over to the select down function, paste that in. It's going to maybe complain at me about the return nodes, or maybe not. It automatically adds in the output. That is fantastic. Hook this up to this branch, of course, for the initial input. And then we have to, obviously, change a couple of things slightly around. Because now that we're doing this in the opposite direction, we just need to change count down to being false on both of these. And instead of doing -1 after the finding node, we do +1, because we're going to be cycling the other way around. And that's everything you need to change between the cycle up and the cycle down. It's actually remarkably simple once you have all of the functionality set up to implement these two functions. That only leaves the selecting of the other party, which we can do. So let's go over to select other party, and this requires effectively the same thing again. So we just copy over, apparently I had something else on my clipboard there. We just copy over this entire thing one more time to loop over or to select other party. Put that in. And what we'll do here is we'll get rid of the addition node after find. We just put in actual finding into the starting index here. And here we just have to switch up one little thing. So we're going to be looking over the party for the finding node, but then for the actual thing that we're going to be selecting, we'll be using the enemy party because we're switching parties, right? And here, the same thing. For the enemy party, we're going to check with the finding node the enemy party, but then the loop over array with wrap, we're going to be using the player party for, because this way it'll be switching whatever we have in the enemy party to the corresponding index at the player party, which is when you have the enemy party, the third selected is going to move to the third selection in the player party. That said, if the player party only has two things, this function again deals with all that wrapping stuff, such as going to select the last index that it can find, which will be like the second or maybe even just the first. So that's all the selection logic done on the ability itself. There's one more function that I want to make, and that is just something that we do whenever we start a turn. And that is checking, hey, the thing that we currently have selected, are we allowed to have that selected to begin with? And this is quite relevant for if you want to do an ability that doesn't allow you to attack the thing that you currently have selected from the last turn. And it's also going to be relevant checking whether or not you're trying to do an ability that you cannot even target anything with at all. Because if you can't target anything with an ability, you just want to kind of prevent the player from even starting up that ability. in the first place. And we can just copy over the select up thing again, because we're going to be using the exact same setup parameters, but we'll change the name to update selected target. And then the very first thing that we do is our current selected, can that be selected? So can select on whatever we have currently selected. Because if what we currently selected is allowed to be selected by this ability, everything is good. We can just use this and immediately return whatever we currently had selected. There's no problem there. That's the easiest path. Everything is well in the world. So we can just return, and we'll return currently selected, and that's it. If not, we're going to need to loop over both of these arrays to find the first thing that is allowed to be selected. So there we check currently selected being in the player party. We hook that up to the false part of the first branch. We get rid of these minus nodes, just like we did before. And we're just going to kind of first check whether or not we can find anything in the player party, if the player party is what is currently selected, that can be selected to begin with. And the same thing with the enemy party. But there is a chance that nothing in the player party is actually selectable by this ability. So we need to check whether or not the output from this is valid. So we check is valid. There's just a nice little macro for that. If it is valid, that's fine. We can just output that as the newly selected thing. If it is not valid, however, what we need to do is we need to loop back over this one more time. But instead of looping over the players, we're going to be looping over the enemies. So we put in the enemy here. And we once again use the currently selected finding as the starting index. You can either count up or count down in this case. It doesn't really matter. I like to set count down to false for all of these. And here, once again, we just return whatever is outputted from this. So if this is now invalid, that means that there's just nothing on the battlefield that is selectable by this ability. So we can check in our battle scene after we do this, like, hey, is whatever this function outputs valid or not? If it is, good, we can just do this ability. If it is not, we need to go back around and make you reselect another ability. Again, that's something that we'll probably do in the next video when we actually have like a UI with a couple of different abilities that we can do and select between those abilities. So now all that we need to do is we kind of need to do the same thing but in reverse for this bottom path. So we check our enemy party, we check, hey, is whatever our enemy party contains, does that contain something that we can select? Is that valid? If it is, we return. If it is not, we copy this over, take away the enemy party from that, and replace it with a reference to our player party. And we start at index of currently selected find. We hook that up to is not valid over here, and then we return whatever that gets us. That's a lot of stuff, I know, but we're almost there. We can now go back into the battle scene and use our up, down, left, right keys to actually run those functions now from our currently active ability. So we can select up, and all that we need to do is we need to provide in our enemy party whatever we have currently selected. So that would be our target actor, and then also our player controllers get active party player party. And then we just also do the same thing with a select down, where we also player party, enemy party, currently selected actor. And then for both of these, we actually kind of do the same thing anyway. So what we do is we just get another reference to our current ability, and we select other party. And we just do that for both. Because again, whether or not we are going left or right, we're always just switching parties. And I personally like the fact that it can wrap around. Again, if you don't, feel free to make changes to however you like it. But enemy party goes into enemy party. Active party goes into active party. And target actor goes into currently selected. So now with all of that set up, we can set up a quick little extra function to just like set a new target. So let's make a function for that. Set new selected target. That's going to take in an actor reference, so actor singular, First and foremost, we check whether or not this is valid or not. It's quite important. And then we want to set it targeted. And for that, we're going to go, once again, back into our BPI turn-based combat. We have get its turn-based component, setting it active. Now we also make a set targets, set targeted, which is going to take in, as usual, just a bool is targeted. We'll implement that in a moment on the actual character. It's going to do something very similar with setting up a outline on the character. But now that we have that, we can run it on that actor. So set targeted by message is targeted will be true for this thing, obviously. And we'll need to set it to being false for whatever was previously targeted as well. We'll circle back around to do that in a moment. But before we set this to being the actual like new target, we also need to set whatever was previously targeted, which is the targeted actor, to no longer be targeted as well. And just after we've done that, we can set our targeted actor to being the input from this thing as well. So we hook that up like this. But then when we have done that, we also need to update the target in the actual component, the ability component that we made. So we get our player controller. From that, we get our active party. This only is relevant to things that are controlled by the player. So the AIs don't need to like update their targets or whatever, because they're going to just like do all that by like AI magic, figuring out who they wanted to target. Or in my case, just randomly. So we get our active party and we find the character that is currently active. So that's not the targeted actor. That is the actor whose turn it currently is, to be very clear. And with that, we then get a copy of that from that same array. We get the turn-based component. And in that, we can then finally set the target actor to whatever our new target actor is from here. Now, once we have a UI, we might also want to set like our currently targeted enemy to display its stuff in the UI. But again, for now, that doesn't really matter. All we need to do is now make our ability, instead of instantly starting, what it needs to do is it needs to understand that it has been selected, and then it needs to start once we actually give it the signal to start. So let's go back into our ability class itself, and there in the event graph, alongside end ability and activate ability, I'm going to make a new custom event for select ability. This will be overridable by all of its children as well, just in case we need to like set up any specific like custom code for a specific child. So going over into the ability system components, when we do a ability, so activate a single ability, we're going to add a new parameter to this activate single ability thing, and that is whether or not we need to skip the selection. So skip selection. This is mostly for when an AI uses this ability, because again, when the AI does this, they don't need to, select anything, because this is, strictly speaking, selection for the player. So before we like activate ability, what we do is only when we skip selection do we immediately activate the ability. If we don't skip the selection, what we'll do instead is make a reroute note here, just so everything's a little bit more clear. We will do whatever we put in selectability, which again, for the most part, is going to be nothing. But just in case we want to put in any code there, it is now an event that we can populate. In my reference project, I, in no ability, actually put in any code there, I believe. This is just to prevent it from immediately starting up the ability, but it now has been created. Which finally allows us to go back into the battle scene, back into the event graph for the battle scene, and go into where we have all of our keybinds set up, which again is just debug keys. This would be just input actions in your own game. And I'm going to put a debug key for enter in. And what that's going to do is it's going to also check whether or not it's the player's turn and do a validated get on the current ability. Because once again, we want to make sure that we're doing this properly. And then we'll actually activate the ability only when we press enter. So now we get the option to choose who we want to attack with this. But not before we tie up a few loose ends still. Number one, we're never actually setting this player's turn thing. So let's actually set that up so that that knows whether or not we are, well, inside the player's turn. And we do that within the next character event. At this point, it might also be worth like setting up some comment areas, just so that you can easily distinguish what is what. But we'll do that in here, and we'll do that immediately after we start the turn. We can just check our player controller's active party, and we can check whether or not that contains the currently selected or the currently active. Don't confuse the two. They are very much different things, but the currently active character. And that'll just be the value of whether or not it is the player's turn. So if there's an enemy that is taking a turn right now, this is going to get set to 0, which is going to effectively just block all of these inputs for us. If this is a player-owned character instead, this will be set to true, and we can do all of the inputs that we want. Next up, another loose end is the fact that we, at some point, if we go through, we made this set new selected target, and we never actually put it in anywhere. So at the end of every one of these key presses, we just get our selection output and put in that new selected target to all of those places. So that's going to be all 3 of these. And then just to put it in place already, it's not going to matter that much, but after we set the new current ability, which again is going to always be the same ability in this case, so it doesn't really matter, but after we set that, it'll be variable starting in the next video. We want to update selected target, because now we have a new ability that has its own like criteria for what it can target and what it cannot target. So we want to immediately update our current selection. So that's going to take in, of course, our active party. My mouse cursor is really dying on me. I'm very sorry about that. It's going to take in the enemy party and what it currently has selected as a target. So that will be the targeted actor. And then we also set new selected target based off of that. Now, if this is invalid, again, something that we'll worry about in the next video when we actually can start selecting abilities, we need to then loop back around to selecting a new ability, but that's all UI related stuff. So a lot of what's going on here, the reason that it's messy is because it's very temporary. Next video, we're going to rework some of this, but we need to put something in there for now for it to work. All that leaves us with only one last thing to do as far as I remember, and that is in here. We are setting this set target on whatever we're trying to target, but we're never implementing that in of any of our actual characters. So let's go back into the turn-based actor, and now in interfaces we also have the set targets. And here we're going to just copy over the outline that I made before, target outline. Of course, ideally, this would be like a material instance instead of an entire different shader in of itself, but it doesn't really like matter for what we're doing right now. We're just going to make that a red outline instead, or more orange, it seems. It's fine too. Going into our turn-based actor again, we want to check, hey, is this now what we have like targeted? If we have become targeted, we set the overlay material again on the skeletal mesh. Put this in a place where it's a little easier to see, to that new target outline. If not, we want to check whether or not it's this thing's turn, because we need to know whether or not we need to set it back to the turn outline or back to nothing. The way that I did that in my reference project is having a isTurn variable. And we can put that on the ability system itself if we want to. So ability system components, put that isTurn on there, boolean. And we can pretty easily just, when we start the turn, set isTurn to true, and then when we end the turn, set it back to false. So we don't even need to like involve any like other weird stuff there. So start turn and then end turn, we set it back to being false. You see, even as I'm recording these, I am improving stuff about what I did on my reference projects, because there it's not on the component, there it's just on the turn-based class itself. But we now have a way to check, hey, is it this thing's turn? Yes or no? And we get that isTurn, put in yet another branch for that. If it is not its turn, we set the overlay material back to being nothing. If it, however, is currently still this character's turn, because you might be able to like target yourself, either for attacks, strangely enough, or maybe for like healing and that kind of stuff. You want to be able to target yourself. But if you detarget yourself, you still want the outline that we have here for when it is this character's turn. Now, a lot of this is just easier to set up if you highlight stuff in your UI instead of highlighting it in the characters maybe. But I like having it display in the world itself. So this is how we're going to set that up. Now, let's dive into this and see if I made any mistakes, because I've been at this, recording this video for an hour and a half. So there's likely some mistakes that crept in. Usually I end up, during the editing phase, splicing those fixes in real time. But this video is, just by nature of it being so divided over a whole bunch of places, it's already chaotic enough. So I kind of feel like if there's any mistakes that I did make, this part will remain in. If it just works, I'll cut this out. I'm gonna just do those at the end of this video for this one time, just so that it's a little bit easier to follow along linearly. Anyway, let's see what happens. So one of the little mistakes, and this is why I think that it's fine to not cut these in the video itself. I'm adding a quick little voiceover here during the editing. We are in the battle scene blueprint within the move party to battle event. That wasn't very clear in the original recording, so I wanted to make sure that you know where we actually are doing this stuff. At some point I changed this for each loop around to being a generic actor instead of being a specific turn-based actor. And that kind of disconnected this set actor hidden in game thing. So it made the characters invisible in the game, which is not ideal. But now that we have that fixed, it will show you the actual characters, and we can see that we have the red outline, and I can wrap them around, up to down, down to up, left to right, right to left, and when I'm in the middle, I'll actually select the opposite one. I can make it select itself, and all the selection is entirely valid until I press enter, at which point it will do the ability, and then it will go to the next thing. Now, we do probably want to set up a default selection for every single of our characters, because right now its default selection seems to always be itself, which is a little bit tight. So what we probably want to do is set up the default selection to always be the thing that is opposite of itself. So let's quickly implement that as well, and then we will have our targeting system all in place. And you can see that this is kind of like growing quickly. So let's see where I should set that up. So the way that I did this in my reference project, and I think I'm just going to take that over here as well, is I made a function to set a specific party member's target to a, well, target actor, which is what we already do here in set new selected target after every time we press any of the buttons. Because what we do here is we get our active character, our party, we find, we get, and then we set that target, right? So what we can do is we can just kind of select all of this and collapse it into a function, set new party member target. I don't know, that's a pretty bad way of saying that actually. And instead of making that just our active character, what we will do is we'll move this out of here and make that selected by index. So party member index, put that up the top because I just think that's a little bit more neat. And then if we go back into that previous function, which again is set new selected target, we now have this party member index, and we can just put that in like this. We also copy this back over. So that will now function the same way that I did before, but now we have this as a standalone function where we can just set, hey, get a specific index from our active party, get its component, and set its target to whatever, right? And the reason that we want that is in the event graph, after spawning in any given enemy, we're going to be adding in a function called to that, so set new party member target. And what we're going to do is just hard code this to set, okay, party member 0, its target is going to be this thing. And then make sure to hook everything up properly to nodes on either side. move things over a little bit so that we have the room to do what we need to do. So all of this, let's go a little bit over in that direction. And then party member index 1 is going to get the target for the next one. And then lastly, before we set the turn order, party member index 2 is going to get the target for this. Now, that still does mean that we, when there is no target being spawned in, this is not going to be run. But much like what we did before over here somewhere, this is just setting the initial suggestion. Once we actually start selecting an ability, it will just snap itself to whatever it can select with that ability in mind. Now, it does actually select the proper target when we do this all now. It just doesn't display it yet properly because it doesn't quite yet have this variable populated. So we can just check where all that gets set and see if we may be missing something. So we can right click and find references by name. All the getting we don't care about. Setting, we set it in set selection by index, and we also set it in this, which is set new selected target. So the issue here is that we are using the set new selected target with the target actor. So we're sending through something that doesn't have a value to set something that doesn't have a value yet. So to give this a value before we go into this, before or after making the current ability, that doesn't really matter. Also put in the set selection by index, because what we do there is put that in. And the index will be gotten from a select integer node, which as usual, we're just gonna get like the enemy party and see if that contains the currently active character. And in this case, we're gonna check whether or not from the turn-based component, it contains the get target actor. Put that into the bool for the select int. And if it does contain it, we just find that item in there and return that as the int. And otherwise we have our player controller active party and use it to find it in there instead. So target goes into there and as B. So that will set something to be the value of this target actor variable. Before we even get to this, which again will then maybe change that selection, but it will have a good starting point. This needs a starting point to work off of. That's why we made this separate function. And then with this contains, we also want to set our own party selected bool. This really is starting to be a bit of a mess. I thought this was going to be a couple of nodes, but it started growing out of proportion a little bit. We'll clean this up next video when we actually start implementing the UI. I've said that a bunch of times at this point, but let's see if that works now. And of course, I mixed this up because I've been recording for 2 hours. Don't check if it contains within the enemy party. You need to check whether or not it contains within the player party, which also makes these two the wrong way around, of course. So just to be very clear, we want to check whether or not player party contains our target. That's going to be setting whether or not we have our own party selected. And then if that is the case, on A, we're going to try to find our target in our active party and get its index to go into set selection by index. If this is false, we'll instead try to get it from the enemy party. And after we've done that, we go through setting ability and setting our updated target. It's good to check whether or not what we output is valid, just to have that in there. Then we select our newer target, and then we have this like own party selected thing and select int and select by index. That's what we're doing here already. So we kind of just move that over. So we don't need to do that again because that might mess us up a little bit. So anything regarding that, we just get rid of. And I made a tiny little mistake because what happens here is at the start of every turn, we in new selected target, we give in this actor, set it to being target, but then the targeted actor will get set to being no longer the target. Unfortunately, this targeted actor is already being set elsewhere. So what we're going to do to change that around is we check whether or not this actor is valid still. I mean, that's important. But then we just use this targeted actor 2 different times. So we do this first here, and then we set this to being false. Then we set this targeted actor value to being whatever we input there. And then we use that updated value to set this to being true. So the important thing here is that if you put in the value that already existed, or if there's any like 2 functions that are both dealing with the targeted actor, it's going to set it to false first and then set it to true. So the final position of what it does is setting it to true. If you do change the targeted actor here, it's firstly going to set whatever it used to being false, and then the new one is going to set to true. So that will get rid of any conflicts where it might not be properly showing you this targeted activation. Which, now you can see, if we start the game, it auto-targets the thing opposite of us, and we can change the target to whatever we want, of course. Do the ability, it changes no target because it's doing the one opposite of it. So let's actually change this to being the top. Then the third one is going to pick the one at the bottom. There's a little bit of an issue here at the end of the turn still, where it doesn't clear up when it auto selects the new target, so we'll fix that as well. But we'll be able to see that if we set this to the top one, when we circle back around to the one being on top, so it doesn't clear that up. That's a little unfortunate. But that is fairly easy to fix up, of course, because we can just get our currently targeted actor at the end of any given turn, or of course the start of the next turn, which is what we're going to be doing. So at the start of any given turn, we just do next character, set target to not be targeted anymore. And that should take care of that. So now we can say, I want that one to be targeted. I press enter, and then, well, that was actually a bad example. But now you will see it will actually switch over. The only issue is that with the targeting as it stands right now, we don't really have any difference between the players and the enemy characters. So we're going to be stuck in an infinite loop. And that is where we do make a different implementation for this basic start turn active, because one of these needs to skip selection, the other one does not. I'm just going to promote that to a variable for now. Again, we'll need to set up some actual handling of ability selection differently between the 2 of these, but for now we'll just make skip selection a variable that we can set to being true on the enemy actor, so skip selection, and that will make it just auto execute the ability without needing a target, which this ability in specific doesn't require a target, obviously, so that's fine. So let's just mash through here real quick. Take about 2 seconds for every ability to go through, but you can see the targeting works properly, and now it should go through fairly well. Now it does seem to automatically go ahead and pick the next target as well there, which is a little weird. But that is because all of this stuff, which has to do with setting the proper targeting, only needs to happen if it is the player's turn. Once again, I'm afraid that it might not be entirely clear where in the blueprint graph we are. We are still in the battle scene, and this is toward the end of the next character event to begin with. So we check, hey, is this the player's turn? If not, we don't want to do any of that stuff. So we can once again just go through this, checking whether or not that fixes it, and it should. So now you see there's no target highlighting because there's no targeting because it's not the player's turn. But now when we go back to it being the player's turn, it will have the highlighting for all of the targets. And if we go through and we select like different targets for every single one of these, it will remember which ones we picked. So we just need to wait a couple of seconds for this cycle to complete. And there we are. We picked the middle one with our top character, and it has remembered that. So that means all of our targeting stuff now works. Again, I know that this video has been a bit of a chaotic mess, but the good thing about that is that this is the most chaotic and the most difficult part of setting up this system, just because it has so many moving parts and so many things that are easy to miss and to forget. And it's just been a lot, I know, maybe you need to go back over and watch certain sections. Again, this little end section where I go through and fix issues. Again, usually I would intersplice it within the video, but I am afraid that that's going to make the video even more chaotic. Having this all at the end here hopefully is going to make things more clear instead of less clear. If not, I'm sorry. Once we have this all working, moving on to the next video where we do all the UI stuff, everything is going to end up being a lot easier because now we have all of the building blocks and we only need to start telling the systems what to do. So there's only a couple of parts left, and we'll be getting started with proper ability choosing and UI stuff in the next video. So the target selection video turned out to be long and fairly in-depth. So hopefully today we can set up some UI stuff fairly straightforward. This is another one of those things where what you want to do with your game might differ from the exact things that we're doing here, but before you go ahead and make any changes, just follow along step by step so that you know that what you have works and that you understand that, and then go back in and tinker once you're done with the entire thing. We'll dive in a moment and also redo some of that stuff that we did last time to work now with our UI, because we're going to be able to select buttons and that kind of stuff. But for now, let's go ahead and make a new folder for our UI. I think that's probably for the best because it's getting a little crowded in this folder. So make a new UI folder and add in a new user interface widget blueprint, and we'll call this the Battle HUD. I'm just going to make this fairly straightforward. We're going to show the HP and MP of our character that we currently have selected, and then we also are going to display the HP of the current targeted actor. Now again, for a full game you might want to set something up where you see all of the characters on screen at the same time in your UI or whatever. That's entirely up to you to implement. It's very game specific on how you want everything to work. Maybe you want to obscure the actual HP of your enemies. You only want to see like an HP bar. Maybe you don't want to see any HP information on enemies. That's not really up to me to decide how you're going to deal with that in your game, of course. So, as you can see, we started with a canvas panel because we want to add this as a whole to the screen. Then I want to add two borders, one for the player, so player, and then another one for the target. And both of these are going to be at the bottom of the screen, somewhere around here. Sounds pretty good. Set the anchors to be aligned with the corners of this border. And then I kind of just want to take the canvas slot information from this one, which you can do by shift right clicking on the top here. And then to the target, we shift left click, just copies it over. And that lets us move it to the side, holding shift snaps it along a axis. This may be a little bit more to the left. Update our anchors to properly reflect where they are actually on the screen. And then for this, of course, you do need to then update the anchors to align with these corners. Basic UI stuff. So now that we have those, I want to select both of these and set the brush color to be alpha, I don't know, 0.5, so that they're a little bit see-through. And these are going to be the borders that we display everything inside. So, for the player, I put in a horizontal box because we're going to be putting two things next to each other. And inside that, I put a size box and a vertical box. So, let's put in a size box and then a vertical box, both into the horizontal, vertical box under the size box. Inside of the size box, I put another vertical box. This is just a lot of setup for a bunch of stuff. Again, this is mostly up to personal preference how you want to set this up. And inside this vertical box, I'm going to be putting a bunch of stuff. So I'm going to be putting in some text. Number one, a text for the name of whatever is in here. Then one for the HP. And then one for the MP. And we'll also put in a couple of progress bars in between. So after the HP, put in a progress bar. And after the MP, we put in a progress bar as well. And this is all in a size box so that we can set the width override. So that the HP bars can be of a decent length. Maybe it's also nice to put in a spacer between the name and the rest, so that we can add a little bit of padding on the bottom here. So maybe like 10 units of padding, maybe even like 20 units of padding, creating a little bit of distance between these two things. So that'll be all the data for the player character. Now we also want to add into this vertical box over here, the second one. So if we collapse everything, we have as children of the horizontal box, size box, and vertical box. That vertical box is going to have a size box in it. So it's the other way around from what we just did. And that size box is going to have a scroll box inside of it. And the scroll box we will call abilities, because this is going to hold all of our abilities. Make sure that that is a variable. And then inside of the size box, vertical box, we also want the name, the HP, progress bar, MP, everything there to also be variables. Because everything about this we're going to be setting dynamically. And then we do something a little simpler for the target. For the target, we simply just put in a vertical box. And in that vertical box, we simply put in a text for the target's name. So that will be target name and just one progress bar for its HP. I'm not going to be setting its HP text in this case because I don't feel like it, frankly. So HP targets. Also make sure that both of those are variables. And that'll be the setup for the widget itself. Now we can start getting down to programming this widget, which is actually not that complicated. There's not that much going on. We first want to get our currently active character and set all of its corresponding information to these things. Then whatever we target and set the information to these things, and then we want to loop back around at the end and start populating this abilities list as well. So let's go into the event graph. And first and foremost, before we do anything else, I want to just make a custom event to clear the UI, because we're going to be doing that quite a lot. So clear UI. And what that'll do is it'll get the abilities, clear all children, because we're going to be adding a lot of buttons to this. And every single time that we do that, we need to clear those buttons out when we want to add in new different buttons. We might come back here and add in some for loop later, but for now I want to add a new custom event to set player info. So set player info, and that's going to take in a player reference, which is just going to be a normal actor. So input for the actor here, and that will be a object reference. And we're going to just upgrade that real quick to a variable. So this will be our player. My Unreal has real issues with auto-selecting fields to type in, apparently. So once we have that, we get the turn-based component from it. And before anything else, what we can do is the name, which I think is this one. We can set the text with set text, this one over here. And we can just get the player's display name. Of course, if you do have some sort of name system, like a variable on these things, maybe like cast it actor and then get its name variable from that. We're just going to go with the display name for now, but you can do whatever you want with that. Then from the ability turn-based thing component, we can get attribute. Of course, both the current and get attribute maximum. It might be worth making a function that just gets both and gets you a percentage between the two of them if you're going to be doing this a lot throughout your game. But in our case, we're only going to do that here once. So we're just going to type in HP for both and get both. And then we're going to divide the current value by the maximum value to get a 0 to 1 percentage out of that. And that will be one of these progress bars that I did not name. So let's see which one that is. That will be HP bar, and then this will be MP bar. I don't think I have MP on my character at the moment, so I'll be adding that in a moment. Just to show you that that works. We get the HP bar, and we set the percent on it to whatever we get out of there, and that is that. And then we do the same thing with the MP bar, but just with the stat called MP. So we copy this over, hook this up to there, copy this one over, hook that up to there. and I have two of them on top of each other. Hook that up, and now the only thing I have to change here is changing these HPs to MPs, and actually make sure that they are hooked up to the ability component as well. And that sets up both of those bars. Now we also want the HP and the MP to have text on them. We already have all the values that we're going to need for those, so that's actually pretty easy. We can just set text. The text we are going to get from string, so we do to texts and then string. And the string we're going to make with a append node. So we're going to append the current HP that we have, then add in space/space, add in a new pin, and then put in the max. Now, what you might want to do actually is you might want to put HP colon and then the space bar, so that you can actually see that it's HP, but hopefully you kind of get the point of what is going on here. And then we do the same thing once again with setting the MP, getting an append node as well, and we pretty much do the same thing. We just change HP to MP, and we take these different values, and that gives us these values. Now these are going to be float values, which is less than ideal. So what you might want to do actually is take these values and floor them, or well, seal them maybe. Sealing is always rounding up, flooring is always rounding down, so that they just display as somewhat more neat integers. Otherwise it's going to display as number.0, and this way it's just going to display as a round singular number, which is just a little bit nicer to look at. Again, it doesn't really impact any of the actual like code stuff, literally just for visual representation. So that's setting the player info. Then we also make a custom event for set target info, which will more or less do the same thing without the MP and without the text. So we'll just take in a input for the target. This one we don't even necessarily really need to set to a variable. The reason that we set this to a variable is mostly to do with the ability stuff that we're going to implement in a moment. Even there it's not necessarily needed, but it's just like nice to be able to do. So we just get the turn-based component. We set the text for the name of that thing. So we just copy this over. Target goes into there and into there. And then we just take the HP percent thing, do all of this, copy it over, make sure to hook it up to the component that we're getting from this interface, and then actually setting the target HP, which I think is this one, and hook that up. And now we also have our target. So all that we need to do now is go back into our battle scene, which is that massive, messy blueprint, and provide in whenever we update our player info and whenever we update our target info. And that's actually remarkably simple. And then we'll set up the actual abilities to choose from. So let's go back into here. Somewhere in here we have our battle scene. It's fantastic. So how do we do this easily, right? We have, anytime we move with one of these keys, we are setting a new selected target. So at the very end of setting a new selected target, what we can just do is update our HUD, for which we actually do need a reference to our HUD first. So when we start the battle, at the very end here, what we'll do is we'll create a widget of type battle HUD, maybe even promote that to a variable. We'll call that HUD, and then we'll add that to the viewports. We do need to have that as a variable, obviously, to access it, but also to remove it eventually when the battle ends. But now that we have that as a variable, again, we go back into set new selected target. And at the very end of that, we do HUD set target info. And we just put in our targeted actor variable in there. And that will update our target info as we scroll through. Now, for our player info, that's equally as easy, really, because we already have this whole like flow state of turns. So move party to battle, that's not it. Spawn enemies, that's not it. Next character, that's it. So over here we already have something that's also gated off on whether or not it is the player's turn. So what we do is if it is the player's turn, we do all of like this stuff over here. Somewhere in there, it doesn't really matter where. I'm just going to do it pretty near to the beginning here, I want to say. We take our HUD and we set player info. And we can set that player info with whatever character is currently our active character. And that should really give us the display that we need. Of course, we do need to also go in and make sure that our player actor in the ability system components actually has MP, because right now it only has HP and speed. So let's add in MP. Name will be MP, display name, call that MP as well. Let's set the max value to 100 and the current value to 50, just so that we can see that it fills up properly. And while we're at it, let's see the default percent for both of these a little bit up, because this color is pretty good for an MP bar, but the HP bar obviously needs to be green. So we can go to color and opacity. My screen is freaking out a little bit, so I'll just set them manually. Set this to green so that the HP bar is actually green, and then for this one also set the HP bar to be in green, just to make sure that everything is the way it should be. Percent, set it to a default value so that we can see something. That seems pretty good. So now if we start a battle, we'll see we have our BP enemy actor and our... Okay, so it's actually given in the wrong thing there because I put in the target enemy. And of course, if you're going to be copying things over, do make sure that you change this name to target name, and then this HP should be the HP target as well. So now you'll be able to see that if we do this, we see our player actor 2 is what is currently doing something, has 100 HP. The MP isn't properly populating, so we'll look into that in a moment. I probably forgot to hook something up. But on the right side, we can see enemy actor 2, 1, 0, and so on and so forth. If I go ahead and end my turn, we can see we move over to player actor 1, which has its own targeting. So we have visualization for our targeting system and our actual turn system now. Going back into the player HUD, I didn't do something with my MP settings properly. Yeah, I just didn't hook up this node. That's just stupid on my part. So that's the most straightforward part of this video. Now we're going to do the ability selecting, which is going to take a little bit of work. First and foremost, going into the UI, we need to make a custom button for this. Or at least that is the most straightforward way to do this. So to user interface, widget blueprint, user widgets, and we'll call this the ability button. The ability button is just going to be a button, to nobody's surprise, that is going to have just a simple text block on it, honestly. Can make this a slightly different color maybe, if you prefer, like make it 0.2 and everything, so that's like very dark gray. You can style this however you want, obviously. So the text block, we want to make a variable. The button already will be a variable, and then we'll go into the event graph. Setting this up is going to be fairly easy. All that we need to do is we need to make an ability that this button is going to represent. So that will be a type ability, turn-based ability, class reference. We want to make that instance editable because we want to expose that on spawn. And then on event construct, we want to get this text, set text to this abilities, get defaults, and there we have the abilities name that we can provide into it. So we're going to need to give the abilities actual names, otherwise it's not going to show up in these buttons now. That's pretty much everything for the construct. We don't need pre-construct or tick. What we will need, however, is going to be a event dispatcher. So ability picked or something like that is what we're going to call this. So ability clicked. Horribly misspelled, hold on. So when we click this button, when we press this button that we have here, so this button, we can do onClicked. We're going to call out this ability clicked, but ability clicked is going to need to have a parameter. Parameter is a ability that we chose. So we can just do that and make it again a turn-based ability class. So turn-based ability class reference. When we click on that, we pretty much just call this out with whatever ability we gave in when we created this button. Now, to make this keyboard friendly, I'm going to add a couple of other things because I like making things keyboard friendly. I'm going to add in a debug key for enter, And here we want to get player controller. And we want to check if this has user focus. Because if it doesn't have user focus, this will still fire. So we want to kind of just block anything happening. Because if it has user focus, we want to delay until next tick. Because we're using the same button here as we are with selecting our targets, which might conflict if they happen on the same tick. So we want to just delay this for one tick so we can select our target with enter and then have to press enter again to confirm using the ability. We will call ability clicked as well. So now we can do this from the keyboard easily. And to make this actually show what is selected with the keyboard as well, otherwise you might not know what you're about to execute, right? We have an event on added to focus path and also an event on removed from focus path. And in both cases, we'll just get the button and set the background color for it. If it is added to the focus path, I guess we'll make it a nice light blue. And if it's removed from the focus path, we'll just set it back to being white, which is the default color. So that'll also show you which button is currently selected. So now we have this entire button working. Again, the button is fairly simple. Going back into the battle HUD, we now need to actually construct a whole bunch of those buttons based on the owned abilities of our player. So let's move this stuff over a little bit and add in, just for organizational purposes, a sequence node. I'm going to move all of this stuff over to being sequence 1, and then sequence 0 is going to be setting up all of the ability stuff. Doesn't really matter what order you do these in because they're entirely independent of each other, of course. But here we go. So what do we do? Well, we get our ability system component, or our turn-based component. I keep calling it the wrong thing. And we get the owned abilities. So get owned abilities. Because for every owned ability, we want to make a button. So for each loop, and in that for each loop, we will create a widget. And we're going to be creating a widget of the type ability button that takes in an ability class, which is what this thing is looping over. So that's actually very nice. And then it's going to add that as a child to our abilities scroll box. So add that as a child. After we add that as a child, we also assign on ability clicked, because when we click an ability, we want to inform the battle scene that, hey, an ability has now in fact been clicked and you need to do something. So we go in here and make an event dispatcher for ability chosen. So ability chosen, and give that a parameter of a ability object reference. So ability, and then we'll make that a turn-based ability. This one is going to be object reference, so the blue one. I'll just copy over the get turn-based component here. You can just make another line go all the way over here, but it becomes really messy really quickly. So again, this is why I like making the player a variable, just so that we can keep this a little bit more clear and readable. It's really the only reason. And we will activate a owned ability, and of course the ability that we're going to be activating will be the ability that we sent through with the event dispatcher. And then we call out that we have chosen an ability, we've even constructed it, it's ready to go, and that is the ability that we just created. And this is what is going to set the current ability value on our battle scene. So yeah, this is pretty much everything there is to it. Now, there's one thing, going back into our clear UI, you might also just on a technical level, this is better to do. You can get the children of this thing. So get all children. And you can for each loop over those. We can cast that to our ability button. And then before we destroy them, we can unbind all events from ability clicked. Just in general, a good thing to clean up any event dispatchers that you might have bound to. Because having things still bound to them might prevent them from being garbage collected, as far as I understand. Because they don't get explicitly destroyed until they're not used by anything anymore. But I do believe if things are still bound to event dispatchers on these buttons, they remain in memory. And since we're constructing these every single time we like start a new turn for any of our characters. There's going to be a whole bunch of these things just floating around the memory doing nothing. And Unreal will think, well, there's still something bound to it, so I'm not going to clean it up yet. So we want to unbind. If I understand the garbage collection in Unreal properly, which, I mean, who does, right? And then once it is completed, we can clear all children. No problem. So that's everything to do with this, honestly. So we can now go back into the mess of a blueprint that is our battle scene, into the event graph. And in here we had a bunch of stuff where we said, well, everything in here we're going to clean up a little bit next time. And next time is now. So right here, we set our current ability, and the way that we get that is from like get active abilities and all that kind of stuff. We don't want to do that. Not at all. What we want to do instead is actually go back here to the start of next character. And we have somewhere in here, we set the HUD set player info, right? I'm going to move that over to being after the branch. It doesn't matter that much, but it's just like if it's not the player's turn, why would we even bother, right? And I'm also going to pull off of this and make this a new custom event. And we'll call that event like set player menu, so that we can call everything happening from here in case we need to, which we will need to if we like back out of something or we select an ability that doesn't have anything that can select and that kind of stuff. And everything we do after that, we're actually going to disconnect, because that's going to be hooked up to that event dispatcher that we just created. So we get our HUD, which we made, and then we assign on ability chosen. Now, when we choose an ability, the very first thing that we do is we unbind event from ability chosen, because otherwise every single time you run this, it's going to rebind a second and a third and a fourth and a fifth and a 10th and a 20th time to the same event. We only want this event to run once. So we bind to it until it gets run, at which point we unbind to it, and then we only bind to it again when the next turn rolls around or when we go back to set player menu again manually. And then set current ability, this one over here, is going to be populated by the ability that this event gives in, and then we hook this up to right here. Other than that, this can mostly stay the same at this point, because we check whether or not the own part is selected, we select by index, we then set the current ability to, again, whatever this event dispatcher sends through. We update the selected target based on that ability. And then here, if we have a valid thing that output anything for us to select, we select that new target. But then we also take our HUD and we clear its UI. So we clear UI. Now, if whatever we output here is not valid, that means that it didn't find anything that we could target. So then we want to just force it back into doing the set player menu. We'll also need to set up some automatic destruction of an ability that got created but then not executed. So we'll have a cancel ability functionality as well, but we'll circle right back to that in a moment. Now that we have this, we also want to be able to exit out of an ability after choosing it, because maybe we chose an ability by accident. So if we go back into where I set up all my input bindings, we do a debug key for backspace. Makes sense here for me. And what we do there is we just current ability, and here we want to just destroy actor, and then set player menu, and we take our currently targeted actor, so the target actor, and we say, hey, you actually are set targets to being false, because we only want those targets to now show up when we actually select an ability. It might actually be worth it to change this to a custom event for cancel ability, so that we can explicitly call that as well, because that's going to also deal with the destruction of the thing that I just said. So here, after update select the target, if that is not valid, instead of just setting the player menu, what we can do is we can just cancel ability, and the ability itself doesn't even need to like worry about that. So now let's see how that does. We only have one owned ability. I don't even think actually there's an owned ability technically on the player character. Let's actually check that. If we go onto the player actor, yeah, we don't have any owned abilities, I don't think. So here on begin play, we'll just give ability. And we'll give the ability for jump. And I will also give it the ability for weight. Now, jump is not going to work obviously, because it doesn't really like have the player movement component. But just for demonstrational purposes, it'll have both of these abilities on all 3 of these characters now. So, starting a battle. They both don't have names, which is less than ideal, obviously. So let's give both of them their names. I think I put them in here somewhere. Or are they just still in here? Gameplay ability, jump. Yeah, so going in there. Let's call this jump. And then wait. 2 guesses what we're going to call this one. Wait. You also notice that we didn't have any way to select these. We can just enable the player controller's cursor to be able to actually click on the buttons. But since we set up the keyboard stuff, I'm actually going to not do that right now. And what I'm going to do is in the battle HUD, after this for each loop that sets up all of these things is completed, I will get children of the abilities scroll box. Or specifically, I will get a child at a certain index. That index will be 0. And we will just set the keyboard focus. So set keyboard focus to that. That way it will automatically just select the first thing in the box. So now you will see it has jump and it has wait. It doesn't automatically select the first thing in there. So that's a little annoying. And it doesn't do that because in the ability button, I forgot to set it as focusable. So the topmost thing in this hierarchy here, if we select that and we look for focus, we need to set that to being focusable. Otherwise, when we try to set a focus to it, it doesn't work. But when we do, you can see I now have very easily navigable little buttons. So I can do this, press enter, and it will wait. And we take a target, let's say this target over here, and it takes 2 seconds and it moves right on along. So yeah, that's pretty much the whole idea here. And then it does show the targets for those, and then I can say, well, I want to wait, and so on and so forth. So that's effectively a UI that lets you do a battle. I'm going to make an ability that actually deals damage. I know, wild ID, right? So if we just copy over the wait ability, we will see that we have wait 1. I will call this attack. And instead of just on activate ability delaying, what we'll do is we'll still do the delay actually. Probably make the delay like, well, 2 seconds was pretty good. And here, we'll get the owning ability components, and we'll get the targets from the owning ability components. Then from that, we will get the turn-based component from that target, and that's the wrong thing. So get turn-based components, and we'll be applying a gameplay effect to it. So we'll apply gameplay effect to target, or just apply effect to target. Target component will be, of course, the component from our target. The attribute to effect will be HP. The magnitude will be -10. The effect type will be instant. The current value is what we're going to be targeting. We'll add to it. And that's pretty much it. We don't really need to do anything with the effect. And then we just, I don't know, delay here at the very end. Maybe we want to spawn in like a particle system to show who we attacked, right? So spawn Niagara system at location. Do we have any Niagara systems here? Nope. I'm just going to make one real quick. Omnidirectional burst. I'm just going to make those particles really big so that you can see them. Going to be relatively simple. So like initialize particle, uniform sprite size from like 15 to 30 instead. Maybe like do 30 to 50 so that they're nice and big. And then scale sprite size, we can also increase that. I feel like it's being overridden somewhere. Oh, there we go. It caught up. Yeah, that's definitely too big. So let's go back to 15 to 25 or something like that. It's just taking a moment to catch up with everything. That's a little bit better. So we have that now. We can go back into the attack thing, set that to that Niagara system, delay for 2 seconds so that it actually like shows a little bit before moving on to the next turn. And then the location will be our target's get actor location. And like this, you can start building out more complex things with sound effects also being added in and whatever you want. Camera animations, skeletal animations, whatever you want to do, right? But for now, we just have this attacking thing, which is quite nice. So we go back into our player actor here, and we'll change this jump to just be the attack ability instead. And then in the turn-based actor, I'm actually going to change this on set turn active to being the thing that executes an ability. I will get rid of that. What I will do instead is for the enemy actor, we have a delegate on that, on the system component now, right? We have like this, turn started. So we can just make that event and then activate single ability. And the single ability that will activate will be the attack ability. It will skip the selection in this case, and it will need a target. So the way that we can easily set up this target for now is just you'll want to get your ability system component and then set target from that. And we'll get the player controller. We will cast to our horribly named player controller class. And we'll just get the array and get a random thing from that. So get active characters or something, I think we called it. Active party. And just get a random array from that item, or random item from that array, rather, to set as a target. So now it's going to randomly attack one of my party every time it gets a turn as the AI. So let's see how that works out. So we have wait and wait. I didn't give it a proper name. That makes sense. So let's go back into my attack, class defaults, attack. So we can actually see which one we're supposed to do. We have attack. We can select that, then we select a target. If I press backspace now, we go back into the selection menu, and you can see that targeting has stopped, but we can like attack. I can attack this dude, it spawns on the particles, it waits 2 seconds, and then when I attack, you can see that this one actually does update its HP value when I select it to show its current HP. Now again, in a proper RPG, like a JRPG sense, you probably would have all of the enemy actors at the same time show their HP in your UI or whatever. That's not how we have things set up right now, but you're very much good. And as a little last thing before we end off, and then next time we'll probably do actual win and lose states for the battles. But for now, last thing to do is I want to set up that this attack is going to cost us 10 MP. And just as easily as that, is going to take 10 MP to do this attack now. So let's try to attack, and then we attack like 3 times before we cycle back around, of course. But you'll see that when we cycle back around to the first character, we can also see the AI do its thing now. So it's attacking me, and then it's attacking me like very much at random. But now when we update, you can see I only have 90 HP because I was attacked, and the MP actually did not seem to work properly. So that is because, again, it's been a long day. I'm going to record the rest of this series another day. The attack doesn't commit ability. So, like, commit ability, and only if it was properly committed will we do this. We obviously also have that function like can do ability. So we probably should go back into like the battle HUD. And I think we just can do ability, right? We get the target component and then put in the ability for it. And for now, I think what we're going to do is we just only add these if we can actually do the ability. You might want to like grade them out and like make it skip over within the selection and all that kind of stuff. But again, this is very much something that's up to you, how you want to like design the experience for your game. But we made that function. So we apparently just cannot do the wait because it doesn't have a cost. That's worth looking into to check hey, if the cost is 0. Always return true for this. So let's just immediately do that actually. Can do ability. If our costs is, I guess, less than or equal to 0, you always should be able to do it. So you just immediately return with can do. Otherwise, we check stuff. Now we have a wait back, which is amazing. And we can do some attacks. So let's attack the top one with all of them. And when we circle back around, it should have used up some of the MP on all of these characters. So we'll get attacked a couple of times here, which actually it is stalling these guys because they don't have MP. Makes sense, right? So for now, the way that I'm going to fix that is just to give them some MP. We might make a separate, like, 2 or 3 videos at the very end to make, like, a state tree or a behavior tree. Behavior tree probably makes more sense here. To decide, like, who they should attack and what attack they should use and all that kind of stuff. But for now, it's just using attack at something randomly. But it'll use MP, and it'll have also 50 of it, why not? So we go through this whole song and dance again. Now they can actually attack because they have MP. Fantastic. And now when I'm back at my character, you can see I only have 40 MP because I actually used up some MP attacking these guys. Now, there is no fail state. They just can't die. We can't die. Nothing can die. So next time, let's let characters be able to die, and when all characters on my side die, you lose. When all characters on the opposing side die, you win. We almost have an entire turn-based RPG. We have battles, we have turns, we have abilities. The only thing that we don't have is the ability to end a battle yet. We can't have characters be defeated or anything along those lines. So let's get into that today, and then also set up something like experience and experience curves and all that kind of stuff. So for the most part, the end of battle is going to be somewhat easy to implement, because if we go into the ability system component, we already have this attribute updated delegate that we have a function bound to, if I believe, on attribute updated. So all that we need to do here is we need to check if this attribute, if we break it, is the name of this attribute HP. If it is not, clearly we didn't die, so it doesn't really matter. Probably do this either before or after. It kind of depends on what the rest of your code does with attribute updated. I'm going to do all of this after we call out that attribute updated. Because anything that uses the attribute updated stuff is going to update, and this is going to then immediately destroy it anyway. So it doesn't like actually matter that much. Then we check the stats, split truck chop in, and we check the current value. We might as well check current value plus current value modifier. Again, for HP, you probably wouldn't ever modify the current stat to begin with, but who knows. And we check whether or not that is less than or equal to 0. And then we combine these into a AND boolean. When that AND boolean is true, we make an event dispatcher. And we call this actor killed. We do put in a parameter here for the actor that owns this component. That's going to be, of course, of type actor object reference. We call this out if this branch ends up being true. And then the actor, we will just get the owner of this component and send that through. So now we have a event dispatcher that we can bind to whenever a character dies. So with that, we can finally go back into the battle scene, because there we're going to set up some logic for how to deal with either enemies dying or players dying. So let's start with the enemies, because they are actually remarkably simple. We do all of this stuff. We spawn them in, we set the new targets, and then pretty much like at the end here, what we can do is we can get our enemy party, and we just for each loop over that. And we assign, we get the ability system component or get turn-based component. I'm messing up the name of this thing, even though I am the one that made it. And then we assign on actor killed. So when the actor dies, we need to do 2 things. Number 1 is we need to take it out of the relevant array. So we take our enemy party, and we remove an item from it. Now, it is entirely possible to just keep it in there, because we already have the entire setup where it skips over everything with 0 HP. If you also just make things with 0 HP unselectable with your attacking moves, it is fine if you keep these in here and just make them invisible. The reason being is that if you have unequal sides for your party and your enemies, going back and forth between them due to the fact that it uses like corresponding indexes to toggle between selecting party members from your players and selecting party members from your enemies, it might become a little weird if there's only like 1 or 2 enemies and there might be like 3 player characters. So if you find yourself running into any issues like that, maybe don't remove them, but instead just make them invisible, and then inside of your attacking abilities, in the can select function, which we made in the past. So if we go into this attack, we have the can select function that we can override. You just make sure that you only select things with more than 0 HP. To keep things simple now, we're just going to remove them from this array altogether. And then after they've been removed from this array, we also very simply can just destroy this actor, because we don't really need to do anything with it anymore. We're going to come back to this and add some experience related code in a moment as well. But first let's set up the end battle situation here, because when we remove enemies from the party, and this is the reason that removing them might be easiest to do, because once they are removed and destroyed, we can then check, hey, is the length of this now still greater than 0? Because if it is still greater than 0, obviously there's still enemies left to be defeated. But if it is not greater than 0, that means that it is equal to 0 or less than 0, but the length of an array can never be less than 0. So you might as well check whether or not this is exactly equal to 0. That's effectively the same thing. That means that we need to end this battle, for which we actually probably want to set up a separate event, so custom event, for end battle, because we have not been able to really look at that so far. Ending the battle is relatively straightforward, all things considered. There's a couple of things that we do need to make sure of. I honestly, personally, just put in a variable here for stop battle, because of the whole turn flow thing, kind of like perpetuating itself. Where the turn ends, the next turn automatically starts. If we just put in a stop battle variable in here, we can very easily just at the start of any given turn, when stop battle is true, it just stops the flow of that battle. So we just get this, and when stop battle is false, it keeps going, otherwise it will stop. It's the easiest way to set that up real quick. Then eventually we'll award experience, which we'll do in a moment. But first we will set the actor hidden in game, because we don't want to see this huge battlefield in the sky after we've done the battle itself. So we set this actor being hidden in game. Then we go through and get all of the battle characters that are still left, which should only be your party characters in theory, but you never know. And if we for each loop over those, we can also set these back to being hidden in game, because we don't want those to either be visible somewhere up in the sky. So we just set both of those nodes to being hidden true. Then when we complete it, you might remember way in one of the first videos on this battle scene, we made this return character variable, and we haven't used it yet. This is where we start using that. So we get a reference to that, and we get the player controller, and then we possess that return character again, so that we can keep on playing our game in our just third-person template. And then the same thing, we made a variable for the HUD. We're going to remove that from its parent, which is the viewport. Just going to clean it up from the screen. And this is everything for now for ending the battle. Just to be sure, you might also want to, in the for each loop, get the ability system, or again, it's called turn-based component here. And then unbind all events from turn ended, just to be sure that we don't have any event dispatchers still linked up in weird ways. We shouldn't, but just make sure that once we end the battle, we actually clean up everything that we might have set up. In the same way, we also want to make sure that none of these have their turn set to being active. So we use the for each loop actor, and we set turn active, as well as set targeted, both with the input value being false, so that we don't have any of that overlay stuff when we start up our next battle. So that's pretty much everything there is to ending the battle for now. Again, experience rewarding will be added onto this in a moment, but for now, that's all that we're going to keep it at. So here, back in actor killed event in the spawning of the enemies at the very end. We bind to that, and if our length is less than 0, so it's not greater than, so when this is false, we just the battle, and there we go. That's for the enemy side. Now we need to do something similar for the player side. So that'll be set up in move party to battle, where we have this for each loop where we set actor to the corresponding locations, and then we set it to not be hidden in game anymore. We can also get the turn-based component. I'm starting to remember to use the right name now that we're ending the series soon. We get that component, we assign on actor killed, and here instead of making them destroy, because obviously we don't want to destroy them, we just want to check, hey, do all our party members have 0 HP now? Because if all our party members have 0 HP, that means that we've lost. We can't just check that by checking the length of an array, because they still persist in the array of our characters, because we're not destroying anything, because they're our player characters. We need to be able to like revive them, for instance. So instead what we do is we make a quick function, and we'll call that lose battle. Maybe give it a battle name like has battle been lost, or has lost battle, or you can name this whatever you want. What we're going to do with it is we're going to get our player controller, get our active party, and we're going to for each loop over those. And for all of those, we're going to then get the turn-based component. So get turn-based component, and we will get the current attribute for HP. And then we'll check whether or not that is greater than 0. Because if it is greater than 0, that means that we at least have one character that still has his full HP. So then we just simply return. That means that if we ever make it to the end of this for each loop, we've gone over our entire team and none of them have HP greater than 0. So at that point, we do whatever we want to do for a game over. In this case, that might be just like closing out the game. But in your case, it might be like setting you back to your last save point. Or maybe just exiting the battle as well and just setting all your characters back to 1 HP. Again, this is entirely up to how you want to design your game experience. For now, I'm just going to make this quit the game. Obviously, if you're doing something a little less rigorous than this, instead of kicking people back to the main menu, even if you do that, you probably should put some UI in between this and just closing the game. You still want to just make sure that stop battle is set to true. Because otherwise the battle might keep going in the background while your UI pops up and that kind of stuff, and that might be a little bit weird. So yeah, ideally this would create a widget that you can then like load game from or whatever you want to do. So this just checks and executes what you do when you lose the battle. This probably is best served to be its own function, so you can easily override only that part of it, but there we get into like the little nitty-gritty details of things. So whenever any of these actors are killed, and that is our player characters, we just do our lose battle. And there really isn't that much more to it in this case. So with that, we now have a win state and a lose state. And to show you the win state actually properly working, I'm going to go into the enemy actor. And I'm going to set its HP that it starts with in here. I'm going to set its current value to only being 10, so that they all die within 1 hit. Otherwise, we're going to be here for a moment. So let's do that, and we can just attack. And we've only got 2 enemies as well. So you can see it deletes the enemy as it dies. And then when the other one dies, it also just boots me back to the beginning here of the game again. And I can get into another encounter, and we'll all be good to go. Now, there is an issue here where it didn't actually give me control of my character at the start of the next battle. And that is due to a couple of reasons here, most likely. And we can see the errors that it pops up with, which actually have nothing to do with that. And whenever we start a new battle, we want to make sure that our turn order index gets set to 0, because we want to start from, well, the beginning. And then, of course, if we are going to set this stop battle as a extra insurance that the battle can't continue when we say that it stops, when the next battle starts, because this still is very much just the same actor that we're sending these actors to every single time, we also need to make sure that the stop battle will be set back to false before we do anything else. So now we can see we ended a battle there, and we can start the next battle, and we are back where we left off quite easily and quite simply, like this. Now, because everything the way we have it set up, these actors that are in like our party on the left-hand side are the exact same actors between different battles. So our damage and our MP use, as you can see, our MP use is 30 out of 100 now, because we used attack twice, which costs 10 MP to do. So this kind of data persists between battles, because it's physically using the same actors and just moving them to new areas if we want to battle in a new battle scene, which we can obviously set up. We will take care of this in a moment. Those are not that important as far as things go. But we can just copy this one over, give it a different material. So maybe this one will be a material for like cobblestones. Give it a different encounter table, and we've got a different area. Now, of course, you probably want to make those entirely separate blueprints so that you can easily like drag and drop them in. But it's as easy as that, and now we have a second battleground. And if we want to go to this one, it'll physically take the actors from our party members over on this side and move them to this one. And then back if we go back to this area over here. So all the data on them is easily carried over, which is quite nice. So that's ending the battles. Fairly easy. I can show you ending the battles from the other side as well, just to show you that that works. We can go into the player actor real quick and set these guys to only have 10 HP as well. And then I will just wait a couple of turns and they will annihilate me. So I will wait, and I need to actually still target something for raiding, apparently. That's also something that I probably can do in the wait ability, is just skip the selection altogether. But now one of my guys has been killed, the other one has also been killed, and the third one hasn't been killed because they're randomly picking targets, and if something has 0 HP, it still can be randomly picked. So I think next video we'll make something where we actually give these guys a little bit more intelligence. So let's try to wait again and see if they now hit the proper actor, because that would be ideal for the demonstrational purposes. So please hit the top one. Please hit the top one. Anyway, you can see that the things that don't have any HP at the moment don't get to go in a turn. So that part of the game also does work. But you can see it attacked me and now the game has stopped. So that also works as intended. Meaning that we have only one thing to do for this before we actually have pretty much parity with my example project that you saw at the very beginning of the entire series, and that is experience. So let's go over that really quickly. We can open up our enemy actor and give it a new variable, and that will be something like XP on death. We'll make that an integer, and by default I will give that like 10 experience per that we do. Now, awarding experience is, again, one of those things which, whatever your game might want to do, it might be different from what we're about to do here. I'm going to do what I would presume is one of the more complex way of doing it, and then you can figure out what you want to do based off of that. So what we are going to do is we're going to keep track of which of our party members were alive at the time that an enemy died, and then only if they're also alive at the end of the battle do we award the experience. So you can just award the experience right off the bat in the moment when a character dies to everything that's alive. You can keep track of how much experience has been built up throughout the battle and award that to any alive members at the end of the battle. I'm going to do both. Every individual character going to track how much experience they have built up throughout the battle, and only if they're alive by the end will they actually gain it. So, back in the battle scene. We will go make a variable for that, and that will be the XP to reward. And we'll make this a type actor, because we're going to be tracking it per actor, obviously. And then we'll turn it into a map with, so we're going to say, hey, this actor goes with this amount of experience, and then we can just use that to actually award the experience. Now, when an enemy dies, we need to do some stuff. So let's go ahead and open the event graph. We already are in the event graph apparently. And go to where the enemies die, which is right over here. the enemy party for each loop. We bind to enemy killed. Now we do all this. We also want to do some stuff about how much experience it is going to give us. So for this, I'm just going to cast to enemy actor. And we do all this before we destroy the actor, by the way, because we need to actually access information on the actor. Technically, destroying doesn't happen until the next tick, I believe. So it would be safe to do it after, but it's just good practice to do stuff with an object before you destroy it, because otherwise it's going to be very messy. And we'll call that something like add XP to award. This will be a input that will be the experience that we need to award. And that's, of course, going to be an integer. And then what we do is we take our player controller, of course. We get the active party at this time. We for each loop over it. And we get the turn-based component and then get the current value of an attribute. You can guess where we're going with this. We're going to be checking whether or not these guys have more than 0 HP. So if their HP is greater than 0, we'll move on and actually award their experience, or at least store the experience that we need to award them at a later. So we're going to make a local variable and call that a previous value. And that will just be a integer and not be a map or something. It's just going to be a singular integer. If it already exists, we can use this finding node to set the value of what it already had accumulated as far as experience goes to whatever it has found from this map. If it hasn't found anything from the map, that means that it doesn't exist yet, and we need to kind of initialize that value at being 0. So then what we do is we take our map again and we simply add to it. The wonderful thing about maps is that if you add something with a key, that is the value on the left, in this case the actor, that already has that key, it's just going to update that entry. It's not going to make a duplicate or anything, it'll just update that entry. But if it doesn't yet exist, it will make a new entry for it. It's actually quite nice. So what we'll do is we'll add the previous value that we had, so that's either going to be what we found or going to be 0, and we're going to be adding to that the experience that we give in to the parameter of this function. And in either case, we're going to hook up both of these to that adding node. And this is now going to keep track of that map and every actor. Also actors that might have been swapped out if you have multiple party members, you can swap in and out. Even if actors have been removed from the actual battle scene, but have gained some experience through being in battle while an enemy died, it's going to keep track of that entire thing. Actually, no. And this is now going to keep track of every actor in your active party. So if you have a party system where you can swap in and out, you might need to also have an array of your total party. So everything that's active and everything that is currently not active combined. Because if something is switched out halfway through and you're doing like some kind of switch grinding for like a new character that's joined the party or whatever, you want those to be able to get experience too. Might need to expand a little bit on this system. But for now, we just take care of the 3 party members that we have on the screen at a time, and anytime something dies, we add to that for them in this map. So then all we need to do is go ahead and actually put in that XP to award function in here. So after we cast to BP enemy actor, but before we destroy it, we're just going to run this function. And now we just need to make a corresponding function at the very end of the battle. That is going to award the experience that we have counted up. So for that, I'm just going to call that function award experience. So award XP. And that's going to get this map. We'll get the keys from this map. So that's all the actors, so that we can for each loop over there. If nothing else, after this entire series, you should be intimately familiar with for each loops. And then for each one of those, we're going to try to find them in this map again, because it's going to find the corresponding amount of experience that they should be awarded. But we'll only really do that if a couple of things are true. Here we're going to actually cast to the player actor as well, because we're going to set up all of the experience gaining stuff and the leveling up stuff that goes with it in the player pawn, because the enemy pawns obviously don't need to be able to like gain experience. So here we do actually cast to the BP player actor for once. We double check whether or not it was found in this map, because if it was not, for whatever reason, it should be, because we're getting the keys from this map, but never hurts to put in an extra like little bit of defense there. We get the turn-based components, and we again check if its current HP is below 0 or not, or rather if it is greater than 0. Because if it is, what we'll do is we will award the experience. And for that, we will make a function on the player. Because what that's going to do is it's going to increase the experience on that player character. And then also immediately, if it has gone past a certain amount of experience, level it up and apply some stat increases and the like. So let's open up our player actor blueprint and create a function to match this. So we'll give experience. The experience to give will be a input, so we'll just make that XP, will be an integer, and we'll make an experience variable in this thing as well. So total experience. Do pay attention that this is just a normal variable, not a local variable. We've been using local variables a lot in this series, so pay attention to which one is which. This is just going to be a normal variable that's globally available through the entire blueprint. And we'll set that to being its like current value plus whatever we give into here as well. And this is the giving of experience. It's quite as easy as that. Now let's look into a like experience curve and level ups. Because for that, we can just create a curve, and that'll be a curve asset like this. We'll make a curve float, and we'll call this the level curve. You might want to make a level curve per character or whatever. We're just going to do this one. There'll be assets that you can just swap out what asset you're using with different child blueprints off of this BP player actor. Again, if you have like 5 different characters in your game, you're going to make a separate child blueprint of this for each one of those, and they can have their own references to their own assets for their experience curves. For this experience curve though, what we're going to do is I'm going to add a key, and then I'm going to click on that key. Coming up here, we can see this is the amount of experience, and this will be the level that we'll be at. So we at 0 experience want to be at a level 1, and that will kind of make it move around a little bit. Don't use middle mouse here, by the way, because middle mouse actually switches the position of our key. To navigate this interface, you want to use right mouse button. If you press middle mouse button just on the line, it creates a new key for you. And on that one, I'm just going to see what I had in my reference project. I said about 50,000 experience would be level 99. So let's say 50, 1, 2, 3 zeros, and that would be level 99. Now, this is kind of unreasonable to try to like figure out what this looks like, because it's effectively just a flat line. So what you can do is you can just come up in here and set absolute view. That'll kind of scale the X and the Y axis to the point where it is just like screen filling. Then, selecting both, which you can also just do by Ctrl A, I'm going to make both of these cubic interpolation, and then I'm going to toggle the weighted tangents. And then we can actually make the XP curve as steep as we want. So what you might be used to seeing a lot is an exponential curve that goes like slow, 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 and then like ramps up like this. But since we're giving in the experience and getting back the level, we actually wanted to look the other way around. We wanted to have a very steep incline at first, and then become more flatter toward the end. Because, again, what you may be used to seeing online for other level curves is generally the level and then how much experience you need for it. This is how much experience you have and what level that gains you. So it's the same curve, just from a different perspective. So here we can see, especially if we like start zooming in a little bit again, at level 0 or level 1, we have 0 experience. If you want to get to level 5, that's going to be about 270 experience needed. But then, if we go over here and we look at, well, we're about level 98 here. Let's go to, like, we're 98 to start. You can see that it takes a while to get there. Level 98, you're about 35,000 experience, 34,000 experience. And it takes another 15,000 experience then to get to level 99. So that is the curve that we have here. The wonderful thing about this being a curve is that you don't need to like put in a bunch of individual numbers, and you can fairly easily just kind of play with how this curve like flattens out toward the end and what it kind of feels like from a gameplay perspective. So we have an experience curve now. Fantastic. Let's actually put that into practice. So going back into our player actor here, after we've given some experience, let's make a variable. That'll be our XP curve. That'll be of type curve. And then we can find in the object references, so that's down here, those gray or like skin colored ones. We want a curve float object reference. Probably want this to be instance editable because we're going to be editing this based on different characters most likely in a real game. And we can just set this level curve to be the default. Now, we can pull that into the event graph here for this function. And then we can get a float value out of it. And that's going to take in a time. The time is the x-axis here, so that's left to right. And it's going to return you the corresponding y value. So after we set our new total XP, we just give that into get float value, and then we simply check if we floor that value, is it then greater than our current level? And you might be thinking, we don't have a current level. That's what we're going to be adding next. So we add a new variable here for our current level. So let's say level. We can just start that at 0. That's not that big a deal. It needs to be an integer, obviously. So if that experience gain has been greater than 0, but let's start it at 1 nonetheless. So if that experience gain got us to an amount of experience where we have passed the next level threshold, it's going to round down to that next level. So let's say we're level 5 and we've got experience and we're now level 5.9. Great, that's still going to round down to level 5. But if we are just over that threshold, we're now at level like 6.00001. That means that this floor node now rounds that down to... That means that this floor node now rounds that down to 6, which is greater than the 5 that we were at before. So this is now going to return true. And we'll put in a branch there, because that's going to then level us up to the corresponding level, which will be a separate function to its own. So we'll set our new level. Let's set level up. And then the input for that will be our new level. The first and most important thing, obviously, being to set our level variable to that new level, so that we can be proud of the experience that we've gained. And then we're going to just make some more curves for our stat upgrades. I'm just going to do it for HP for now, but in your own game, obviously, you would also do this for like your strength and your defense, or maybe like your mana, or any stat that you want to upgrade, your speed. You would make essentially the same thing that we're going to do here for HP for any stat that you want to upgrade. So we'll make a curve for that as well. So let's do HP curve as a variable, which will also be a curve float object reference. Again, probably make this instance editable because every single one of your characters is going to probably have its own set of these curves. And here we're going to, once again, just get the float value that corresponds to whatever exact level we are at the moment. Now, you could also do this with data tables, granted. I like doing it with curves because you'll see why in a moment. But after that, we can just get our ability component and apply effect to self. And in this case, we're going to be applying the HP. We'll set our effect math to override whatever comes out of here. And we'll, of course, set our maximum value with this, because that is what HP upgrades do, is they set your maximum value. And when we hook that up, the only thing now that we need to do is make an HP curve. So let's make an HP curve. We can just, again, make a curve asset. So curve, float curve. Call this HP curve. Maybe organize your project a little bit better than this. And let's make a really weird HP curve, okay? Because I feel like it, honestly. We're going to add the first key, which is going to be at level 1. We're going to have a certain amount of HP. So let's say we have like 500 HP at level 1. That's going to make us scroll quite far out until we have found that. And then let's say that at level 99. So here we're kind of doing the opposite of what we were doing before, right? Before, what we were doing is we were giving in the XP and getting the level. Now we are giving in the level and getting the like stats total that this stat is going to get us. But at level 99, let's say that we have about 2500 HP. We can go back in here, set absolute view, so that we have a more representative view of how this entire thing goes. Now, what we can do is we can just add a random key. Everything will be linearly interpreted anyway. But we can say, well, actually, I want to say at level 2, I am going to get a 600 HP. So I have a 100 HP increase from level 1 to level 2. Then at level 3, I want to go back down to 400 HP. I don't know why you would want to do this, but this is something that you can do. And then until level 10, I want to stay at 400 HP. Then at level 11, I suddenly want to go up to 1000 HP. 1000, not 100. And you can start making these like really weird curves that you can like very custom make to what you want to do. And if you want to just linearly or even cubically interpolate between two of these keys, you also can just do that. I can say, well, level 11 and then up to like level 25. You can just say, okay, actually up until about level 25, I'm kind of good with this like linear growth. So we can find level 25 on this. And then let's find like level 25 that we want to make. We can find that right about here. That can just keep being linear. And then at level 26, let's make another one. Level 26 to level 35. So let's do up to 35. We want to stay at the same amount of HP again. So that will be 1250 in this case. This is the weirdest stat curve that I've ever seen in a game, but you can do a lot with this. And the neat thing is I can just select these two and move them like together, and they will snap to this grid as well, which is quite nice if I hold shift. If I don't hold shift, well, also if I don't hold shift, they snap to the grid, it seems. And the wonderful thing about this being a curve is that I very much can just like box select these two, and if I hold shift, I can very easily move them in just one axis up or down, or I think left or right as well, which is a little bit smoother. That doesn't snap to the exact levels, which is slightly annoying, I will admit. But with those, you can just select them back and set them manually to whatever value you need them to be. Which is maybe not the most ideal solution always, but you're only going to have to do that a handful of times. But it's much more easily adjustable than making an entire data table where you manually have to fill out every single level's stats, which is very tedious and lots more work. So this is our HP curve now. Let's check in our level curve actually what level 2 will require for us. So we actually need like 120 experience to get to level 2. So let's actually go back into our enemy actor and XP on death, just set that to like 60 so that I can be sure that I get to level 2 over just one battle. And then in our player actor, what I'm going to do is I'm going to print out a couple of things in event tick. So we'll get our ability system components, which we'll use to get currents for HP. Well, actually, we want to get the max for HP, don't we? So get max for the HP. And we'll print that as well as the level. So we'll do a append node. We'll get our total experience. So write that out, experience. Then get the experience. Then next up, get the level. pull that in. And then lastly, we also get the HP and put that in as well. Of course, we do need to actually hook this up into the execution flow. Otherwise, that's not going to work. I guess these could be pure functions now that I think about it. There's no reason for them not to be, because they're just getting values anyway. So that would probably make a lot of places a little bit easier to work with in the project. I'll leave it up to you to fix that if you can. Now, it's also probably a good idea now that we have this to just, on begin play, set our level by default to 1 this way. So that way it'll actually apply the stats that are corresponding to level 1. And make sure that this HP curve actually has a curve selected into it as well. And now, if you want to be able to save your levels and stuff like that, because we're applying all of those stats based on a curve, based on purely experience, the only thing that you actually need to store in your save file is the amount of experience that your character got. Then when you load your file, you just give them that amount of experience through the give XP function, and then it'll automatically set them to the proper level, and when they are the proper level, using those curves, it'll automatically set everything to the proper amount of their stats as well. So you don't need to go ahead and store like your HP and your strength and your whatever. Just store the experience and you'll be good to go. Anyway, we can see that I have 0 XP at level 1, means I have 500 HP, so that actually makes sense. It looks like I have almost no HP at all, because obviously my current HP is like 50, and I have 500 actual like max HP. But if I kill this thing, nothing quite happens yet. If I kill the other thing as well, it doesn't yet give me the experience. I probably messed up somewhere along the lines, and that is that I didn't actually use the give experience. Whoops. So yeah, in award experience, in our battle scene, we actually do need to then go back in at the BP player actor and give XP, the function that we made specifically to give XP. And we're going to be getting that XP from our XP to reward map and put that in there. So let's try that again now that that is actually hooked up. So that'll work a little bit better. We can attack, and we can attack another time. And this should award us a total of 180 experience by the end of this, and it still does not. Why not? And then going back into the event graph, of course, at end battle, somewhere in here, you also put in the award experience. So I'm going to just do that quite near the beginning here after stop battle. We award the actual experience. So with that out of the way, we can actually do this battle now. And I'll just go through pretty quickly and just wipe out our opposing characters here. And once the battle actually ends, you can see I've gained 180 experience. I'm still at level 1. That doesn't seem to match the actual XP curve that I made. So and then in the give experience, at the very end here, if that new level is higher than our current level, then we actually level up to whatever that new level will be. This will also allow you to level up more than one level at a time, because it's just setting your level to whatever new level you give in. So with that, now we can do a battle, and I can just kind of like race through this. It should give me 180 experience for these 3 enemies in total at the end of the battle. And then we level up to level 2, and we have 600 HP now, max. And we're kind of lagging out because I'm printing so many things. We have one more thing here, remove item. It's trying to remove things from an active effect. We can simply, which is a little bit weird because this thing is trying to remove itself from a target component that no longer exists. So what we can just do is we can check is valid. Well, we can just actually convert this to a validated get, to be honest. And then just holding control, we can move this over here, and only if this is valid do we try to remove it. The only reason that we need to remove this to begin with is so that Unreal doesn't have like a reference to it existing anywhere else in another actor and keeping this thing around. But if the like owning component has been destroyed to begin with, there's no reason to remove this, and Unreal will just clean itself up with that. So we should be able to see that if we go through this super quickly now, and we then end the battle. Only have some errors to do with trying to spawn in particle systems at locations where things are about to die anyway. So you ideally would probably apply this effect after spawning in the particle system, because otherwise it won't be able to get the actor's location. This is all like minor cleanup for the specific ability that I made here to showcase. So don't worry too much about all of that. But now we have a functional turn-based RPG. So congratulations, here we are. I'm going to make one more video, and in that video, which is going to be a little bit more unscripted because I didn't actually like prepare for that, we're going to set up the AIs to be a little bit more intelligent to prevent them from targeting things with 0 HP, but still weigh them toward attacking things with lower HP, so that they weigh toward attacking things that are almost dead, which is a good strategical thing to do, but still with a little bit of randomness in it so that they're not too determinate. Making a full-fledged JRPG style anime AI is going to be a little bit beyond what that video is going to show. We're just going to kind of set up the beginnings of that with a state trip. We have only one thing to do for this before we actually have pretty much parity with my example project that you saw at the very beginning of the entire series, and that is experience. So let's go over that really quickly. We can open up our enemy actor and give it a new variable, and that will be something like XP on death. We'll make that an integer, and by default I will give that like 10 experience per kill that we do. Now, awarding experience is again one of those things which, whatever your game might want to do, it might be different from what we're about to do here. I'm going to do what I would presume is one of the more complex way of doing it, and then you can figure out what you want to do based off of that. So what we are going to do is we're going to keep track of which of our party members were alive at the time that an enemy died, and then only if they're also alive at the end of the battle do we award the experience. So you can just award the experience right off the bat in the moment when a character dies to everything that's alive. You can keep track of how much experience has been built up throughout the battle and award that to any alive members at the end of the battle. I'm going to do both. Every individual character going to track how much experience they have built up throughout the battle, and only if they're alive by the end will they actually gain it. So, back in the battle scene, we will go make a variable for that, and that will be the XP to reward. And we'll make this a type actor, because we're going to be tracking it per actor, obviously. And then we'll turn it into a map with, so we're going to say, hey, this actor goes with this amount of experience, and then we can just use that to actually award the experience. Now, when an enemy dies, we need to do some stuff. So let's go ahead and open the event graph. We already are in the event graph apparently, and go to where the enemies die, which is right over here. The enemy party for each loop, we bind to enemy killed, and then we do all this. We also want to do some stuff about how much experience it is going to give us. So for this, I'm just going to cast to enemy actor, and we do all of this before we destroy the actor, by the way, because we need to actually access information on the actor. Technically, destroying doesn't happen until the next tick, I believe, so it would be safe to do it after, but it's just good practice to do stuff with an object before you destroy it, because otherwise it's going to be very messy. And we'll call that something like add XP to award. This will be a input that will be the experience that we need to award, and that's of course going to be a integer. And then what we do is we take our player controller, of course, we get the active party at this time, we for each loop over it, and we get the turn-based component, and then get the current value of an attribute. You can guess where we're going with this. We're going to be checking whether or not these guys have more than 0 HP. So if their HP is greater than 0, we'll move on and actually award their experience, or at least store the experience that we need to award them at a later date. So we're going to make a local variable and call that a previous value. And that will just be a integer and not be a map or something. It's just going to be a singular integer. If it already exists, we can use this finding node to set the value of what it already had accumulated as far as experience goes to whatever it has found from this map. If it hasn't found anything from the map, that means that it doesn't exist yet, and we need to like kind of initialize that value at being 0. So then what we do is we take our map again and we simply add to it. The wonderful thing about maps is that if you add something with a key, that is the value on the left, in this case the actor, that already has that key, it's just going to update that entry. It's not going to make a duplicate or anything, it'll just update that entry. But if it doesn't yet exist, it will make a new entry for it. It's actually quite nice. So what we'll do is we'll add the previous value that we had. So that's either going to be what we found or going to be 0. And we're going to be adding to that the experience that we give in to the parameter of this function. And in either case, we're going to hook up both of these to that adding node. We just take care of the 3 party members that we have on the screen at the time. And anytime something dies, we add to that for them in this map. So then all we need to do is go ahead and actually put in that XP to award function in here. So after we cast to BP enemy actor, but before we destroy it, we're just going to run this function. And now we just need to make a corresponding function at the very end of the battle that is going to award the experience that we have counted up. So for that, I'm just going to call that function award experience. So award XP. And that's going to get this map. We'll get the keys from this map. So that's all the actors, so that we can for each loop over there. If nothing else, after this entire series, you should be intimately familiar with for each loops. And then for each one of those, we're going to try to find them in this map again, because it's going to find the corresponding amount of experience that they should be awarded. But we'll only really do that if a couple of things are true. Here, we're going to actually cast to the player actor as well, because we're going to set up all of the experience gaining stuff and the leveling up stuff that goes with it in the player pawn, because the enemy pawns obviously don't need to be able to like gain experience. So here we do actually cast to the BP player actor for once. We double check whether or not it was found in this map, because if it was not, for whatever reason, it should be, because we're getting the keys from this map, but never hurts to put in an extra like little bit of defense there. We get the turn-based component, and we again check if it current HP is below 0 or not, or rather if it is greater than 0. Because if it is, what we'll do is we will award the experience. And for that, we will make a function on the player itself. Because what that's going to do is it's going to increase the experience on that player character. And then also immediately, if it has gone past a certain amount of experience, level it up and apply some stat increases and the like. So let's open up our player actor blueprint and create a function to match this. So we'll give experience. The experience to give will be a input. So we'll just make that XP will be an integer. And we'll make an experience variable in this thing as well. So total experience. And we'll set that to being its current value plus whatever we give into here as well. And this is the giving of experience. It's quite as easy as that. Now let's look into a experience curve and level ups. Because for that, we can just create a curve, and that'll be a curve asset like this. We'll make a curve float, and we'll call this the level curve. You might want to make a level curve per character or whatever. We're just going to do this one. There'll be assets that you can just swap out what asset you're using with different child blueprints off of this BP player actor. Again, if you have like 5 different characters in your game, you're going to make a separate child blueprint off of this for each one of those, and they can have their own references to their own assets for their experience curves. For this experience curve though, what we're going to do is I'm going to add a key, and then I'm going to click on that key. Coming up here, we can see this is the amount of experience, and this will be the level that we'll be at. So we at 0 experience want to be at a level 1, and that will kind of make it move around a little bit. Don't use middle mouse here, by the way, because middle mouse actually switches the position of our key. To navigate this interface, you want to use right mouse button. If you press middle mouse button just on the line, it creates a new key for you. And on that one, I'm just going to see what I had in my reference project. I said about 50,000 experience would be level 99. So let's say 50, 1, 2, 3 zeros, and that will be level 99. Now, this is kind of unreasonable to try to like figure out what this looks like, because it's effectively just a flat line. So what you can do is you can just come up in here and set absolute view. That'll kind of scale the X and the Y axis to the point where it is just like screen filling. Then selecting both, which you can also just do by Ctrl A, I'm going to make both of these cubic interpolation, and then I'm going to toggle the weighted tangents. And then we can actually make the XP curve as steep as we want. So what you might be used to seeing a lot is an exponential curve that goes like slow, 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 and then like ramps up like this. But since we're giving in the experience and getting back the level, we actually wanted to look the other way around. We wanted to have a very steep incline at first, and then become more flatter toward the end. Because, again, what you may be used to seeing online for other level curves is generally the level and then how much experience you need for it. This is how much experience you have and what level that gains you. So it's the same curve, just from a different perspective. So here we can see, especially if we like start zooming in a little bit again, at level 0 or level 1, we have 0 experience. If you want to get to level 5, that's going to be about 270 experience needed. But then, if we go over here and we look at, well, we're about level 98 here. Let's go to, like, we're 98 to start. You can see that it takes a while to get there. Level 98, you're about 35,000 experience, 34,000 experience. And it takes another 15,000 experience then to get to level 99. So that is the curve that we have here. The wonderful thing about this being a curve is that you don't need to like put in a bunch of individual numbers, and you can fairly easily just kind of play with how this curve like flattens out toward the end and what it kind of feels like from a gameplay perspective. So we have an experience curve now. Fantastic. Let's actually put that into practice. So going back into our player actor here, after we've given some experience, let's make a variable. That'll be our XP curve. That'll be of type curve. And then we can find in the object references, so that's down here, those gray or like skin colored ones. We want a curve float object reference. Probably want this to be instance editable because we're going to be editing this based on different characters most likely in a real game. And we can just set this level curve to be the default. Now, we can pull that into the event graph here for this function. And then we can get a float value out of it. And that's going to take in a time. The time is the x-axis here, so that's left to right. And it's going to return you the corresponding y value. So after we set our new total XP, we just give that into get float value. And then we simply check if we floor that value, is it then greater than our current level? And you might be thinking, we don't have a current level. That's what we're going to be adding next. So we add a new variable here for our current level. So let's say level. We can just start that at 0. That's not that big a deal. But let's start it at 1 nonetheless. So if that experience gain got us to an amount of experience where we have passed the next level threshold, it's going to round down to that next level. So let's say we're level 5. And we've got experience and we're now level 5.9. Great, that's still going to round down to level 5. But if we are just over that threshold, we're now at level like 6.00001. That means that this floor node now rounds that down to 6, which is greater than the 5 that we were at before. So this is now going to return true. And we'll put in a branch there because that's going to then level us up to the corresponding level. which will be a separate function to its own. So we'll set our new level. Let's set level up. And then the inputs for that will be our new level. The first and most important thing, obviously, being to set our level variable to that new level so that we can be proud of the experience that we've gained. And then we're going to just make some more curves for our stat upgrades. I'm just going to do it for HP for now, but in your own game, obviously, you would also do this for like your strength and your defense, or maybe like your mana, or any stat that you want to upgrade, your speed. You would make essentially the same thing that we're going to do here for HP for any stat that you want to upgrade. So we'll make a curve for that as well. So I'll have to do HP curve as a variable. Which will also be a curve float object reference. Again, probably make this instance editable because every single one of your characters is going to probably have its own set of these curves. And here we're going to, once again, just get the float value that corresponds to whatever exact level we are at the moment. Now, you could also do this with data tables, granted. I like doing it with curves because you'll see why in a moment. But after that, we can just get our ability component and apply effect to self. And in this case, we're going to be applying the HP. We'll set our effect math to override whatever comes out of here. And we'll, of course, set our maximum value with this, because that is what HP upgrades do. They set your maximum value. And when we hook that up, the only thing now that we need to do is make an HP curve. So let's make an HP curve. We can just, again, make a curve asset. So curve, float curve. Call this HP curve. Maybe organize your project a little bit better than this. And let's make a really weird HP curve, okay? Because I feel like it, honestly. We're going to add the first key, which is going to be at level 1. We're going to have a certain amount of HP. So let's say we have like 500 HP at level 1. That's going to make us scroll quite far out until we have found that. And then let's say that at level 99, so here we're kind of doing the opposite of what we were doing before, right? Before, what we were doing is we were giving in the XP and getting the level. Now we are giving in the level and getting the like stat total that this stat is going to get us. But at level 99, let's say that we have about 2500 HP. We can go back in here, set absolute view, so that we have a more representative view of how this entire thing goes. Now, what we can do is we can just add a random key. Everything will be linearly interpreted anyway. But we can say, well, actually, I want to say at level 2, I am going to get a 600 HP. So I have a 100 HP increase from level 1 to level 2. Then at level 3, I want to go back down to 400 HP. I don't know why you would want to do this, but this is something that you can do. And then until level 10, I want to stay at 400 HP. Then at level 11, I suddenly want to go up to 1000 HP. 1000, not 100. And you can start making these like really weird curves that you can like very custom make to what you want to do. And if you want to just linearly or even cubically interpolate between two of these keys, you also can just do that. You can just say, okay, actually up until about level 25, I'm kind of good with this like linear growth. So we can find level 25 on this. And then let's find like level 25 that we want to make. We can find that right about here. That can just keep being linear. And then at level 26, let's make another one. Level 26 to level 35. So let's do up to 35. We want to stay at the same amount of HP again. So that will be 1250 in this case. This is the weirdest stat curve that I've ever seen in a game, but you can do a lot with this. And the neat thing is I can just select these two and move them like together, and they will snap to this grid as well, which is quite nice. But it's much more easily adjustable than making an entire data table where you manually have to fill out every single level's stats, which is very tedious and lots more work. So this is our HP curve now. Let's check in our level curve actually what level 2 will require for us. So we actually need like 120 experience to get to level 2. So let's actually go back into our enemy actor and XP on death, just set that to like 60 so that I can be sure that I get to level 2 over just one battle. And then in our player actor, what I'm going to do is I'm going to print out a couple of things in event tick. So we'll get our ability system components. which we'll use to get currents for HP. Well, actually, we want to get the max for HP, don't we? So get max for the HP. And we'll print that as well as the level. So we'll do a append node. We'll get our total experience. So write that out, experience. Then get the experience. Then next up, get the level. Pull that in. And then lastly, we also get the HP. And put that in as well. Of course, we do need to actually hook this up into the execution flow. Otherwise, that's not going to work. I guess these could be pure functions now that I think about it. There's no reason for them not to be, because they're just getting values anyway. So that would probably make a lot of places a little bit easier to work with in the project. I'll leave it up to you to fix that if you can. Now, it's also probably a good idea now that we have this to just, on begin play, set our level by default to 1 this way. So that way it will actually apply the stats that are corresponding to level 1. And make sure that this HP curve actually has a curve selected into it as well. And now, if you want to be able to save your levels and stuff like that, because we're applying all of those stats based on a curve, based on purely experience, the only thing that you actually need to store in your save file is the amount of experience that your character got. Then when you load your file, you just give them that amount of experience through the give XP function, and then it'll automatically set them to the proper level. And when they are the proper level, using those curves, it will automatically set everything to the proper amount of their stats as well. So you don't need to go ahead and store like your HP and your strength and your whatever. Just store the experience and you should be good to go. Anyway, we can see that I have 0 XP at level 1, means I have 500 HP. So that actually makes sense. It looks like I have almost no HP at all, because obviously my current HP is like 50 and I have 500 actual like max HP. But if I kill this thing, nothing quite happens yet. If I kill the other thing as well, it doesn't yet give me the experience. I probably messed up somewhere along the lines, and that is that I didn't actually use the give experience. Whoops. So yeah, in award experience, in our battle scene, we actually do need to then go back in at the BP player actor and give XP, the function that we made specifically to give XP. And then going back into the event graph, of course, at end battle, somewhere in here, you also put in the award experience. So I'm going to just do that quite near the beginning here. After stop battle, we award the actual experience. And then in the give experience, at the very end here, if that new level is higher than our current level, then we actually level up to whatever that new level will be. This will also allow you to level up more than 1 level at a time, because it's just setting your level to whatever new level you give in. So with that, now we can do a battle, and I can just kind of like race through this. It should give me 180 experience for these 3 enemies in total at the end of the battle. And then we level up to level 2, and we have 600 HP now, max. And we're kind of lagging out because I'm printing so many things. We have one more thing here, remove item. It's trying to remove things from an active effect, which is a little bit weird because this thing is trying to remove itself from a target component that no longer exists. So what we can just do is we can check is valid. Well, we can just actually convert this to a validated get, to be honest. And then just holding control, we can move this over here, and only if this is valid do we try to remove it. The only reason that we need to remove this to begin with is so that Unreal doesn't have like a reference to it existing anywhere else in another actor and keeping this thing around. But if the like owning component has been destroyed to begin with, there's no reason to remove this, and Unreal will just clean itself up with that. So we should be able to see that if we go through this super quickly now, and we then end the battle. Only have some errors to do with trying to spawn in particle systems at locations where things are about to die anyway. So you ideally would probably apply this effect after spawning in the particle system, because otherwise it won't be able to get the actor's location. This is all like minor cleanup for the specific ability that I made here to showcase. So don't worry too much about all of that. But now we have a functional turn-based RPG. So congratulations, here we are. I'm going to make one more video, and in that video, which is going to be a little bit more unscripted because I didn't actually prepare for that, we're going to set up the AIs to be a little bit more intelligent, to prevent them from targeting things with 0 HP, but still weigh them toward attacking things with lower HP, so that they weigh toward attacking things that are almost dead, which is a good strategical thing to do, but still with a little bit of randomness in it so that they're not too determinate. Making a full-fledged JRPG style anime AI is going to be a little bit beyond what that video is going to show. We're just going to kind of set up the beginnings of that with a state tree. Now that we more or less have an entirely working turn-based RPG, I wanted to make an extra video here to kind of highlight the basic setup for an AI. Because at the moment our AIs are just randomly choosing who to attack, which very much includes things that have 0 HP, which is maybe not ideal. I didn't really prepare this video as much as other videos in this series, because while initially planning out this series, I didn't intend on doing this, but as we actually got on with developing this series and recording these videos, I figured, you know what, it's probably good to show just a little bit of that. So this is going to be a bit more off the cuff, but we should be fine. So what we have here is in our enemy actor class that we set up, we have a thing that just runs on turn started. When we start a turn, what it just does is it does an attack ability and it gets a random party member from the player controller. That is the most basic version of this setup. What we're going to do instead is I'm going to add a state tree to it, for which we actually do need to enable the state tree plugin. So let's go into the plugin and look for state tree. Gameplay state tree is what we need, I am pretty sure. So let's restart the engine and I'll be back with you in 1 moment. You know, I somewhat regularly forget that state trees are still a plugin that you need to enable. So we will add a state tree component now, so just a state tree normal, not state tree AI, so that we can actually run these state trees. So what we'll do instead of doing all of this is we'll just get rid of everything here. When our turn starts, we get our state tree and we just start logic, I think it's called. So yeah, we just start logic on this state tree. And then we can move all of the logic that we need to do into this state tree. Now, there is an argument to be made that behavior trees would work as well for this. We can't use behavior trees because these things are basic actors. They don't have AI controllers, and they don't really need AI controllers. And state trees can pretty much work as behavior trees, and then once they have found an end to their tree, they also just stop using processing power until they are restarted again. So they're actually, in my opinion, in most cases, pretty much all that you need. Behavior trees are suddenly a very niche use case once you start working with state trees. So let's make a state tree just for our basic enemy actor here. We'll go in here and that's a new folder. I guess we might as well just make a new folder for AI. I don't know why not. And that will be, I think they're in gameplay state tree. There we go. So we'll make a state tree component one and we'll call this basic AI. Now here, I don't really have a good direction as to where to go. So what do we want this thing to do? Let's workshop this live, right? We want this to pick a target and we want this to pick an ability. The question is, which do we want to do first? So this entirely depends on your type of game. If you're making something like Pokemon, what you ideally would do is you would score a handful of different options in this state tree based on simulating a damage instance. So you would go over all the abilities that you have. In Pokemon, that will be all your 4 moves, and check the potential damage that that move would do against that target. And then those would be scored, and with a little bit of randomness, one would be picked out of that, favoring the things with higher scores. We don't have a dynamic damage system where certain types of elemental damage deal more damage to different actors. So what we need to do is we only need to check, hey, what enemy do we want to target with our moves? Because we are going to be favoring the lowest HP enemy first, or the lowest HP player party member, because we are coding the enemies at the moment. So what we do is we pretty much just make a couple of states here, which will be attack player 1, And then add a sibling state for attack player 2. And then again, a sibling state for attack player 3. We then choose the root, and the selection behavior will be, we would try to select at random, weighted by utility. So that way they're going to try to pick one with some amount of randomness, but the utility will be weighted in. So we now need to set up the selection utility for every single one of these. So let's add some utility to this. We can do that based on a float. And we're just going to do this as a percentage of HP for now. You can do this with absolute values, of course, just checking which one is the lowest. But I'm just going to do this as a percentage of their HP. So the response curve will just be adding 2 keys. When the value is at 0, so our time, rather, is at 0, so we have 0 HP, that should be a utility weight of 1. That's the highest that is going to go. When the HP is at 1, the value should be maybe not 0, but like 0.1 or whatever. Again, you can make these just absolute values as well. So we can say, well, actually, when we're at 0 HP, that's going to be a value of 1. But then if we are at like 500 HP, that'll be our value of 0. And everything above that, we just kind of don't consider attacking at all. Unless everything is above that, at which point it'll just pick one at random, right? But again, we're going to go on a percentage basis here, just to make things a little bit easier to scale up and just to make them function. So the input range will also be from 0 to 1. And then the only thing that we need to do is we need to set up an input for this, which we'll do in a moment. We kind of can copy this thing over as a whole selection utility. Can just paste that in, I think. Doesn't let you do that, apparently. So let's just copy it over and add in a float input here, put that in, and that should copy over our curve. I think the curve is the only thing that we really need to copy over to begin with, to be honest. So let's just copy and paste the curve. Shift right click to copy, shift left click to paste using this method. And then the only thing that we need to do is for player attack 1, 2, and 3, we need to give in the HP percentage. So how are we going to do that? Well, I'm going to do that by adding in a quick little task up here that's going to just expose all 3 of those. So let's make a new task. We can actually make that a evaluator as well, I suppose. Yeah, let's make it an evaluator. That makes sense. So right click that, blueprint class. We can make this a evaluator. So state tree evaluator blueprint base, and that'll be get players HP %. And that'll just be player 1 float, and we'll set that as category output. Make sure to actually spell it correctly. That is quite important in this case. So I forgot to add in a T there. Unreal's not working with me today. There we go. And then we just copy that over to also be player 2 and player 3. And we do need to also mark those as output. Apparently copy pasting that does not work. But once we've made it once, we can just select them from the drop down menu. So that's not too bad. Then we're going to override the tree start values. And when this tree starts, we want to just set all 3 of these. And the way that we're going to do that is from get player controller. We'll cast that to our badly named player controller. That's just the way that I'm going to call that forever now. And we get the active party. Let's for each loop over that, because that's the easiest way to do things with arrays, obviously. And we get the turn-based component, and off of that, you can guess where we're going. We get the max, and we get the current for the HP. So we hook both of these up. We set that to look up the HP. This is current. I actually have that saying min value after all this time. We divide that by max. And then what we're going to do is we get this array index, and we actually just add in a switch on integer. So if that's 0, 1, or 2, we're going to then use that to set these 3 things. So at index 0, it's going to be player 1 that we set. At 1, it's going to be player 2. And at 2, it's going to be player number 3. And then we can hook this up to all 3 of those. No problem. And that's the evaluator done. That's all that it needs to do. When the tree starts, it's just going to get the current player controller, and it's going to set these 3 output variables to the HP percentage of all 3 of these players. And now that we have that, we can add the evaluator, and that gets us these 3 keys that we can now bind to. So in here, player 1, we bind to get player HP percent, player 1. For player 2, we do player 2. So player 2, there we go. And we do then player 3. Then we need to make a task to actually make it execute its abilities. So let's make a new task, state tree blueprint based task, and that is just going to be like run ability. Now, if we had multiple abilities, here we would also want to choose which abilities we pick, obviously. But if you have multiple abilities, there you really quickly get into the range of it becoming a lot more complicated to choose, okay, but this ability takes more MP from me. Do I need that much damage to kill this thing? If not, maybe score like a different potential move higher. And all that comes back to this. The way that we score these things is entirely done by this utility thing. So you can say, well, if you only have 100 HP, a move that does like 1,000 damage, more than likely, maybe don't score that too high. Maybe check them in a way where the closer the resulting HP from this amount of damage is to 0, the better it is. But if it goes below 0, maybe then take away some of that utility score again. And that'll balance the AI to probably, most of the time, pick something that is going to make sense for it, not to be expensive, not to overkill you. But for that, we need like more abilities, we need more characters, we need a lot more things. So it's kind of difficult to show off how to set that up right now in this moment. But I hope that you're kind of like getting the vibe that I'm going for. The way that we're doing it right here is just going to be simple, just do the attack ability that we have. So we have run ability. On state enter, what we'll do is we will, with a variable for actor, and that's going to be of type actor. We're going to set that to the category for context. If you're not following along very well, by the way, with all this state tree stuff, I do have an entire series introducing you to state trees, and then also like a quest system with state trees and a dialogue system with state trees. There's a lot of state tree content on the channel as is. So we just get this actor, we get the turn-based component, and we just activate single ability. For the enemies, we don't really need to like grant them abilities, because the way that we grant them abilities is just to like hard code those abilities into being one of the options, one of the paths in their state tree. So we pretty much with enemies would always use activate single ability. And we're going to promote that to a variable and obviously expose that as instance editable. And we want to always skip selection because this is being done by an AI. You can then, within this state tree task, even like make another event that you bind to it. That's why we even made this event dispatcher input here to begin with, in case you ever want to do that. We're not going to do that though. We're just going to immediately finish this task once we've picked an ability that we execute. So finish task, succeeded, sure. Back to the state tree, we can just go in here, and for each one of these we can just do a task, run ability, simply attack. And then I guess in run ability we also want to set up a target, now that I think about it. So let's say we want to set up the target actor. Let's make that a input here, because we do want to set the components target to whatever target we put in here. We are just going to have to find a way to conveniently get our player character references into this task now. But now that we have that, we also need to provide in this target actor. So probably make another evaluator or make it part of this evaluator to expose those as well. Actually, it kind of makes sense to just do it as part of this evaluator, to be honest with you. So we just make some more outputs for player 1 ref, because we already call this player 1. And that's going to be a actor object reference. Make sure to mark these as being output. And then we can just say player 1 reference will just be our current index array element from the for each loop. And we can just do that with like 2 more. So player 2 ref. And then also a player 3 ref. I think that'll be the easiest way to send through these player references as well. And all of this gets like sampled at the beginning of this state tree running. And that's going to be just when this thing decides to take its turn. It's going to run all of this in a split second. And then the state tree is going to be done. And it will reset with all new relevant information the next time this thing runs. So all should be well with that. The question is, can we hook this up to multiple things at once? Yes. Sometimes it's a little bit weird with that, with output pins. I never can remember which ones it likes doing that with and which ones it doesn't. But now that should also, well, actually we do need to set these as outputs. And then we should also have access to these 3 as outputs. So we can get player ref1, and then kind of just like copy over. Copy over the entire tasks list? We can't. We can copy over the entire task though. That should be no problem, right? No, we can't. Okay. I guess we just put in new runability, attack on player 2. It's not that difficult to do, I suppose. Runability, ability, attack, and we do 3rd one there. Then for all of these, we also want to add a transition. State is complete. We want to succeed the tree because we need the tree to actually stop running so that when we rerun it, it actually does the evaluator thing all over again. Otherwise, it's going to get stuck in one of these states, and we don't want that to be the case. So on state completed, succeed tree, and we just kind of do that in all cases. So we do that in here as well. And now we have a state tree that should pick whatever is the lowest amount of HP in the player's party with a little bit of randomness to it. Now, it's going to weigh them and select them at random. You don't really have a lot of control over what random exactly means, but essentially it's going to pick them in the same way that we pick from our data table. If you don't remember, we have this data table with encounters in it. And what we do is we add up all the weights and then we just loop through them, having generated a number in between 0 and the total weight of everything added up. And it's just going to pick one of them based on that. If you want to have some other type of selection that maybe leans more into something that you can like explicitly set up, you're going to need to do a fair bit more work. But this try select at random by weighted utilities is pretty much as good as you need it to be, most likely. So let's see if this turns any problems for us. Well, actually, they die instantly, so this is going to be a problem. Let's set there. We also do have an issue here. Set targeted, the targeted actor in set next character. I guess the targeted actor was not, well, I mean, just convert this to a validated get. This is not an important error. It's just one of those errors that sometimes it complains about. It's not going to like crash your game or anything, but it is annoying. So just like validated gets only do this node if this is valid, otherwise just move on. But yeah, let's go into our enemy actor and actually give it its HP back, and then also do the same thing for our player character. So in the ability system components, in the attributes, I think the first one was at HP actually, yes. Let's set that back to 100. And then it's a good idea to also do that for our player, because that also doesn't have a lot of HP anymore, I don't think. Yeah, that's also at 10. So let's set that to 100 as well. And now, it's going to be kind of difficult to test this, obviously, because there is a degree of randomness to this. But if we just attack, we will see that at some points it's going to attack me. And what's likely going to happen, statistically speaking, is the first one of the enemies is going to attack. That's going to lower the HP of one of my characters, which means that it's going to be more likely to get hit by the next one as well. So I'm not saying that this is necessarily a great way to program your AI to just only take, hey, whoever is closest to death, let's pile onto that one, because that's generally a pretty good strategy in these turn-based like team versus team games. But it's such a good strategy that maybe it's a little annoying if the AI does that as well, which is why we introduced a little bit of randomness. Anyway, let's see what they do with their turns. This one attacks none of us at all, which means that the targeting probably wasn't successful. If I had to take a guess. So let's open up the debugger here, and I'll put that on my second monitor. And if there's anything important on it, I will show you. Turns out it's quite important to go into the stage tree component here and actually make it run the basic AI tree, and then don't start logic automatically. We only wanted to explicitly start when the turn for this thing starts. So yeah, without that, it's not going to be able to do anything because it won't be getting any commands to actually do any attacks. So let's try that again. This time with them having their stage tree component. We'll see. It's his turn now, and he attacks the bottom one. And the next one also attacked the bottom one. Statistically, that is what they should do. And from this point onward, they are very likely to only attack the bottom one, and the less HP he has, the bigger the chance of attacking the bottom one becomes. So, you see, there's a little bit of randomness to it because they now both attacked the top one. So, if we just look through the HP that my characters all have, you see that he has the same amount of like percentage HP as the bottom one. The middle one has a little bit more. So they will share the likelihood of being attacked. But again, it is random, so they can attack anything that they like seem like they want to attack at any given time. But now it attacked the top and the middle, it seems. So yeah, we pretty much have a little bit of randomness to it. Now, we do want to make sure that when they have 0 HP, that they don't get attacked. So what we do for that is actually we go into these utilities before I forget. And there we set the response curve, add one more key to it. So add a key to the curve. And we're going to set this time to being like 0.001. And that'll be a value of 1. And then we can zoom in a little bit or a lot. And now once we have zoomed in, we pick this extra key that we have here. And that is at time 0, so at HP 0. We actually want him to have like exactly 0 chance of choosing this. This will have a built-in functionality of it not choosing things that are almost dead. As long as they don't have like 10,000 HP and they're at 1 HP, of course, because this is everything under like 0.001% HP. So with this, it might make more sense to actually set this up with absolute values, so that we just check, hey, if you're under 1 HP, because you're not going to ever be between 0 HP and 1 HP most likely. So if you're under 1 HP, we don't attack you. But for now, since we're doing this on percentages, just adding a couple more zeros in here also like doesn't hurt. Well, actually, we can only do that up till 2 zeros, it seems. So that's all that we're going to get. Again, won't be a problem until you have a absolute shit ton of HP, or if you allow decimal points of HP to begin with, which I don't think you really want to do for the most part. So let's just copy over this curve to these other places as well, just to prevent it from targeting something that has 0 HP. Of course, we could make a different extra consideration here for the utility, where we set this float input and add that to there. So by default, this becomes AND, so it checks both of them. We can make a separate consideration here that just takes the absolute value of the HP and just checks, hey, is it at 0? And if you keep this at AND, it will take that into consideration as well. And if it is at 0, this AND is always going to fail. So it's going to return this as 0, which is a little bit more of an evolved way to set that up. But it's a way that you could do. For the most part, again, making your response curve just kind of look like this is a pretty good, quick, hacky way to get a pretty similar result. So with that, we have a basic setup. Again, from here on out, how you set up your AI is so heavily dependent on how you actually make your specific game. That there's very little use in me actually diving super deep into that for this tutorial series. What I will be doing is I will be using this same system to make a turn-based RPG section in my own game. And after I've pretty much C++ recreated this entire system, I will probably be streaming setting up some AIs for those characters, for that little section of my game. So by the time this goes live, we might have started doing that. We might do that in the future. You can check on the channel. If YouTube's algorithm is doing its job, it might even be in your recommended right now. And you can see me working on actual AI with a broader context that have more abilities in real time. Which means that it's also very much less prepared than the rest of this series, but if you really want to see like more in-depth development of these AI like behaviors for your turn-based characters, that's probably the best thing that you're going to get out of me from that. But for now, I do think that that means we have finished the turn-based RPG project. So once again, thanks everybody for watching all the way through this. This is probably one of my longest series to date, if I had to guess. I don't know, I still have to edit like half of it. The project files for every individual video, as well as the finished project files as they are now, well, I'll probably go through and like add some comments to some places, because especially the battle scene is a bit of a mess. But the finished project files with hopefully everything slightly more commented will also be available for YouTube members and Patreons. I always do this spiel at the end of every video. I just figured I would shout it out a little bit extra here, because this has been a very big project, and those Patreons and those YouTube members do go a long way to support me being able to like invest all of the time that it takes to like pre-develop this and then go through the entire thing to record and edit it as well. For now though, I will leave you with a finished project and we'll start coming up with whatever the hell I'm going to do next. And a very big thank you to all my Patreons. You can see them on screen right now. If you want to help support the channel or get any of the project files in any of my tutorials, there's a link down below to the Patreon page to support me, or alternatively as a YouTube member. And a huge thank you to my Cave Big Brain tier supporters, which care more for coding than impulse control: Earl, Monserville Erno, my Cave Students tier supporters, Paul Berry and Oiku, and my Cave Digger tier supporters, Mauricio Farias.